It's late at night. It's late at night for us in Europe.
Maybe you've been on the tap for too long.
meters, everybody spread around.
No, you know all of the people that were here yesterday.
Yeah.
It's actually only Paul
Okay.
is here again,
Okay.
and he didn't meet Wednesday.
Okay.
And Stephen wanted just to update with the resetting so everybody knows how to use resettings.
Okay.
And then I could call him and so forth. That's the main reason for meeting.
Okay. Are you in this room? Oh, you're in the 1-8.
No, actually, today, not sure yet.
Okay.
I wouldn't mind doing this one, I actually like to do this one,
Okay.
because I've done the two small ones.
Yeah.
And
Okay.
this one is
Okay.
and the first day gig was Gabriel.
Have you been trying? Have you been trying to listen to what they're saying up front?
Yeah.
Do you understand any of it?
But the beginning was like,
No.
nothing,
Okay.
no word.
Yeah.
And now I'm starting to understand some of the names of the
Things or what?
programming
Okay.
programs or
Yeah.
plugins. I really forget what,
Yeah.
just some terms and I'm starting to pick up a bit of.
Okay.
I think I don't know if I really understand it or not.
Okay.
I think it's interesting.
Yeah.
And you?
It's interesting to see the kind of things that they care about,
Yeah.
the kind of things that are relevant to them. Now, I don't know, I think the problem is that here these talks are very almost hardware specific. So if you don't know to understand the hardware, it doesn't really mean much.
Good morning. We did, yes. No, I didn't. And I'm glad we took the earlier train. Yeah, it was still kind of late. And oh my
Very
God,
fine.
my house, I'm so sorry.
In 8 minutes, we should all go to our rooms. Hi. Good morning. Nice to see you again.
I'm Paul, by the way.
Oh, yeah, right, sorry.
Hi.
How
Hey, Brooke.
Hi, I'm Steven.
I think I've seen you before.
On to the new training program.
How are you, Steve?
Cool, we do well. I think. Is this everybody?
Yeah.
Yeah.
So, yeah.
Yes, it actually went pretty well. Not a whole ton of issues besides the normal ones with said trackings. I went through and repaired stuff this morning. In all the rooms, the head should be on, connected to the iPads, with one beacon on and connected. It's just sitting on the charger, so whatever one has the light on, the light on, that's the one that can go to the catch box. And then, yeah, I sent a video in the chat yesterday to make sure when we change beacons, it seems to work better if we turn on a new one, hit follow in the iPad before we turn off the old beacon. Because the heads, when you first connect the beacon, they need to be aligned to the back. Or when you connect to a watch, they need to be aligned to the back beacon. And they seem to get off over time. So I'm going to start noticing they get too far off during a break. If we turn off all the beacons, turn off all the watches, move the head where it's centered in the back beacon, which is on that music stand with the wide camera. And zoom in, kind of center the screen-ish, then turn on a beacon. That should be centered. That's good. Make sure we're talking starting between presenters. I guess we knew about that yesterday, so it's good. This makes our life. Thanks for editing. with remote presenters that the house front mic was picking them up because the gate wasn't properly set on their boards. So if that happens, you can let us know, and if you take a listen, if it's only a remote presenter, you can, most of you know what toggling vmix is to drag down the audio. I'm going to show you just to make sure. So the in-house, where we get audio from, is this F8, and it's this input here, audio 1+2. Definitely make sure you don't click any of these M, A, or B buttons. That's how audio is routed through Big Blue and everything. But if you have a remote presenter or like a dual setup, and if you listen to the headphones, and if you're noticing the online presenter echoing in the headphones, it's most likely because that front mic is picking it up because the gate isn't properly set, which is, we've tried. But so if you're talking a lot, then you can drag this. So just pay attention to that. If you bring it down for a remote presenter, if it's echoing, just please make sure it's back up when someone starts talking.
So that is audio 1 and 2 is the front mic.
It's all audio from the house.
Okay.
So it's the front mic, the catch box, any audio from from in here.
I see.
So if anyone's talking in here, then we need to make sure that's up.
Mm-hmm.
It only happened a few times yesterday in a couple other rooms, but just so you guys know. But all that looks good. I think I made sure every one of these is on shared notes, which they want. And then if they have a lot of notes, they've asked us to scroll down for it. So once it gets filled up, if you can scroll down. Cool, what you guys have been doing.
Oh, okay.
And then, any other questions or points, comments, suggestions, long rooms? When you guys go to your rooms, if you could just double check that we're streaming. This looks like this.
Ah, yeah.
And then that the Zoom is recording, or that the F8 is recording. I think I triggered them all. And if it's not, let me know. But it should have the red light on and like a red countdown in the top left corner. Make sure that's recording. And then once you guys get to your rooms, we can go ahead and hit record to not miss anything. And then if you guys can start the cameras in the room, start record. So just hit record, and then the front one too, there's a button.
So the front one can also do over there.
Yep.
Yeah.
You're 100% right. Front one, if it's connected, you can do it from the iPad.
You mean
Yeah.
this camera, the photo?
Yeah, the photo camera. Yeah, you can
Because
record.
that one is anyway.
That one doesn't record. Yeah, that just gets brought in. So that one's recorded. Record. So then everything should look like that. Cool.
I have one question.
Yeah.
Not a technical one, but Jonas sent in a document, like the contract,
Yeah.
basically. But I also got one over email from Tim.
Yeah.
Is that the same thing?
It should be the same thing.
Okay, because I already filled that out. Because I wasn't sure if the others also got it over email or not.
Probably. Did you
We
get
did.
an email too?
Yes, yeah.
Oh, no.
Okay, that's all I wanted to ask.
Perfect.
I have another question.
Yeah.
So this record button,
Yeah.
when do I press it? Like I press it now in the morning and
And let it go.
I
all
let
day.
it go.
Yep.
Okay.
Yeah. So,
So this we have to press before we start.
yeah. As soon as you go to your rooms, which we'll go here now after starting 10 minutes, then hit record on there. That starts the recording on the front camera,
Okay.
and then hit record on the wide. Those go all day. Those are just our
So
backup
not-
safety net.
Not on the camera, we have to hit record, or also?
It's the same. It's connected to it.
Okay.
So if the iPad is connected, then you can do it on.
Oh, okay.
And if your iPad's not connected for some reason, they all were 20 minutes ago, then you can reconnect it.
Good.
And then you have to start and stop with that. You can go all day. Same thing.
Yeah.
Good
Thank
luck.
you.
Where should I
Great.
go? Which room?
I would love to do this room, but it doesn't matter. Where were you? Were you here?
No, it was in 116.
Okay, who was in this room? Oh, I forgot.
131?
Only if someone was in L. I don't know if anyone's in an L group here.
I think Sydney is already in L, too,
Yeah.
because that one started at 9.
And L3 also starts there.
You're L1,
It's
right?
the combined.
Oh, okay.
Yeah.
Then everybody else is saying like that.
So I do 185.
Perfect, thank you. Right, let's go ahead and change the survey. Just actually have to get rid of this, that's all. You're like, ah, you put bells. Alright, I'll take this one.
It's not so different, but
Right. So the team of this room, which actually pretty good. The camera has been temperamental. This is N2, yeah. The tracking has been temperamental. I had to reset everything twice already, like repair all the beacons and everything. And it's currently, it was currently still following, but then it got a little temperamental of like jittering, so just pay attention to that.
so half an hour break, and then squeeze it.
Yeah. We'll realign it, realign it.
With,
I tried multiple times to get this one to work, but if, look, you're really not getting to it without position sensitive, but,
I've only used 2 anyway.
yeah, yeah. We were last setup, we had 2 catch boxes, and so we had 2 earmuffs out there all the time, so that's why we needed 4, and then it was more of a thing, this is back and forth on the iPad, so you gotta like label the catch boxes, you know, like pay attention if he was talking about one, it was one catch box, way easier, way better. But that 4 was kind of after looking at, after we set everything up, they're like, this could be the setup all for it. There we go. Alright, cool, we'll start recording.
Thanks.
Thank
See you later.
Tests that cover multiple systems, you need to make sure that it supports putting them both or having a pointer. So one of the other side.
So that brings the idea of, possibilities to also, because what we're really saying is that this thing that we put together shouldn't really be
I guess what we want to do is boil down bare minimum information you want. Right? Now, what is the minimum set of information I need to understand what this thing is?
Oh, for crying out loud, this hasn't joined yet.
Here's the catch box.
Okay, thank you.
Need it?
Okay, thanks.
Peter, not your still this one.
Same old, same old.
Hello there. Hey. Just wanna set up BBB for you.
It looks like you know what you're doing.
Sorry?
It looks like you know what you're doing.
Perfect.
I'm very happy with what you've done.
Oh shit.
Wait, oh, are you about to load the presentation?
Yeah. I see that no.
Okay.
There are no
I
presentation.
just took presenter, but you took it back, so go ahead and
Oh.
do whatever you're gonna do.
Okay. I don't have. Do you have the PDFs with you?
What?
Do you have the PDFs with you? In this
I
machine?
don't have for this session, no. I have mine though. So
Okay.
if you have all of them.
No, I don't have it all. But we can.
Let me at least get mine up.
Yeah. Sure. Go ahead. So you are the first one anyway, right?
Right, yeah.
Okay. I'm gonna download the rest here.
I'm Satmari. How are you?
Good.
Good to see you too. Good talk to you too.
So mine's up. If you wanna take presenter and get some others up. I don't know how much.
Okay, I'll take back. But yeah, it's very, very slow.
Yeah, very strangers to add some notes here. I couldn't give them too much.
I mean, I think the RC, the Kirkstone in terms of what's passing, what's failed,
Appropriate
what's
facsimile
gaps.
of being like.
I didn't include that.
Let's see.
Does that,
Well,
does that paper like there with the board? Will that work for the extra?
no.
It should. Just need the right string.
I'm just helping.
I think that's gonna be very different. I mean, I would expect it to be bigger.
It was.
Smaller.
No.
I'll sure you can find it. So if we're doing the RC.
One that had some jam and some toast.
And then
Just get the, up to the break and then
So the only bad thing is there's metrics, but you have trying to design up the execution.
Okay, Chin, you are at the benchmark results, right? This is yours, right? Your presentation is adding benchmark results. Okay.
got an external video. Got it down.
Do you need a minute still?
What?
Do you need a minute to correct everything?
No, I'm trying to decide. I'm gonna get the-
So I think we have everyone here. So some presentations had a generic name, so I changed for the presenter name. Okay, Nicholas Ellen. So I think we are good.
Awesome. Thank you. Do you want to do the intro?
Yes.
Do the intro? You got it?
I don't know, yeah, I was trying to get the notes working, but the internet is working.
Oh, they have it. Thanks, sponsors and shit. For being here with a mic. Good luck.
What's happening?
How are you?
Ready? Good morning, everyone. It's good to see a few early birds, including Tim Bird this morning. For us this morning. I don't think there's anything too special to mention, although that the connection is very slow, so we'll try to add some notes here. We'll have a virtual talk after the break. Hopefully it will be working. Yeah, I don't think there's anything too special to add about this. I guess we've been doing this for several times now. If you want to ask a question, raise your hand and we'll give you the catch box with the microphone. And yeah, thank you to all our sponsors.
You should flip through the hand.
Sorry? Yeah, we need to go through this, yeah. So, a bit, I suppose you've already read this before, but we need to mention it again, that the anti-harassment policy has to be followed. And that's when we'll be on a break, but we're not on a break. Okay, so... yes.
That's it. Yeah, that's right.
Okay, up to you, Tim.
Good morning, everyone. Thank you for showing up relatively early. I'm going to talk about a subject that is near and dear to my heart, adding benchmark results support to KTAP. And I'll just get right into it. I like to throw the abstract into the slides just so when people download it later, they have kind of a summary. I'm going to skip that. So what I want to do is just go really quickly through kind of how are benchmarks used today, and then talk about how that presents some problems for test automation. And I have a proposed solution, and we'll see how the demonstration goes. I actually have it pre-recorded, so it should at least go as well as my recording. And then I'd like to talk through some issues and kind of get your opinion on things. So how are benchmarks used today? Well, mostly it's a human, in terms of actually getting test results that are fed back into the development process, it's a very human-oriented process, right? A human knows what the benchmark value should be for their machine. And in particular, they also kind of know what variance is allowed, right? If you're doing a storage benchmark, you get a certain number, and you kind of know, well, it might not be that exact number, but if it's close enough, it's like, well, what is close enough? So the tester then runs the benchmark, examines the results manually, and then determines if the performance has regressed on their hardware. And that's actually kind of a key problem for doing this at scale in the community. The tester reports a bug, and then if something changes, something like the software changes, or the hardware, the configuration settings, or even the workload, then the tester relearns what the threshold values are, and what the variances are for that new situation. So it's not only a manual process, but it's a manual process that's ongoing, right? So it's very hard to automate. The rationale for supporting benchmark data is there's a whole set of features in the kernel that we don't actually, that get tested, but not with the same kind of rigor that we use for testing functionality, right? So we have K-self-test, we have K-unit that are testing very specific features, either of individual functions within the kernel or individual features. But we're not, and people run tests of performance and they look at it, but it's all a manual process. We're not doing it in in kind of a rigorous way. And so in order to do this, what we have to do is we have to find a way to convert that numeric data that we're getting back from benchmarks. And here I'm using the term benchmark in a very general way. Basically anything that can return you a number instead of pass-fail, I consider to be a benchmark. So that could be something like CPU utilization, right? You may want to see that go above a certain amount. It could be things like latencies, Okay, so anything that's returning a number. So you have to convert that into a pass-fail. And the normal way this is done is with what I'm calling a reference value. So a reference value represents that threshold that is used to determine whether the test has passed or failed. So this may include some delta, some wiggle room for variance. But the main thing, in order to do this at scale, I believe that you have to keep those reference values separate from the test itself. They have to be kept outside the test. But that raises a lot of issues. And issues that so far, I mean, we've been doing, I first started working on a test lab for the Linux kernel in like 2006. And we've been actually maybe even before then. So it's been over 20 years we've tried to do testing for the kernel, and we've never cracked the nut on how to do performance testing at scale. So what happens when we try to keep those reference values separate from the test itself? So it makes, if you don't keep them separate, right, it makes the test specific to one situation. And that means that you can't share the test. If you've got the reference values encoded into the test itself, you can't just give that to another developer, right? So the storage numbers I'm going to get back on my Raspberry Pi or my BeagleBone or some other embedded development board, they're not going to match the performance numbers on, you know, the top 500 CPU supercomputers. And so as the other thing about this is it's not just a difference between machines, it's a difference in time. Over time, the numbers are going to change, and you actually want to adapt those numbers. And so having them if you encode the numbers into the test themselves, then you're constantly having to change the test. And that's undesirable. It just doesn't scale. So, but here's some of the issues that crop up, okay? So if you're keeping these reference values separate from the test, where are you going to store them? Can you store them upstream? And I would argue you probably can't. Or maybe you can store some, well, there's certain situations. This is the discussion I want to have. What format are you going to use for those reference values to kind of make it so that it's a standard across the industry? And then how do you determine at runtime what the mapping is from your test environment to the set of reference values you're going to use? So you're going to have multiple sets of reference values. Like I said, you're going to have some for BeagleBone. You're going to have some for, you know, a high-end Intel machine. You're going to have different ones for a server. So where are they stored? How do you make sure that when you're running detecting your regressions based on those reference values, that you're picking up the right file? And how are they generated, right? So there's still a human in the process that has to look at those numbers and determine, you know, what is the actual number you want, right? And that's not an easy process, right? So one of the most challenging things as a tester is, you know, you run. This happened all the time with LTP. It was invariably when you're running a Linux test project, a couple of things fail, and you always go, well, is that okay? Was that supposed to fail? Was that expected? So I have a proposal, and I think it's a pretty simple proposal, but it consists of these parts. So I want to add just a couple of tweaks to KTAP to support expressing numeric values into KTAP, and I'll talk about the details here in a second. I want to have a collection of reference values defined somewhere, to be determined, and that can be used with benchmark results. And we also need criteria, and for interpreting those test result values. And I'll talk about the rationale for that. And then you need an actual tool that can do that conversion, right? Can take the numeric results, convert it into pass-fail, or in the case of KTAP, okay, not okay lines. And then optionally, I've also written, just barely gotten started with a tool that helps you manage reference values, right? That allows you to look at past results and say, well, you know, what do I want to use to update the reference values that I'm working with? So these are the different system objects. This is kind of a repeat of the last slide, but the actual test results in KTAP format are what we're going to be working with. We're going to have reference value files, so files that contain numbers that we're comparing against. And then we're going to have a set of rules for applying those values that we receive versus the reference values. And the reason that you have a separate file for that is because the sense of the operation, like are you doing a less than, are you doing a greater than, are you doing an equals, so that has to change depending on the type of thing you're doing. And this is intended to be a generalized system. And then the final thing is the actual results evaluation tool. So the tool that will make those inferences. Okay, so here's what I'm proposing for KTAP syntax extensions. I have just two simple extensions, and these are backwards compatible. A new line or a new syntax for value output to indicate value output, and an undetermined test case result. And I'll talk about that in a second. So the first one, the value output is very simple. Again, I feel like it's almost so simple that it's like, you know, why do we even need to talk about it? But I'm sure there'll be people who disagree. So the value line starts with the word value. It has a value identifier, an equal sign, a numeric part, and then the units, and then there's actually an optional comment on that line. And then, for reasons that I'll explain in just a second, it's important to have an undetermined outcome result. And so I want to actually add to the set of things that you can put at the front of a KTAP line, we've got OK and not OK, and I want to add unknown to that. And this will indicate data that has not yet been, or a test case that has not yet been analyzed, has not yet been processed. And the reason for that, I'll explain in a second. So the reference values themselves, I'm proposing that they be kept in a standalone file. They can also be embedded inside the criteria rules, but they also have the exact same syntax as the KTAP line. So it's just value, some value identifier equals, and number in units. The reference values files would consist of just a set of lines. So these are greppable. The file names, I would recommend reflect the test name, machine identifier, or environment. So you'll be able to identify, just by looking at a directory of files, which reference file might apply to your environment. So for instance, the file name might include Raspberry Pi or BeagleBone, or, and I'll show some more examples of that. In the future, we might want to talk about more complex systems like that include metadata for more advanced matching, but I think that's beyond the scope of this presentation. The test criteria, this is probably a new concept that if you haven't been working with this, maybe you haven't thought about. This is the actual rule for evaluating the test result versus the reference file. And the reason you need this is, again, because you have different operations that you have to perform. Like I said, the operation could be a less than, it could be a greater than. The other thing is that the criteria can include, since it includes the units, it allows you to do unit conversions. So if you're getting a test that has a reference value in gigabits per second, but your test returns megabits per second, that you can detect that difference and either automatically convert it or warn the user that something's off. So this is what one of these lines look like. If IO4K write speed is less than 90 megabits per second plus or minus 5%, then IO4K write equals not okay. Okay, so that actually should be fairly human readable, right? It should just look like an if-then conditional that explains, you know, what the outcome is going to be based on that comparison. Okay, so then we have the results evaluation tool, and that's a tool that actually performs the evaluation. It's very, again, it's so simple, it's not a lot of lines of code, but it basically, so the trick here though is that it does have two modes of operation. So you've got a mode of operation where you can perform the evaluation actually during the test, and it has a post-processing mode where you can perform the evaluation after the results have been produced. So let's look at those two. In during test mode, the test will actually, as it receives a numeric value, as the benchmark or whatever is measuring this device under test receives an individual value, it will pass that to either a library or a program that can then read the reference file, read the criteria rule, perform the evaluation, and produce the outcome. So that's very straightforward. However, okay, so this is good because it allows the test to provide everything that it used to. It allows it to indicate the outcome immediately along with the test results. The bad thing, though, is that this requires that your benchmark understands the whole criteria system. You have to introduce a new system call or a new function exec to an external program. And a lot of you would not be able to support existing benchmarks this way. Only tests that were already aware of the criteria system would be able to use the during test method. The other way that you can, and the results processing flow. So this slide is almost too obvious to have to read, but basically if you had this value that you got back, and this reference value of 90 megabytes, this criteria rule, and then you called, in this case the function is an external program that's in Python called process results, and you give it the value for the expression value, and you have to refer to the reference file and the criteria file, then you actually get the line that you can put in your KTAP results. Okay, so that's that final line there, not OK 12 IO 4K sequential read. The other mode you can do is in post-processing mode, and this would apply for other tests that are not aware of this whole system. What happens in this case is you would produce, the benchmark can produce a set of values, and if it's at least marginally aware, it can also indicate that it has unknown test case outcomes. It's not required, right? You can write a wrapper that will just take the values from an existing benchmark and annotate the test case results. But then what happens is you use process results as a post-processor. So this reads the test output, the value lines out of that output, reads the reference files and criteria, and then writes new test output and provides new outcome lines. Now this is pretty easy to do. The good thing about this is it does not require that tests know anything about this system. But it does present a problem that you might have unknown outcomes in your test results temporarily. So you can't do things like counting at the time of the test. So the classic line at the bottom of your test that says, oh, I had this many successes, this many fails, you'd have to either add an unknown thing or just omit those or update those in the results once the actual tally of results is known. That's usually not a problem because any benchmark that doesn't already know about this system is not producing that set of numbers anyway, right? There's no benchmark that says, oh yeah, 5 of your performance tests failed, right? It doesn't have a count because it doesn't even have the notion of test case outcomes. Okay, so so in this example, the tool, the benchmark itself would produce this top box here, value IO4K sequential read speed is 78 megabits, megabytes, and then it would just say unknown, and then it just converts that to a not OK. So post-processing, pretty simple process. So now I have a demonstration. So these tools actually exist. And this will require that I go to a YouTube thing. I didn't want to do this live because that is fraught with peril. But I'm going to try to share an external video. And this unfortunately requires that I'm going to be accurate on typing a YouTube URL, which is as I'm sure you're aware, is not a X. All kinds of capitals and lowercase. Let's see. Hopefully I typed that correctly. Okay, and then So there should be sound on this. If there's not, I'll just tell you what's going on. So this is a DDIO test. This is just a small wrapper around DD, the DD command, which runs a bunch of block operations. This is testing a flash drive and a spinning drive. Notice that this is just a wrapper around DD, so it's not DD itself, but it produces these value lines with unknown test case results. And then what I'm going to show you here is a directory full of reference values and a criteria file. So notice I have reference values for a bunch of different machines in my lab. I've got one for TimDesk. I'm going to show you the contents of that. TimDesk happens to be my desktop machine. And look, it's very simple. It's just a bunch of, these are the threshold values that I'm expecting to see as outcome for what it should be. Notice, and then I think the next thing I'm going to show is the criteria file. I use wildcards a lot to. This has got a very simple criteria, and I'm using a wildcard. I hope I have enough time to just finish. Where is it? Yeah, we can open up for questions now.
I have one.
And this should go back to my presentation. What happened? Oh, do I have to stop the video? Yeah, stop the video. And no, share. Should be presentation, not screen. Well, I don't know what I'm doing with this, but anyway, okay. So we're very limited time. I'm sorry, I had way too many slides for what's supposed to be a motor discussion oriented, but go ahead.
So my question is, wouldn't it be useful to encode just the comparison sign of the criteria into the tab as well? So like assuming that someone wants to just use the output format that you're proposing, without the evaluation side, all the storage?
Right.
Can we say like min, max, exact
I've
in the
actually been
output?
thinking a lot about that, right? Because I've written several different rules now, and sorry. Yeah, I'll switch, please. Yeah, I've thought a lot about that. I've written several criteria evaluation rules to see if that needs to be abstracted. Every single time, it's the end thing is not okay, so I'm not sure that that's really necessary to specify that. So I may have put in more flexibility than is needed. Systems that I've worked with before, in particular Fuego, only have the operator. I do think, though, that the units is useful, and I've added flexibility that you can have the value identifier and the test case identifier don't have to match. So the reason to have like kind of a fully fledged conditional rule there is that you may have a mismatch between the name of the value that you're looking at and the actual test case result name. So there's a difference there that you have to account for.
I was hoping that we can basically create a system which, like, based on the previous runs, we can also evaluate. So without the criteria, without explicitly storing the results like somewhere, we just have a database of old results, and then if we know that
So I have a tool that looks at old results. So this is the other really huge thing about doing this. A lot of times your reference values come from a prior run, a known okay run, right? And so, but that means you have to have a database of the runs somewhere. So if you use past results as your reference values, which is a perfectly valid thing to do, you still have to have this external file that you're referring to, and you have to know where the collection is. So the reason that I made the KTAP value lines the identical syntax as the reference value files is that you can do that. You can actually just put a symlink, say, I want to refer to Tuesday's run, or I want to refer to the 611 run of the kernel, and have that be the reference values, and the system works as is. So yes, and then I also wrote a tool that I didn't have time to discuss today that allows you to look at, if you have this database of past results, you can look at it and it will show you like the averages, min, max, and standard deviation, and z-score, and a bunch of statistics, so that allows a human to pick reference values that kind of match your data, right? You run your tool several times or over several versions, and you start to get a feel as a human for what the value is. Again, a human has to be picking the reference values, because there's just too much. A human knows what is a good run versus a bad run, or they should. That's kind of your job as a tester. So. Yeah, I'm out of time. I would love to talk to more people about this. There'll be patches coming to the list soon. And I really want to get more feedback on this. As I really don't want to standardize something prematurely, right? I don't want to get it into like the KTAP documentation or put the parser upstream until I've heard feedback and gotten more information. So anyway, thank you very much. Yeah, I can switch to the next one.
Yes. No, I'll keep it very simple. Okay, good morning everyone. I'll keep this relatively quick so we can get back to talking about Tim's very interesting proposal in the remaining 5 minutes at the end. I'm David. I'm going to be talking about whether we want to run K-unit tests even more in user space than they already do. Few people have expressed that that's something they'd like, so let's have a little bit of an overview of that. I've got slides saying what K-unit is, but everyone I think in this room's got a pretty good idea, so you can look at those on your own time if you want to, or that. Equally, there are lots of new things in K-unit over the last year. Have a look at that, come and talk to me later if any of them particularly interest you. But what we're going to talk about now is, why we might want to run K-unit tests as standalone user space binaries, and what are the upsides, downsides, how do we want to do this if we want to do this. So why basically testing things in kernel space is annoying. The kernel is big, all of the tools that exist for user space tend to be a little bit both simpler, B, more widely understood than kernel space ones. Most people would rather just use GDB than having to set up, KGDB, etc. Building an entire kernel and then booting an entire kernel to test your one function or your one small data structure is kind of overkill. Takes a long time. No one wants to wait for everything to happen. And when you're debugging it, you've got all of these other things happening in the background to keep the kernel running. You've got, weird signals happening. You've got all sorts of exciting things, huge amounts of code it takes GDB to load in, parse symbols. Better not to do it. And then if we're taking code and sharing it with other people, like we've found a bug in the compiler, and want to send it to the compiler people, they'd much rather a reproducible case that's like one C file than the entire kernel and a bunch of complicated configs. And finally, there are user space tools in the kernel tree. Maybe we'd like to be able to test those too, ideally using something similar to we're testing all of the other code in the kernel tree. So what sort of things are this useful for? Library code, which is a recurring theme in K-unit talks, basically data structures, helper functions, parsers, self-contained or heavily abstracted things. These are the best things for unit tests in general, and they work very well as totally isolated, often don't need to call into other kernel functions. And a couple of examples, the rosebush data structure that was posted to the list, the core VMA manipulation function refactoring, both have, let's write tests and run them as separate user space binaries, often by, here's a header which implements a basic unit testing framework heavily inspired by K-unit and others. As mentioned, if we want to share code between the kernel and something else, we need something that works both in the kernel and user space, whether that's an external library or whether that's some piece of code within the kernel tree. Tools in the kernel tree, Perf has its own unit test framework, which is inspired by K-unit but isn't K-unit. It would be nice to just be able to use the same thing for both. And there are tests that we want to share with people outside the kernel community. I mentioned the compiler bug example. There are tests specifically for compiler-based hardening features and that, where this is a real aim. When Case originally posted the stack init K-unit test to check stack initialization, it also had custom implementation of K-unit in a header so that we could easily give it to compiler folks. So that's several reasons why we might want to do this. there are several things that might already do it, like the obvious question, why don't we just use a k-self-test? They already run in user space. And maybe that's the right answer. So, we've already got a way of having tests written in user space, but k-self-test doesn't have quite the same variety of features specifically for unit testing that k-unit does. Equally, things like resource management stuff, the parameterized test features, you can implement those on k-self-test, and maybe we should bring some of those features to k-self-test. But k-unit already has these in a simple way. K-self-test also really philosophically is more aimed at let's write tests that test the kernel we're running under. It's not a hard and fast rule, but that's something that people tend to think of when they think of k-self-test. So this is philosophically perhaps a slightly different thing. And similarly, tools like perf, aren't really the running kernel. Equally, why don't we just grab one of the many fine C and or C++ unit testing frameworks that exist in the world and use that? That again is a good idea. We don't want to have to reinvent something. These are widely known and used outside the kernel community. But, much like with other things, we can't just reuse the exact same test in kernel mode and user mode. If we've got, a data structure or one of these, tests that prods compiler things, ideally we can build the same test and build it into the kernel and run it as part of a running kernel or as a separate binary, which means we need to use the same framework. And while I think the FreeBSD folks have experimented with putting an off-the-shelf unit testing framework into the kernel, we have gone down a different path with KUnit. And of course, we'd then have two unit testing frameworks to deal with, two implementations living in the same tree. Why don't we just use UML, user mode Linux? We're already doing this, and that's both the advantage and the disadvantage. We don't get any new advantages from this because it's already what we're doing. So, if this is all we want, we can go home straight away. But equally, it's got some disadvantages. It only works on x86 and x86-64, which kernel developers didn't mind quite as much, 10 years ago compared to now. But and if anyone wants to port UML to ARM, they have, my eternal gratitude. But it's also not lightweight. It still have to build an entire kernel. You still have to wait for it to boot. If you're debugging it, you still have to deal with a lot of weirdness because UML is made of very interesting hacks. And, God forbid you do something like this for, testing perf or tools. You don't want to suddenly add a kernel where there wasn't one before. How could we go about doing this? The obvious super simple implementation is what everyone's sort of already done where they've needed this, is make a header that implements the bare minimum unit test framework you need, define kunit log printf, just absolutely the most simple thing you could do, have the assertions there, behind an if def or a command line flag, build that instead. This is super simple. For simple tests it works very well. People are already doing it, and it would be a great idea to take what people are already playing with and have one standardized implementation. But you lose a lot of features doing this super simple thing, and we end up rewriting everything. And it could be more interesting if you're dealing with bigger tests that span multiple files, just forcing an include in one spot, a bit hacky there. We could refactor kunit to add a user space backend as well as a kernel backend. Find all the bits where it calls into actual kernel functions and, find a way of splitting those off so we can either have user space implementations of those as well, where that makes sense, or if it doesn't make sense, there's a kunit feature that's really heavily integrated with the kernel and it doesn't make sense to have a test independently for it, we can just, carve that out and not include that in the user space version. So that's great. it'd be pretty generic. Most tests would port across very easily. You know, we'd get as many features as we can without too much effort. But, you know, it is more work than just having a single hacky header. There's, you know, a question, and there's a question with all of these of how do you want to deal with both code that runs in kernel space and code that doesn't in the same files in the same part of the tree. That's ugly. Whether we care, how we deal with it, that's a question. And working out exactly what bits we can keep and what bits we can't, and you know, who wants to actually go and refactor all of this and how much time people have is a question. Very similarly, we can try to just split KUnit up into lots of individual modules, you know, say, okay, we're making the bit that emits KTAP a library, we can use that not just from KUnit in the kernel, but from user space programs or K-self-tests or, you know, tools. Similarly, we could split the mocking stuff out into something that could be used outside the context of a KUnit test. This is a really nice idea, but, you know, there are some technical problems. All of this code depends pretty heavily on there being this struct KUnit lying around, whether it's passed in manually or whether it's implicit in the current kernel thread, and working out how we would handle that. You know, it could make things that are currently quite simple a little bit uglier in the process. There's a fair amount of coupling between different bits. And we've still got all the problems of the previous one. Someone's got to do a bunch of refactoring work, and we need to work out how we're going to deal with kernel and user space code in the same spot. So that's basically, you know, the situation. Is this useful? Where would we want things to live? You know, do we need to put a whole bunch of tooling to support user space tests in? Can we expand our tooling to do that? How do we make the decision of what should be one of these user space tests, what should be a kernel test, what should be both, can be compiled in either way, what should be a self-test? This is already a slightly fuzzy area. We have a great page of documentation of when to use each, which still manages to spawn arguments because there's no one correct way of doing this. That's a good way of wasting time if we need to argue about something. And if we are going to do something, how do we go about it? Do we start with the bare minimum header, merge all of the people doing that, and then just move on to something bigger when it actually becomes necessary? Do we go, let's go straight away and start refactoring things? Do we pull the implementation perf has of a user space thing out and rename everything KUnit? These are all options. Or do we do something entirely else? So, what do people think?
Nearly. Hi, so I implemented the VMA.c test, so this is kind of relevant to me. Maybe I'm more excited about this than many other people. But I feel like something iterative would be useful, because right now in my implementation I've done a hacky, like assert true, assert false, and it's all just, it's like the simplest possible thing. So having some like kunit.h would be really useful, I think. When I implemented it, I had to do quite a lot of specialist kind of work to make it work. So we had to like very heavily, or I had to very heavily adjust the way that the VMA functions were structured, such that we could then include like a separate header that would be the userland stubbed out version of functions. So it actually ended up being a very custom thing to do it. But I think it could be super useful for certain cases where you have like an algorithm that can be separated out. Like the VMA logic is really well suited to unit tests like that, but I think a lot of things probably aren't. So I would say it kind of takes a lot of work potentially to do this. It has to be, probably has to be case by case, but it's really glorious to have GDB and have O0 and everything works. And one thing that my colleague Liam actually, he suggested something that for us that would be really exciting is you could take some raw output from state from the kernel and import it into the userland code, and then be able to debug there, and that's hugely powerful potentially. And also, like another interesting thing is you can do things like fuzzing, and because the performance increase when running in userland is like potentially huge. So there's a lot of really fun stuff you could potentially do. But yeah, I think something iterative would be nice.
Yeah, thanks. I think you've hit on one of the great things that I didn't mention, which is, certainly this isn't going to be useful for all or even most tests which do call lots of kernel functions, but maybe we need a standard, here's a bunch of stubs for kernel functions that, simple things need, but nothing else does, which several people can share. I know I mentioned the Linux kernel library, which tried to do that by literally compiling the whole kernel in, but, a bunch of defines is better, I think.
Yeah, I mean, I think it really works for modular code better than anything else. I wrote the Maple Tree. I also use this sort of framework, but the user space stuff. But the problem I have with doing anything KUnit-wise, like I have to separate tests already because I use threading to test race conditions and RCU, so I have a dependency on user space, RCU, and threading so that my tests can run. So I have actually separated them into a module and user space, and the user space can run everything in the module, but not vice versa. So it would be nice to have something more standardized so that we can get into a framework that bots will run for me. Because a lot of the time people will say, hey, I got this patch and it breaks testing, and you're like, well, go run this thing. And like, oh, what's that? And
yeah, I think the two interesting things there are, needing things like threading and that. KUnit has very limited support for threading in the kernel. But, I don't think there's a problem with having user space only tests using something like this.
Yeah.
And ideally, you could more easily say, well, these are the ones that actually only run in user space. These are the ones that run in kernel space. The ones that can run in kernel space, we can run either. And yeah, hopefully, eventually, we'll also have tooling that, we put these user space things build them in a standard way, put them in a standard place, and we can, have a config that runs them all.
yeah, I mean, I think you need to make sure there's a way to either say this depends on having a library available for the tests in user space or something like that.
Which is, a whole other can of worms, but, something to keep in mind.
I just put it in the header since apt-get install.
So does anyone think this is a terrible idea? Does anyone want to do all of the work for me? Okay, well, this is good feedback. I think we've, definitely got, a lot of people who would find this useful. And as far as I can tell, the general view is, do this in the most iterative, simple possible way, which is my preference too, because I want to do the most minimal amount of work. Sounds good.
Okay, hello everyone. My name is Ray, and this is going to be my talk on KTAP general tooling. I mostly work on the KUnit team with David, but I also work on KTAP. Okay, I'm going to start on some background If you've worked with K-self-test or K-unit, I'm sure you know what KTAP is. But just as an overview, KTAP is the official test result format for the Linux kernel. I've linked to a specification here in the kernel docs. It's been upstream since 5.17, approximately in 2021. Tim here worked on the original specification. I've included an example here of some simple KTAP. It's simple, text-based, and it's actually based on the test anything protocol, which is TAP. So it's kernel tap or KTAP, hence the name. And then in the example, you can see there are some general components that KTAP shares. There's a version line, a test plan. That's that sort of 1.2 line. It shows the number of tests that are going to be involved. And then most importantly, there are the results lines. Those are the ones that say okay or not okay. And then there's something sort of seen as like a comment that's considered a diagnostic line. And that really shows any sort of supplemental test information. And then really importantly, KTAP allows for nested tests. So for this example, we have one test suite with 2 subtests. So that's just an overview. I find it really helpful to look at what KTAP results actually look like now. So the specification was back in 2021, but since then, it's been more and more widely used. Major frameworks have taken lots of efforts to improve the compliance to the KTAP specification. I've included some K-unit results and also some K-self-test results here. There are some slight differences, I'm sure you can tell, but really they've come a lot closer together in terms of their compliance with the KTAP spec. So here you can see K-unit maybe has some funny diagnostic lines underneath the version, and K-self-test uses hashes as indentation. But overall, they've come a long way to follow this specification. Really quickly, plugging the KTAP version 2. So I've been working on this for the past year, and I've included a compiled list of patches for KTAP v2. It's mostly ready to go, although given Tim's talk earlier, maybe there's more discussion to be had on KTAP version 2. The largest component of what we have approved right now is KTAP metadata. This was a presentation I gave last year at Plumbers. It's mainly a framework for outputting supplemental test information. So things like test speed, module name, there's a whole big list. If you're interested in this, I'm happy to talk to you after this. Or you can look it up on lore, and it's on version 4, but it has been approved. And since this is the first version after the initial specification, the method for accepting these patches is still a little bit unclear. The tentative proposal is to bring these accepted patches in via KUnit, but if anyone has any additional ideas, I'm planning on speaking to some people after this on this. Okay, and then getting into more of the heart of this presentation, KTAP tooling. So currently, we mostly have parsers. This makes a lot of sense. KTAP is kind of dense, a little hard to read, a little hard to find in output, dense kernel logs, for example. So we have everything from a variety of simple parsers that just check for okay or not okay to more complex parsers. I personally work a lot on the KUnit parser, so I've included a screenshot of the KUnit parser output. You can see that there's pretty colors. It's a little bit more of a pretty print, human readable output. But I know there are other framework-specific parsers, some not even in the kernel tree. You could consider within those parsers there are some sort of hidden features that could technically be considered additional tooling. So for example, the ability to isolate KTAP documents within the kernel log. It's simple, but it would be nice if that would be modulated out into sort of an independent feature, along with summary lines, or even this feature that I'm currently working on to compile a list of metadata from KTAP lines. Again, mostly our overall tooling are these sort of framework-specific parsers that are sort of monolithic rather than modular. Okay, so I really want to have a discussion on what the system is doing well and how could it be improved. First, for what it's doing well, I think this tooling has made the experience working with KTAP extremely better, working from it with personal experience, especially parsers. They improve my life so much. And then additionally, I think this tooling really helps to fulfill framework-specific needs because it is developed within those specific frameworks. So a K-self-test has a K-self-test feature, and you can easily add that to the parser. So I think that's what it's doing well. However, what can it be? How can it be improved? The first thing I think is that there's some redundancy here. We're not sharing any resources. So there's redundancy in code and developer efforts. So for example, if a new framework wanted to start using KTAP, they would likely look to write their own parser, which is not ideal considering we already have lots of parsers. So I think there's some redundancy in developer efforts again. Second, I think this tooling really isn't visible. There's no documentation on it. There's no central location where you can find it. I don't think people are even really aware of the extent of what the parsers are that are out there. And third, I think we can do more. I think we can expand this beyond just parsers. So Tim was mentioning some sort of benchmark tooling, but I think you could do other things. So I've considered recently adding a converter for KTAP to JSON or JUnit XML, and there's no really location for me to put those things. If I put them in the KUnit library right now, I don't think it would be visible to most kernel developers, so I think we can do more. So that brings to my proposal. So I propose a new library, which would include KTAP common tooling. This would mainly be a common parser because that is the #1 feature that I suspect people would use, but I do plan to add additional tooling as well, and the hope would be that this would be used by multiple frameworks. So sort of the objective here would be a Swiss Army knife where you have all your favorite KTAP tools in one location, and hopefully this would reduce redundancy, increase visibility of this tooling, and finally having one common library I think would help reinforce the KTAP specification. So we've had problems in the past with people agreeing on one common specification, and having one common tooling library, one common parser, I think would reinforce the specification moving forward into future versions of KTAP. So where would this be located? In a new directory called Tools Testing KTAP. It would be written in Python and a command line interface, but also ability to directly access the methods. Okay, so more specifically, what can it do? I've talked about the parser, but of course this would be my initial focus. I think I would work on this primarily at the beginning to ensure that we have one common parser. The goal of this would be to isolate and output KTAP results in sort of a pretty print, human readable format similar to what you saw in the KUnit parser. But really importantly, I think this should be compliant to both KUnit and K-self-test output as it is right now. I don't think there's any point in making a common parser that doesn't work with the current tools we are using. Okay, and then the next 4 are possible features. I'm not set on them, but I do think they would potentially be good ideas. So one would just be an isolator, super simple. You take a kernel log, you isolate where the KTAP document is, and you spit it out. It seems simple, but it would be really useful, and I end up doing this manually most of the time. So. Second would be sort of a splitter or combiner. This is slightly more confusing, so I've included a graphic here. Basically, when you're running KTAP tests, you often run KTAP, and then there's like a space and some kernel log, or you run a test and you get KTAP, and then there's a kernel log in between, and then you have like another KTAP document, sort of like this here on the left. The combiner would basically isolate them and then combine them into one sort of valid KTAP document. Often when you take these big kernel logs and you throw them into a parser, only the first one actually gets parsed correctly. And so if it was in one valid KTAP document, it just makes things easier to work with. It's a small tool, but again, these are things that I end up doing manually most of the time. Okay, and then a summarizer, that's just one of the features that are normally within parsers now, but I think it would be nice to be able to just generate a summary line. And then finally, converters. This is what I was kind of talking about before. So this would be a tool that would convert KTAP to JUnit or JSON. So it could be other formats as well. I'm open to additional ideas if anyone has one. But the idea would be you could actually use this to upload results to a CI system or something like KCIDB. Okay, so that's a lot of concepts, and because this presentation is mostly a proposal, I wanted to give you some hope that this would actually work. So I've been working on the current KUnit parser, and just with a few little tweaks, mostly to work out the indentation with the hash in K-self-test, I've taken some pretty standard K-self-test results here and input it into the parser, and as you can see, you already get some pretty nice output. I would clean it up a little bit, maybe remove the times that don't make any sense anymore, but For the most part, I think this is a pretty impressive result for relatively little work, and I imagine if I had more time and effort, this could really be polished, and we would have a common parser. Okay, wrapping up here because I definitely want to hear what people have to say about this, but some general pros and cons here. Some pros, I've spoken a little bit about these, so I'll go over them kind of fast, but frameworks would be able to share resources, and it would reduce redundancy in code. One library would reinforce the KTAP spec. KTAP tooling would be more accessible and visible, especially for new kernel developers. And I think this would incentivize new tooling because we would have one space for it. I know for me, it would encourage me to make more KTAP tooling if I had a space where I could actually add those tools. And then cons, I think this first one's going to be the biggest one. I do think it would disincentivize development of framework-specific parsers. So, for example, if K-self-test had a specific feature that they wanted to parse out, and they started using this common parser, it would make it a little bit more difficult to use that. I'm definitely not opposed to adding sort of a flag to the common parser to parse out a specific K-self-test feature or a specific K-unit feature. Or something similar, but I don't think you could add too many of those specific flags. That would be more on a case-by-case basis. But yeah, that would be the first con. Second, it's a new tooling library that we'd have to maintain outside of the current frameworks that we're already using. And then third, I think this would slow down development of parsers and similar, this common tooling, because we'd need to get more people's approval of it, and with more opinions just slows down the process a little bit more. So those are my discussions. I want to open up to questions. Where's the little box? Oh.
Okay, my first observation, I think this is a great idea. My first observation is that you could also add to your list of potential features turn it into a test itself, right? So compatibility test to make sure that output from K-self-test or K-unit is in the appropriate format, right? So if you you could validate, use it as a validator as well as.
Yeah, no, I love that idea, absolutely.
Could you put this in releases on PyPy so I can use it if I don't have a kernel tree around?
Potentially, I think it would be pretty modular, so it would just be a Python library. I imagine you could add it to release pipelines. So yeah, that's a great idea too. Keep them coming. Any other questions? You just love it. I'm so happy.
Oh. We'll have a show as well. So I think it would be really interesting just to say that the obvious thing to work out how we could use this alongside what Tim's been working on to have, use this library, build in things for dealing with tests which maybe have indeterminate results when they originally run and doing post-processing on them, which could be great. Equally, I know the existing K-unit implementation supports streaming of results, so we can start printing things out before they're completed. Would we be able to do that? And maybe if we're doing, Tim's performance testing stuff, have that as, pipe the results straight through and be automatically, dealing with that as part of it. You wouldn't need to necessarily have the tests themselves pull results in.
Yeah, one thing about the current K-unit parser is it does incremental results, so as you feed in the output, it'll produce it, and that's where those timestamps, if you remember, that's where those would come from. I think that would be possible if you did that with K-self-test too, if you had sort of a stream like that, but I haven't looked into that. But it's a really nice feature. I enjoy that in K-unit. And then, yeah, any sort of post-processing, I think this would be a good location for that. Post-processing metadata or the benchmark information, stuff like that. I want to talk more to Tim later about the unknown test result. I was interested in that.
It complicates things.
Yeah, it does a little bit.
I just said it complicates things, so it's going to mess up everybody's parser. Well, and that was, sorry, that was one of my concerns, is that if you don't get sequential test case numbers, does that throw off your parser, right? Because if you can't just ignore it as an unknown line, but then
you might get a warning, but I think it's possible.
Anyway, there's weird things that happen.
Yeah.
So regarding the format conversion, well, first of all, I think it's very important because like you're saying that you want to make it more human readable, and then I think it's also important to make it more machine readable. So are you leaning towards one format, or I know you're open to suggestions, but are you leaning towards one or the other, and for what reason?
I've already done some work on just JSON because we have a similar tool in KUnit that directly outputs our results to JSON. So I already have something kind of similar working to that already. But I've had some requests for JUnit XML. I see some nods out there. So yeah, I'm considering doing both basically as a starting point. And then if anyone has any additional framework sort of formats that they want to discuss with me afterwards, I'd be happy to look into that as well.
Okay, yeah, I think Jason, usually the complaint is like you can't comment, right? But at the same time, you already have the human readable stuff somewhere else, and then this would be more on the other side, so.
Yeah, you'd end up just making like a field for like diagnostic information in JSON, so it's the best you can do.
Oh, this is gonna be a good one. No.
So, I was just wondering when you were talking basically about the parser, to like parse that a bit crude output into something nicer. I was basically thinking that the general errors and warnings that we have in the kernel already, like when you just compile, for example, are also sometimes a bit crude. So could we maybe have like a broader effort of like a parser? So not just looking at KTAP, but looking at a broader scale?
Oh, interesting. That might go above my pay grade, but yes, I think that's a great idea. I've had some people discuss with me parsing out errors and warnings into more human readable formats, and I think that's a great idea, but we don't have any sort of specification right now for what that would look like. Yeah, I think that's a great idea. If anyone wants to work on that with me, I'm open definitely to doing that.
I mean, you work for Google, right?
I do.
Talking about handling in general the logs, sometimes together with the KTAP, you may end having in the middle some errors or warnings, and so you will need anyway to parse this somehow. Otherwise, you may be hiding things that are happening during the K-tests.
Yeah, so I showed you a very nice test here where everything passed. Maybe I should have thrown in something a little bit grosser. But basically, if one of these tests failed, above it would be all of the like raw log up at like within that test case. So like you see sort of this information above the test here. It would print out that information. So you're not losing the information. I print it if anything bad sort of happens. But it's a little tricky. It doesn't always happen exactly perfectly. Sometimes things print out later. So I'd be lying if I say it catches absolutely everything. So, yeah.
So I like the idea of making it a KCIDB client, because that way, if hypothetically I had some other tests and this was in PyPy that produced KTAP output, then I could get a free KCIDB client out of it. But just a note on that, so it wasn't the actual data that was an issue when I was trying to write the Fuego client, it was the metadata. And so there's issues with, if you're gonna write a KCIDB client, you gotta make sure you have appropriate metadata to go along with it, which is not gonna be obvious from the test results themselves. So that involves an extra step of gathering some extra metadata from somewhere.
Yeah, I have looked into that. If anyone was here for my talk last year, it was the KTAP metadata. You'd have to include more output in your results, so it would be like things about your branch and things like that, and date, time, things that KCIDB really likes to have. So it would be, you'd have to sort of have a collaboration between the framework and the common library in order to get that to work perfectly. But I don't think it's a stretch. I think most people have that information. But I think doing the specification of KTAB metadata would need to happen before that. So if anyone has any thoughts on KTAB metadata, please go onto the list and join the discussion on KTAB v2, because we need to get that done first before we get that done. Yeah.
Just to echo that a little bit, I think one of the advantages of having common tooling like this is if we did want to inject extra metadata, we could have a invocation of this tool that just says add at the top level, this key value pair as metadata, kernel this, that you could easily work into your scripts and get one KTAP document that combines all of your various tests along with the metadata. Equally, yeah, that was exactly the problem we hit with KUnit trying to output KCIDB style JSON was, where do you get all the metadata from? I'm sure we can, worst case, either it can be KTAP metadata or we can just pass a huge number of things on the command line or pass another file that stores it somewhere.
Yeah. Was there a question back there?
Tests are good. I would also love to know which lines of code were covered in the test. So.
Ooh, yeah, printing out a coverage report.
Some sort of coverage. And we're hopefully adding LLVM cov to the kernel so you get source-based instrumentation. I know coverage requires instrumentation, so that breaks a lot of testing scenarios, so it's not perfect, but yes, I would love to see that.
Okay.
Yeah.
That's a good idea. Okay. Thank you, everyone.
And we're on break until noon. Thank you.
Well, this was many years ago. Yeah, like 4 or 5 years ago, I think. Basically just, KUnit doesn't have any of that metadata with it. So like the raw kernel logs, KCIA, KTAP output is just a list of tests and that. So our tool we've got to get the metadata from somewhere. Yeah. Yeah, I think the interesting thing for us was the KUnit output was literally just test results we had no metadata. So that one have to be
Yes, that's an excellent question. I don't know.
hard coding.
So I think I need to write even more kind of tests and use it to see and also. So I mean, it works on the command line. We kind of integrate it with the rest of the system to see what requirements get sussed out. But test name. So right now I'm putting test name in the value file, but it's not somewhere else.
It's very freeform.
Yeah, it's very freeform. Well, one of the things I'm taking strings that I get straight from, in the one case, straight from DB.
I like so.
And so, and then,
Interesting idea.
so I have some shell scripts for version things that just weird characters.
Basically
for all
adding-
other stores. So those strings are
Okay,
actually
not okay, unknown.
the tool itself, and then I happen to name the
Yeah,
test case
port,
names
and then
the
the
same.
code processor goes through, looks at the unknown, and makes the determination that that number is a pass. Yeah, because it's one of these things, with performance, it's not a pass fail.
I got a number.
So, well,
Is it good?
One
Is
of
it
the
bad?
questions I had is,
And you gotta look.
did you ever have to look at
And you
the
gotta fill out,
numbers
reference
to
numbers.
produce your outcome? Like,
That's an art form.
result?
I would compare them to the reference individual.
We're constantly really into that. For internal evil vendor SDK, right? We're looking at, the past
So you
ones
could have-
and
you could have
keeping
the
a sort of an
same test
average with
case,
standard
the effective
deviation and all that. Constantly giving us trouble. So why did this test fail? We're gonna reset it.
Sorry,
It runs, didn't produce real data.
And I basically have a namespace on the potential.
Yeah. There's a table there that I guess you want to
CPUs, columns, CPU.
Yeah, that's the thing is they try to run it and try to make sure the board bring out. A lot of time the formulas just jump. So they're looking for values and try to bring it up so they can just call it a range. Manually they can determine it because the calculations that you can set up and you go back to the values.
But yes. Yes, you have to have, so the reference values is a combinatorial problem.
Yes.
Right? And that gets really, I think that something is the reason we've never done something that's it's combinatorial problems, like you're gonna have 100,000 reference value files.
Yeah. Because many of these performance labels stem from some sort of
it's usually based on some identifying factors like is it number of CPUs, is it my processor speed, is it a kernel command line option, is it a config value, all those things, right, but if you try to well, and I agree with you that it's probably not as big as it sounds, because it turns out you don't vary all those, right, or you vary some of them, you may have lots of combinations, but you really only end up having like 10 or so different combinations that are realistic and practical. You have usually, like if you're on a development board in product company, say, you can have a debug configuration, you have production, and those are the two configurations you're testing. So you're not testing every possible kernel config. You're not testing every possible kernel command line. And your hardware, that's the thing, it's more practical and embedded because you're on a single board, right? And your hardware, well, it's like, hey, I'm the software, hardware's not changing. Right, you make it like, you get new revs of hardware, but they don't, I mean, the whole reason you're doing this, right, is to possibly affect the hardware side. But it's not, you're not getting hundreds of hardware sizes, you're getting 2 or 3 over Yes, well, and that was, so, yes, I actually think it's going to be important for law enforcement to somehow encapsulate the metadata that goes along with it. What were the things that you thought affected the outcome? So yeah, try to include that metadata or something. I hadn't come up with a good scenario, but and you need that for the reference values. And if it's in the case tab, it would be I could use a result file as a reference value. So, and you want to say, yeah, I only want to compare the same number of my same number of same kernel span.
There's also some that do we should maybe kind of execute the policy
Right.
Because then they just change
Right. Well, so that's I have a results analysis tool that lets me that flips over a span of results files.
You need to have this validation stuff to know if this value, the higher value is a parse or a fake.
Right. Yeah, that's right. Well, that's what the rule says. Are you looking for lower
If that is somehow encoded in the result.
Basically to move.
Yeah, well, okay.
Maybe you need to stop presenting first.
This is the magic one.
Yes?
I really think you should the output.
Maybe that, I don't know. Nothing is there. No, you should be want to say like stop presenting. It just was not a before.
You got this out but because your reference value was this, I was comparing it against this, and I was
Check with Tim.
less than operation. Because otherwise, a human just gets a file and says not okay. It's like, well,
I found it useful to get the results, compare to without thinking about encoding the ref, but the rules.
For test results,
Okay. So
I would
just
not want to
if you namespace it and have speed or throughput,
Are you able to find the presenter?
We're trying to.
He said he is actually like in the room, but not the presenter yet.
Yeah, but we're trying to figure out how.
Okay.
Like, it's a great question. So like Guillaume is checking. This is him, right?
Yes, it's him.
Oh, okay, perfect. Does it work?
Sounds good. Yeah.
See if it. Perfect.
You made a presenter now.
I'll go call Guillaume.
Right. Well, that's why. So most of my tests, I originally
Something's happening.
criteria rules for every single value, and then I realized I had to add the wild card because I have these rule
So we can switch. I can switch around, I guess. No, I can't anymore.
So I may do the opening for him. Using this one right here.
You should be able to open now.
Okay.
Well, let me. You know what? Tell him I'm still in presenter for a second.
Yes.
And we're gonna open this one.
Well, so when I thought about that, I also thought about
Not this one. Not this one. This one. Yes.
So to make him
just decode it in the test. But I actually have one of my tests that does that. I don't have a criteria file. I'm just comparing last year. Well, it does.
So he can just show up here and then talk, right?
Yeah, he just needs to
I see.
turn on his camera.
So
Take the finger, you're supposed to click the person.
Yeah, that's what I did as well.
And then you have make presenter. So we made them
I clicked on it, it didn't work. That's crazy.
So we made them presenter and then all the slides for him to play with.
Because I did a right click instead of left click maybe.
So he will basically clicking through the slides, right?
Yeah, he's the one who's
okay.
presenter.
Yeah, so I sent him a message, Tinchu. Yeah, there's no reply yet, so I don't.
He's touch.
Are you in touch? Okay, yeah.
Yeah.
If you could just ask him to jump and test the video.
Yeah.
Because last year we had a problem with
Can you test the video now?
sound and audio, just like there. I don't think we can.
To me, that's why your approach that says you can test.
We might need to join the audio here.
He didn't turn his microphone thing on.
Oh, he did.
That means that your actual test result part of
I need to ask the tech.
But that's it, it's not your...
My question is whether we should join with the mic. I'm wondering whether we should join with the mic so he can hear what's going on.
He does.
No, I mean right now we haven't joined the audio.
Yeah, so this one doesn't need to join the audio. It's just a presentation laptop. He needs to join with the audio.
Yes, yeah, he needs to join with audio, but I don't know about us, so I need to...
Teacher, I think you are like in the listening only mode.
Okay. So there's another user for this.
Perfect, so that's working.
Okay. Where is disconnected now?
Yeah.
Is he coming back?
I'm sorry?
Is he coming back?
What do you mean by coming back?
He disconnected.
Oh, he disconnected?
Yeah.
Jesus. There'll be some here, so don't worry about it.
Oh, he's back. Well, the user is here, but... So is he going to be changing the slides, or are you going to be changing the slides?
He will change the slide.
Yeah.
Yeah.
So normally he should be making...
I'm just going to say a few words like in the beginning and the end.
Okay.
Set up the background.
So he seems to be disconnected now. So.
Yeah, ping him here.
Yeah, okay.
But the reality is...
The talk is at 12, right? So you have 30 minutes.
Yeah, it's at 12. Yeah. We're a bit early, yeah.
Oh, okay.
Am I happy with it or not happy with it at this point in time? That's exactly the case. Yeah. Yeah, well, it's better now for whatever reason, right? Or it works. Yes, right. That's why progressions, I think. I just collect measurements and have them.
Oh, well, can you hear me here?
Yes, yes.
Excuse me? Okay.
Yeah, thanks for the feedback.
His mic is on. It'd be good to try if he can speak.
Well, can you hear me?
Oh, yeah, we can hear him.
We can hear you.
Wow.
I'm online and I can hear you. I'm not sure about the room in person. You can maybe
Excuse
send
me,
it.
good afternoon. Okay, I see.
It's a really big lag. I think it's just a lag. Was it him speaking?
Hi, good
I
afternoon.
think he's speaking, but there's a big delay. Between. Yeah.
Just keep speaking.
I think there's a big delay.
And you can also take a result.
Can you ask him if he can hear us?
Can you hear us?
Excuse me, good afternoon. Good afternoon, good morning, good evening.
Because it outputs.
Yeah, this is working.
It doesn't work.
I might need to fix my reference values manually and just want to read them later.
Right. Yeah. In fact, that's what I did in prayer.
Oh, like, there is another team member say, like, you can hear him in the online room.
It's like, oh, okay.
So it seems like that's our problem. Hey, Wental, can you hear us?
Yeah, thanks. When are we back?
12.
12? Okay, we're gonna have that.
Hello, can you hear us? The laptop in the room is muted. Yeah, okay, so I need to ask the technician.
Gotcha.
I think what it needs to be able to be open to other people, like plugging in their parsers and have a way to invoke themselves when some matches. And then we show them like interject the results and say, I'm going to handle this part and the other part is going to be handled by whatever the invoke parser and one's going to be handled by whatever else injected themselves with. So that way you can open it up to anyone to either use whatever it is or add themselves to do more parsing by saying, this is the stuff I want to match and I want to start parsing it until I'm done. And I'll give it back to you.
Yeah, I think it's overall a good idea, and I like the idea of opening up some sort of thing like tools, parsing, and then this could be a specific PTAP one, and then having something above that to in general. I just don't know if I'm the right person to do that right now when I'm focusing on this project, but I would really be open to talking to
You could meet your piece as the one that does the piece that you do.
So you can't hear us? That's strange because I'm pretty sure other people could hear us before. So I don't think he should be in a special case.
Got it.
What to do is, I think it's going to cause some feedback. Maybe. Yeah. Yeah, it's just going to cause some feedback if we could do this.
But how can the speaker hear us if we cannot? have this mic.
There's another connection, I think.
There's another connection, I see.
So there's two LPC speaker here. You see. So the one here is us. No, sorry, this one is us. Maybe it's because this one is muted. Maybe it was muted for the break.
I see.
Let me check with it.
Can you hear us? Gee, no. Can you hear us now? Still not. Able now. Okay. Now works.
Oh, well, excuse me, can you hear me speaking?
Yeah, we kind of can, but there is a delay, I think. Just keep speaking so we can know more.
Oh, well, good afternoon. Good morning. Good morning. Good morning.
Yes, we can hear. We
Hi.
can hear now, I think.
Yeah, there's just lag.
Start at 12, right?
Start at 12, yes.
Yeah, well, the lag is less than 20 minutes. Can make your talk now. We'll
It's
hear
not
it.
real time scheduling, so it's fine. I think it's fine.
Can you say something and raise your hand at the same time so we can measure the lag?
That's absolutely what we want. And whether we do it, as you say, by outputting a partial thinking tool, or whether we have.
Can you ask him to say hi and raise his hand at the same time so we can see that?
Sure.
Either.
I guess he can hear us now.
Hi. Hi. Now I'm speaking.
It's about like 1 second.
Good morning.
Delay. Not too bad.
Thanks for someone specified where these significant lines go on the output or on the error, but sort of parsing the data.
Do you mean like the specific lines, how they're
Yeah, so from the individual main lines, is it specified if it needs to watch the error or the output, or it just doesn't error?
It doesn't care. Whatever output is for the error or warning, it's just going to print back the basically the kernel if it were to fail or something like that.
So K-unit and all that comes from the kernel, or from debugfs. So it's in a file somewhere. It's a stream of lines. We're not fussy where it comes from. That's not part of it.
People have been interested in standardizing errors and warnings and things like that, making it easier for the browser to read those. But I think there's such variety right now, and people have lots of different experience on how that would go.
As long as you can get it in a file or in a pipe,
then it'll be there.
And if there's also no way to say in the format that now this test is starting.
No,
uses the same value within a test. So you can stream, time series of data from another test, which again, is not necessarily what you do for version 1, but
At some point, you probably also want to be able to see histograms.
yeah.
At least I'd like to one. Yeah.
It's debatable, like, whether it's good or not.
Yes.
We're not using game.
It is. It's just no matter what you use.
I'm assuming this framework is basically getting compiled with special options.
Yes. Yeah. Each unit test is enabled by a config option, or each suite of tests. By default, then with there are KTAP to either the kernel log or it's accessible from debug FS. You can also build them as modules.
The quality of the test is, expectation is that they all pass?
Yes. Do they all pass right now on all different configs? No, but pretty close. The expectation is that the tests pass pretty reliably and run pretty quickly. You can use metadata attributes to say, hey, well, I've got a test that I know takes a really long time to run, and you can tell the kernel, please skip all tests and run this slow result.
You compile one kernel with all of the tests, or if you compile multiple kernels,
ideally, you compile as few kernels as you can get away with, but ideally you can do it with one. But if you have two kconfig options that conflict, then you don't have to do it twice. We're hoping, I think that's looking promising. We're hoping to have some better features to do things like if the tests are running and you get a failure to be able to say, hey, kill that one, start the run again, and start running from the same point. So we can isolate them better with individual kernel executions. You can do that now. Tooling doesn't make it. Tooling makes it easy to do it completely.
You are currently the only person in this conference.
Because I think we talked internally, like, the fact that we're not doing much testing for kernel. I have found out about taking this probably a bit later than that. I'm thinking that that's probably something that we which means we're going to build some custom kernels and put them into the test, right?
I mean, the advantage of the KUnit tooling is that there's literally this Python script you can kunit.py run in the config. It will build a UML kernel, run it on your local machine, pass all the results, print it out quickly, and run it go. You can throw that in a script, have it outputted in all of the formats.
What do you need to build? What do you need to build?
Well, you can run it in VM, or in the case of UML,
So we're coming from a embedded world, so our world is a bit different, but yeah, I mean,
it's one of the things with unit tests. Ideally, they're not super hardware specific. You can mock out the actual hardware stuff, whether that makes sense or not. Obviously, you can use it for hardware specific things.
general tests that you can run on your ICC. It's also like sanity checks.
Yeah.
The basics are working correctly.
Yeah, and we obviously have lots of KUnit tests for use the linked list data structure function in a vaguely same way.
There's no phase that we
yeah, and you certainly can run KUnit directly on hardware. I do, but the tooling doesn't do it automatically for you. You'll have to integrate that into your own setup. You can get KUnit.ko, all that. You do need to have had it enabled when the rest of the kernel wants to. You can't just go and change it afterwards.
So I was wondering if this is a private nobody that
testing, it's obviously harder to unit test drivers, particularly if they weren't architected that way. So, you know, arranging your code to make that nice is up to you.
But I'm thinking about it to make sure it's testable with this.
Yeah. There are ways of stubbing out kernel functions. So you can put in if I'm running from within the text context, please redirect this function to something else.
I see.
There's also like Kane has some resource management stuff, so you can defer things to a text, like clean up to a test exit, whether it passes or fails. You can say, I want a struct device pointer, you know, give me one with this name, and it will put it on a special key pass for you, clean it up for you when the test fails.
So the intention is that after all the tests are run through, the state of the system is the same as before?
Ideally, but we still take the kernel if you run any tests, because, you know, we can't guarantee that. Even if tests pass, you know, you probably don't want to be using your test kernel in production.
Yeah.
And certainly if a test fails, you know, we can't make a guarantee. And I know the Rust folks have had some fun with like unwinding, putting things in interesting states when things fail. So, you know, we're not going to guarantee anything, but I've run, you know, to try it out, you know, to set all the tests, and then use my desktop feed locally, no issues. You know, I know it works pretty well in practice.
And it's, I mean, we compare it to the performance testing, I guess it's the same state, right? I mean, you have some reference that some tests are failing, some tests are passing, and it's looking for not everything.
I mean, at the moment, for the default sort of tests, they all pass very well.
Oh, really?
So
Okay.
that's partly because K-Unit's still new enough that there aren't a huge number of tests. There are, you know, 1,000 or so split around, but you know, you're not going to be running all of those in every configuration. You know, some are architecture specific, some are, you know, specific for the particular drivers. But in general, they work pretty well. People try to jump on them when there's failures.
Are they running kernel CI?
Kernel CI are running them. Whether they're running them successfully on the new setup, I'm not sure. A lot of the CI systems run at least some selection of K-unit tests.
So kernel CI does build kernels that work to do with the K-unit test.
We're not doing K-unit.
No.
As far as I know. No, I am, but as far as I know, the kernel CI doesn't.
Okay, there's last I checked, there was a K-unit thing on the results page and
Right,
it showed
maybe.
error, but certainly there are quite a few CI systems that run at least some set of K-unit tests.
Yeah, that's why it's covered. I mean, it's not very interesting because it never fails.
Yeah.
Basically, it's.
Have you tried running that for coverage?
We have. There would be a bit, I think, in the next talk showing there's not a lot of extra coverage compared to just picking the kernel from it, but on an absolute level. But yeah, we've had difficulties with
sticker for my laptop.
There you go.
It's the workload.
UML coverage, which UML is what our tool uses by default with some GCC versions, but LLVM is working now. So working out why it regressed in GCC 6 is the one that enormously funded.
Cool.
Thank you.
Interesting
Yeah.
stuff. Thank you.
Nice.
lecture started or?
Here are my top 3 reasons why I stopped downloading sample packs, form and tweak sounds on the fly. Each kit has these crazy modifiers where you can reshape and mess up the sound. And those sampler kits are only half the plugin. With instruments, I can play chords and melodies like this. Number 2, everything is all in one plugin and super high quality. No more complex multi-plugin chains. Each kit in Arcadia is crafted perfectly. And I have instant control with macros and modifiers. And I can even edit everything in the tweak page. And number... using my own sample.
I think it's working. We can get started if you want. It's time? Okay. All right, hey everyone, thank you for being here to listen to our talk. So I'm Ting, I'm the last person. So this is actually a team of efforts. I'm an assistant professor at the University of Illinois. Darko and I, we actually working with Boeing since the beginning of this year, working with fantastic folks like Truck, just trying to basically certify Linux, for it to pass FAA kind of standard, try to make it fly on the plane. And Wental actually did a fantastic talk yesterday at the referred track, talking about the process, even try to measure test coverage matrix such as MCDC, right, as the first step. And many of you ask in the talk that what's next, when we know how to measure the adequacy of the test, what can we do to making Linux actually fully certified? And certainly, measuring is the first step, and the next step is really try to boost the confidence of the kernel code just by running tests, having huge coverage. And one thing obviously we're interested in is that what is actually now existing test status, right? How much we're able to cover our code, at least some of the core code. So we have this fantastic undergrad student, Ting Xu. He is going to tell us some of the work he is doing as a side project, trying to actually measure and understand Linux kernel test. So Ting Xu, if you can hear me, just feel free to get started.
Yeah, I can hear you. Good afternoon, everyone. My name is Ting Xu Ren, and I'm an undergraduate student currently visiting the University of Illinois. Well, it's a great pleasure to be here talking about the project I'm doing this summer about measuring and understanding Linux kernel tests. Well, it's a pity that I can't attend LPC in person, but Darko and Tian are at the conference, so if you have any questions, you can follow up with them. Well, first is an introduction of myself. I'm an undergraduate student from Zhejiang University, China, and now I'm visiting UIUC. My colleague Wentao Zhang presented some high-level picture about the project, about the background and some goals. But so I'm not going to repeat too much about this. Generally, our goal is to comprehensively test Linux kernel as a modernized software that can be accepted by some organizations like FAA and also used on safety critical systems such as airplanes. Well, and also this is my first time giving a conference talk, so please bear with me. Here, let me be more concrete about the motivation of our work. Basically, we have seen great efforts from the community to modernize Linux kernel testing, as exemplified by, for example, kernel CI. So we are interested in understanding more about this perspective, especially the current practices limitations and also how we can contribute to this effort. Coming from a somehow academic viewpoint, we think that in order to build an efficient CI system for the kernel, we may need the following three components. Firstly is that we want some high coverage and effective test cases so that maybe every incremental changes can be well tested. And second is some test selection and prioritization mechanisms so that when there are code changes, we only need to run a small number of tests, and we can also prioritize them by prioritize the ones that are more likely to find the bugs. And thirdly is some bug localization and reproducibility mechanisms. So when there are test failures, we can quickly find the bug and reproduce them. So with the aforementioned goals, we are asking ourselves the following three questions. How far are we from achieving them? And what should be done but has not been done yet? And at last, how can we contribute to this effort? We started by studying some commonly used test suites. There are all kinds of test suites with different targets. For example, there are unit tests written in the KUnit framework, and there are also many US-based tests which test kernel by using system call interfaces like LTP and K-self-test. And there are also many module-specific tests which target on specific modules like XFS, block devices, and so on. We also studied test suites for certain distributions like Red Hat Enterprise Linux. It is a very large test suite, but may target mainly on the certain distribution or some pre-installed packages. So in summary, we eventually focused on the three test suites, KUnit, LTP, and K-self-test. Well, LTP and K-self-test are the native tests used by kernel CI. And we also included KUnit because unit tests are very effective for CI system and regression tests. And we also included booting because it is the precondition for all these test suites. Well, a future work is to add system call fuzzers like syscaller, but up to now we hadn't had the chance to run it, and maybe it is not very suitable for CI testing. Here is the setup and configuration of our work. All the measurements are done in kernel version 6.9.8, and we are using the default configuration for x48. Along with some modules for LLVM coverage measurements for KUnit, and also an Ethernet driver. We are using LLVM 19 to measure the coverage, and we are using metrics including function, line, branch, and MCDC coverage. And all the experiments are done on physical machines of Cloud Lab machines. And I think it is also worth mentioning about the so-called source-based code coverage. This is the coverage tool we are using. It provides some human-friendly and informative coverage reports, which can be mapped directly to the source code, and it is not susceptible to optimizations. Actually, this tool is an enabler of our work because we wouldn't be able to survive with the optimizations with traditional coverage tools like gcov. Our patch for supporting SCC is going out and requesting for comments. So my colleague Wentao will talk about it at the safe system with Linux MC today at 4 p.m. So please support it and give us some feedback. Okay, and now let's look at some concrete numbers about the coverage. Here I'm showing an overall coverage report with all the 4 test suites included. From the bottom line, we can see that the function coverage is about 39%. The line coverage is about 29%. Branch coverage is about 22%, and MCDC coverage is even 9.68%. To take a deeper look, let's take the line coverage as an example. In this line, most of the subfolders are less than 60%, except for IPC and memory management. And the drivers and sounds folders are extremely low, with only about 15% and 11% coverage. Besides an overall coverage report, we may also be curious about how some test suites can actually contribute to the coverage. Here I'm showing the increase of coverage by running KUnit alone, compared with just putting the kernel. From this table, we see that the highest lines are drivers, lab, and sound. Labs is high because it implements some common data structures like list and hash table, and also the core code of KUnit lies here. While drivers and sounds are also relatively high. This is also reasonable because almost half of KUnit tests are written for drivers. And from those tables, we have some very high-level observations. Firstly, we find that the coverage of kernel tests is actually far from adequate, especially compared with some modern software projects. Like, as I know, Google is offering a general guideline of 60% line coverage as acceptable, while kernel coverage is only about 30%. And secondly, some user space tests like LTP are pretty ineffective in testing drivers. Like LTP is performing even weaker than KUnit while having much more test numbers. And thirdly, the higher covered modules are mostly less than 60%, while branch coverage is even lower than this number. And at last, certain subsystems like init and cert is really These codes are generally exercised during boot time, and this can make some boot time bugs difficult to find and cause trouble in debugging. So here, let's take a deeper look into some concrete code. And I'm firstly taking IPC as an example because it has the highest coverage over all folders. IPC is a very small and simple subsystem with only about 12 files, and it is extensively exercised by existing tests, especially LTP. By looking into the uncovered code there, we mainly classify them into 4 types, which are first, missing usages, and second, error paths, third, execution context, for example, whether they are raw in privileged or not, and at last, 32-bit compatibility. Here I'm going to show some examples for each of the types. First is some missing usages, like we are taking the POSIX message queue as an example. Well, the system called MQSend is using its false parameter as the priority of the message. A message with higher priority will be inserted before others. But from the code below, we can see that some lines are actually not covered. The first column here shows the line number, and the second column shows the times certain line is covered. From the table, we see that line 204 to line 208 is not covered at least once. So this may imply that all the time the messages are using the same priority, because this code implements the searching process on the RB tree. And the second pattern is some arrow paths. Arrow paths are usually complex and they spread all over the code. The usually features in the validation check, followed by some cleanup code. And below is an example of such arrow paths. There is assignment of arrow number and unlock operations. It is worth mentioning that covering all arrow number of a system call doesn't mean covering all arrow paths because there can be many internal arrow codes. So from the examples we have mentioned, we want to think about how to enhance existing tasks and get more code to be covered. Actually, we have developed a very simple tool to select some tasks that can cover certain code, and maybe we can try to enhance them to cover more code. The basic idea is to maybe track a certain line in a certain file and see which task actually covers that line. If we find such tasks, then it is easier to cover related code. And here I'm going to show a brief demo about the automatic tool. Here you can see my screen here. I've already installed the kernel with only the LPC folder instrumented by adding these 2 lines to the makefile. And so the first step is to run the LTP test. Using this command, I will run the whole LTP test and generate a profile for each of the single tests. It will take a long time to run, so I stop it here. After it has been executed, we can find the coverage report for all the LTP tests. And we go to check the example I was given before. For example, we go to line 204 in mqsend.c. If you still remember, this is the example I was giving about searching downside on the RB tree, and this code is not covered. In order to cover them, we may want to find which task actually exercise this line. For example, this if statement. So in order to do so, we are writing it in the config file. Here I'm writing the mq.c file and also the line number as 202 and give it a name called message priority. With this config file, we can run another script here. This script will analyze all the profiles and find whether they actually cover this line. So this may also take a time, and after it has finished, we can go to some certain folder, and it has already generated a result for each of the lines. Let's take the first one as an example. In this result, it tells us that the task named mq timed send01 actually covers this certain line. And so we may want to make some modification to this task. Here I've also already made some changes. This is the source code of this LTP test. The core of it is here. We see that inside the loop, it calls mqsend many times, but all the times the force parameter uses the same value. It is almost a constant, so the priority doesn't change. And in order to enhance it, I'm adding a new test case, and here I'm also using a very similar for loop, but inside it, the priority is changed to associated with the iterator j. So after making this modification, it is expected that the target code will be covered. So to check it, we are running a single test of LTP. Yeah, and this script runs a single test and will generate another coverage report. It is already showing here. And we go to the same position. to find that line 204 to line 206 are indeed covered. Well, this is a brief demo about the process, and I think similar techniques can be used for maybe task selection and also prioritization based on this coverage measurement. After that, let's go to see one more module, which is the submodule. Submodule is very different from IPC, not only because it is much bigger, but also because that most of the features cannot be directly invoked by system calls. For example, transparent huge pages. And the behavior in memory management may also depend on certain memory layout. And there are also complex multi-threading comparison. So we are expecting to find some different cases here. We are going to take the THP as an example. It is not very well tested by all the test suites. For example, there are only 0 in KUnit, 1 in K-self-test, and 4 regression tests in LTP, which are focusing on certain bugs. Here I'm going to show a concrete example. The way of allocating a huge page here is as the follows. There will be a check-in, for example, to check whether the pages are available to be promoted. And this process is wrapped with read log and read on log. After that, the kernel will try to allocate a huge page. And after that, it will isolate this certain page from LRU list and make some copy. This process will also be wrapped by write log and write on log. So on the right side is the source code for this. From it, we can see that the code from line, the code marked with black here is indeed covered. This code actually means checking whether some certain page has non-PTEs not exceeding a certain threshold. If it satisfies, then this page is ready for promotion. And we put this piece of code in the top and go to maybe the next step. On step 6, there are some very similar code here. For example, it also checks the number of non-PTEs and see if it is ready for promotion. But in this time, this piece of code is never covered, though they are just the same as before. This is because that the memory status never changes during this whole process. So if it's satisfied in the first step, then it's satisfied in the second step. And in order to cover this code, the only thing we can do is to change the memory layout during step 4 when there is no read log or write log. But since it is a background kernel thread, it is very hard to achieve that. And from our perspective, we think that the easiest way would be to use some kprop or similar techniques to insert some code before line 1112 so that we can change the memory layout during step 4. In summary, we find that we have some the following observations. Firstly, we think that existing kernel tests do need to be enhanced. And secondly, we think that there are many opportunities to enhance existing tests. For example, as I've demoed before, coverage measurement can guide the enhancement. And thirdly, we think that new mechanisms are needed beyond system calls. For example, THP and other event triggering code are not easily exercised by traditional mechanisms. And we also think some existing tooling is quite rudimentary because we didn't find some handy tools for task selection and analysis. Besides that, we also did some study on existing bugs. Here is a demo of the 11 bugs we studied. From them, there are 8 bugs which are associated with some uncovered code. Of them, 4 lies in some functions that is not covered entirely. and about 2 of them are caused by some uncovered branches, and 1 of them are caused by uncovered lines. And there is also a special bug where all lines and branches are covered, but there is still a bug because of missing execution. And we also find 3 bugs because of concurrency problems. Well, that was my conclusion about the work I was doing. Then Tianyi will give some conclusions.
Basically, Tingshu, he was asking, what's advice for giving a talk? So I said, you have to piss off people, by giving some provocative, kind of statement. And he was too, kind not to tell that, so I'm going to, basically say that. So essentially, what, Tingshu mentioned, Darko cannot make here. He was actually in an academic conference, also in Vienna, at the same time, about software testing. And if you go there, I sneak, to the conference last night, and then they were all talking about very fancy things, right? They're talking about really kind of, continuous integrations. They're talking about, wow, there's huge, high coverage test suites. You can, for every single, changes, you have, basically very fancy test selection, test prioritization techniques. And, you have, those, who was telling me about, you can even, using large language models to generating some test code, and then, be able to boosting, some of the code coverage. And if you look at the kernel land, we don't really have too much about it. So, one question, I guess I have is that if you go to the next slide, we have very smart students, and also we're trying to do some work which can increasing the confidence of kernel testing. Wentao is going to give another talk in the afternoon about hope to convince everyone his patch, which enable source-based code coverage. And one thing is we want to actually hear from you what we can help. As students or faculty from academia. And if you have any ideas or if you have any hard questions, please let us know, we'd love to hear. And I guess we have 5 minutes. Happy to hear any feedback.
Is that on? Yeah.
Yeah, it's
okay.
on.
We've talked about this. I think there's a research opportunity. We've talked about GCOV instrumentation. You actually can't tell where the coverage occurs because instrumentation happens in the back end. Optimization just makes it too difficult to tell. So can you go backwards? Can you take the GCOV instrumentation results and go backwards and figure out exactly where it traces through the code? So there might be some interesting research work.
Definitely, definitely. So basically, again, the other talk, in the afternoon about this patch, we really want to enforcing, enable the source-based code coverage. And we do this really because we're starting from GCOV and we find that we cannot survive, right? We look at the coverage report, we cannot actually trace back to the original code. Where is it actually covered or not? It's very basically pain. I think the similar problems even in syscallers, if you use basically KCOV, it's really hard if you find a bug. And basically, I think what Truck is mentioning is that can we even using those GCOV and KCOV report and be able to actually precisely go back and trace the source code? That's a very interesting question.
Yeah, it is. The other one is transactionality. So start and stopping at known points, but then how much noise are you still getting from interrupts and all those things firing? I don't think we can get to 0, but certainly I'd love to come to Plumber someday and say we're down to 0.1% or something like that and start looking for ideas for that.
Yeah, David was talking about userland, in a K unit, and hopefully can solve some of the problems, I think.
So that tool looks awesome, by the way, the one that finds the test that does it. When can we see that upstream?
It's just Tingshu as an undergrad student, hacking this stuff for 2 months. We'd love to basically open it up. We actually use it for our own use cases because what we find is that it's actually hard to rewrite inventing a bunch of new tests. It's better to finding the existing tests which actually already cover a part of code. And then adding something more. I have 1 minute, okay. So I will be here this today, so just find me. We can talk more.
Yeah, thanks for this, really interesting. We did something similar in Red Hat, and so, but I think a great input from you can be to the LTP project, can be to provide such a report with some cadence about which test can provide the biggest increase in coverage. So something like that I think can be really useful for LTP project that really need input to understand how to step forward.
Yes.
Thanks a lot.
Just one last question, yeah, I guess.
You've asked how can academia can help, and I'm thinking that, okay, cloud coverage is super important because now we know what's missing, but the hard part is to actually writing the test then, right? Because, and I'm thinking maybe there are smarter ways how to write tests we don't know about, like, for example, property-based testing or something else, which would allow us to cover more code with less effort, basically. Maybe that can be like a broad area where some input from research to practical development would help.
We are thinking about it. One thing we wanted to do always is actually try to understanding the syscaller or other kernel furthers implication to CI, kernel CI, right? So they have great properties they can actually explore the code passes in the code. But one thing they may not give it to you is that if you are actually in a CI, you want some quick feedback, you want to actually be able to test a small basically a patch. If you run a long campaign of syscaller, it may be a bit not that convenient. Property-based testing similar things. As I mentioned, Yongwei was mentioning that we can use large language models to generating a bunch of tests. That's some of the hot topics. Maybe we can boost certain things, or at least easy things well. Certain things as Ting-Shu mentioned is difficult, right? For example, the THP, which is transparent huge pages, it's hard to be directly triggered, and you need to have some ways to tweak about the memory layout, even during the text execution. How do we even deal with that? Yeah, so interesting problems. All right, I guess I'm running out of time, so thank you.
Servers got restarted. Does in theory produce some very, very early finished ACI DB. So, yeah.
Sorry about the file name.
The noisy thing is very noisy.
Yeah.
Absolutely right.
Yes. Everyone's fine.
Okay.
So flooding is just random.
Thank you.
Hello. Hi everyone, my name is Nicholas. Today I'm going to talk about basically the current state of device testing, and maybe I'd like to start a conversation to see where we can go from here. So what's the motivation for this work? Basically, if you think about it, a lot of the code base in the kernel is composed by device drivers and as such, which provide functionality to the system. So really, there's a large source of regressions that could affect real use case of the system, right? At the same time, we have lots of different subsystems in the kernel, ranging from, I don't know, displays to keyboard and whatever. And each subsystem really has specific user space interfaces. So covering all of them really requires targeted testing for each one. which would be great to have at some point, and I think we can get there. But at the same time, I think another approach is to do generic testing for the devices, which could be done by much less code and cover a lot of ground and get us to a better point than we are now. So that's like the goal of this work, to detect regressions in the generic device layer through generic tests. Some of the objectives here would be also to have the minimum of false positives. As I was working on this and looking into possible tests that we could develop, that was a constant concern. We don't want to be annoying maintainers with regressions that aren't real, or like just because something changes, then we get false regressions. And also, like, as much as possible, have the minimum maintenance, because I know kernel developers usually are more interested in the fun stuff, implementing support for devices, and not so much for the testing part. So if we can get the maintenance to a minimum, I think everyone would be happier. So on that note, these are the areas that we have submitted tests for upstream, generic tests. So on one side there's probe, right? Like that's like an obvious place to test. So we have the device tree case self-test, which, if you're not familiar, it basically looks through the device tree in a machine and looks for each one of those devices, whether they have existing drivers in the kernel source tree, and if so, it will check if they are probing or not. That helps you. That allows you basically to detect whether maybe there has been a change in a configuration, in a kernel configuration, and out of a sudden you no longer have the driver that is needed to support the device, or any other different problem that could result you in not having the driver probe. So it really is a good way, I think, to detect such failures. And we have that enabled in kernel CI, and there have been a few different occurrences where we caught real regressions with that. So like I think that's an interesting test. That's already upstream since a few kernel releases, by the way. So if you'd like to check that out, if you're not familiar with this test, and you could check it out with your own machine or whatever, and report back to us if you have any feedback on that test. I'd be glad to know about it. There's also an equivalent test for ACPI. Basically, also looks through the ACPI tables and checks whether the drivers have probed or not. Although that one hasn't been merged, basically due to lack of feedback from maintainer. So again, if you're interested in that sort of test and could give us, it has even already caught some regressions because we're running it out of tree. But if you have any feedback on that, we'd be happy to learn about it. Besides that, so like there has also been another test that I upstreamed, which is, I call it discoverable bus test, but I don't know, naming is very hard. Basically, the idea there is device tree doesn't allow you to describe all the system, right? If you have discoverable buses like USB and PCI, which are not described by device tree, and you still would want to check whether the drivers there have probed to ensure that you catch any of those regressions. That's one test that I have discussed in the plumbers last year. So it is now upstream, and it does allow you to detect failures in driver probe for USB and PCI buses. The annoying thing about it is that you really gotta, basically, you use a YAML file to describe the USB and PCI devices on the system, and it has to be like basically put together manually. So we do have like that test enabled in kernel CI, but it has limited functionality because it's kind of hard to create the reference files for it. Another front is error logs. So basically, we're all familiar with the kernel log buffer. And that's really like, basically, as I see it, the only real generic way we have to report errors to user space or the user of the system. So what this case of test does is basically to collect those error logs from the log buffer, and as you may know, each log message in the kernel, if it's coming from like dev error or one of those device-related helpers, it gets a metadata attached to identify which device it's coming from. So this case self-test basically goes over the log and tells you which are the devices on the system that are reporting errors, which are devices that you should look into. And it also, like, through that allows you to basically detect whether a new device is now reporting errors. So it allows you to detect regressions which might not have been caught otherwise. Of course, being error logs, it also is subject to a lot of noise. That not every error in the kernel is really an error. And I think that's also a problem, and a thing that I feel like running this test more broadly might help to address, because once we start really caring more about the errors that the kernel is spitting out and fixing the false positives, we can actually get the real errors to resurface and make them easier to identify and fix. And yet another one which I've proposed more recently is basically a test to detect existence of a device. So not really but whether a device exists in the system or not, basically by looking through the sysbus and sysclass directories. That's supposed to be like a more generic test, and I'll get into it in a bit. But at this point, I would really like to already open up, like, I want this to be a discussion, so like I would like to hear from you if people have any other ideas of areas we should be testing in the generic layer for devices in the kernel. Yeah, anyone? Okay, so if not, I can continue on and we can talk about a little bit about this test, the latest one that I've submitted. So basically, this test is currently an RFC on the list, so you can check that out. It is composed by 2 steps. First, you have to generate a reference, and later you have to validate against a reference. The reason a reference is involved is because the presence of devices in a system is really like a what would be the right way to put it? Like, you really have to boot the system into a working state to really know what devices you need to have there. Like, there's not a deterministic way to tell upfront like what are the devices that are really expected on the system. If you're not talking only about like the statically described on device tree, but really any device on the system. So this is the first step is to generate a reference, which you can do by just passing that the generate reference argument to the case of test. The important point here is that you have to do that in a non-good kernel, because you're really generating a reference of all the devices contained on the system. So if you're running that on a kernel that already doesn't have a few devices, like it has some issue, then that will be apparent on your reference, and it means that you won't be able to catch regressions on those devices, right? Here on the right, you can see, or yeah, I guess it's on everyone's right. It's a device snapshot in a YAML file. That's basically how I'm describing it right now. So basically, you have all the subsystems, be classes or buses on the system, all of the devices on the system, and from that you can later run the test. The idea is for this reference to be stored out of tree. That was a conversation that was brought up like last year at Plumbers, and I guess Tim Bird also touched on that on his presentation for about reference files for tests. Yeah, like you would really have a reference file for each platform, so like Schwab wasn't very happy about keeping these files in tree, which is understandable. So my proposal would be we could start as in a kernel CI repository for the test for all of this. We could start all of these reference files in this repository, but really, like, you don't need to. That's just meant as a convenience. You could bring your own reference file for whatever system you're interested in, but that's meant as a way to provide reference files for already like platforms that are being tested, so it's easier to run. So once you have generated that YAML reference, you would run the test again on a, say, like a more recent kernel version, and without like the argument, and that would basically compare to the reference. Any missing device will cause a failure in the test. What a missing device means is basically that the count of devices on the subsystem is lower than the expected from the reference file. So say here on the right, I have an example for NVMe bus. So basically, in the reference file, there were, when I ran the test first, there were 2 devices, and when I ran it again, intentionally removing the device to show how it would look like, one of the devices wasn't there, and that is reported in the output there. So basically, it shows you what devices were expected from their reference, what devices were found, and what are probably the devices that are missing. The important thing here is that, like, it's not giving you a certain response on which are the devices missing, because that's I think that's one of like I can call it like an issue with devices in the kernel, which is I don't see really a way to uniquely identify a device that is really stable across versions. So as I mentioned in the beginning, like, we're really trying to avoid false positives here. So basically it's I would say almost impossible for you to describe a device in a way that's really stable across versions. So the one thing that you can really rely on, which is what I'm doing here, is on the count of devices, because you don't expect like devices to disappear in a future kernel version, because that can break user space, right? So that's the only thing that we're relying on, that the devices are not going away, which represents breaking functionality. So that's the only thing that the test expects, that devices are still there, basically. And the idea is, since that's the only thing that is being checked, we give all the other information that we can infer from the system, from like U-event files and the such, in the output, which is what you see there on the right. So like we can tell you that there are less devices on the system now, but and like what are the information about those devices, and that's like that will be the job of the person looking through the results to identify like what is then to understand what is the device that is missing and find a way to fix it. So basically, the idea of this test is to be avoid as much as possible throwing false positives and still identifying missing devices which would break user space. So like there's a lot of open questions on this and things that I would be glad to gather feedback on if anyone has any feedback. Is there any device property that is safe to match, which is the concern that I mentioned before? Like really right now we're just looking through counts of devices in subsystems and assuming no device property is really stable across kernel releases. Should probe also be tested by this test? I mean, that would be one way to kind of make the USB and PCI case self-test redundant, and we could just do work with this test instead. But I've left that part away for now because I believe that that might also be one point that might introduce false regressions, and I'm trying to stay away from those as much as possible. Are there more identifying properties that the test should be reporting for each device? So currently we're reporting U events and names for the devices. So those properties, are there other ones that we should be reporting that you think would make it easier for the person looking through the results to identify the issue? Should we be ignoring more buses and classes? Right now we only ignore devlink, which is basically a class of devices which, in my view, is really just there for debugging purposes. No user space application is expecting to rely on devlink devices, as far as I know. So I just left that out of the test so that we're not reporting results for a class of devices that the user space isn't really concerned about. Also, are there better way to ignore non-devices in sysclass? Right now, I'm just checking whether it's a symlink or not. But there are some files in that structure that there are some files there that show other information. So that's why I'm doing that filtering, but I'm not sure if there are better ways to do it. I have another slide for more feedback, but maybe we can stop here and see if there's any feedback.
I found it useful to use the address thing in the device tree path to identify devices, even if their name in the bus in the device tree changes, because the hardware address is fixed in the hardware.
Right, so you mean the address of the device on the device tree?
Yes.
Right, yeah. I think that's useful information, and that's included in the UEvent file, so we're already reporting that. I guess, I'm not sure if you can actually read it, but yeah, OF full name property UEvent shows that information. So yeah, I agree that's useful information and it's already exposed.
Yeah, and it also is useful to, in the reference file, to have the driver that was matched or probed at that point.
Right, yeah.
So if it goes missing, you at least know which driver was used previously.
That's a good point, yes. We should be reporting that. I wouldn't be matching against it because I've seen drivers renamed in the past, but as adding that to the report information, I agree. That's a good tip. Thank you.
I happen to have a related question on this reference file. Can you store some metadata, like the version of the kernel, the diff config that was used, and things like that?
Yes, that's a great question, and that's something that I was thinking about, and Tim Bird also talked to me about that, and I do believe that it would be good to introduce that kind of metadata. So one of the things that Tim Bird was talking about was how to match to the correct reference file, and that can really vary between kernel versions eventually, and also config files. So how do you encode? There's the problem of how do we encode that information, which I think it's something that would be great to discuss in detail also. But either way, I think having that sort of metadata in the reference would be a great step towards that, so that we can eventually match against the right file. If, let's say, if you're looking for regressions in both stable releases, you can have both reference files for both releases and automatically identify the right right reference file to use. So yeah, I think that'd be great.
Building on that, I'd be quite interested in a smart ratchet, so that the reference file can be updated if there are more devices in the kernel under test than in the reference. If it's a strict superset in terms of the bus class things, then, I mean, ideally it would just update or tell you to update or give an indication that the test itself needs to be updated because the kernel has changed, because that information will go invisible otherwise.
Right, yeah. I think I missed the beginning of your question, but just one thing that I have on the test right now is that if there are if there are more devices in the if there are less devices on the reference than in the system, that shows you that there have been more devices added since, and it prints a warning telling you you should probably update the reference file. It won't cause a failure because we don't want false regressions, right? That it's perfectly reasonable to have support added in the kernel for new devices, but still we need to warn the user because there's a real concern of if there are more devices added in the system and you don't update your reference file, then some devices can go missing and you wouldn't necessarily get the regression from that. So that's a concern. So yes, that's why there's a warning in case there are new devices added, and in that case you should update your reference to make sure you can catch all possible regressions.
Yeah, it'd be super interesting if there was a -auto reference that changed the Git tree, and then I can check occasionally, I can get status on the Git tree and see if the references have changed and push them if they need to go up.
Okay, yeah. I'll definitely talk more with you about that.
You had this point about stable device properties on your last slide. I mean, there is a list of stable sysfs attributes that's supposed to be stable in the admin guide of the kernel. So there is an ABI list of attributes and properties and whatnot that are supposed to be stable in sysfs. And you can use those. And actually, if you use those and you find out they are not stable, then that's supposed to be a bug, right? I mean, if you are on the ABI list and you have a property and it goes away or it displays something else, then that's a bug.
Yeah, right. So I have looked through those files, and my experience has been that first of all, there's a lot of under documentation, like a lot of stuff that seems to be missing. But besides that, while the properties themselves are supposed to be around, like they're guaranteed to be there, their value is not stable really. So say I guess it's hard to come with an example right now, but yeah, I haven't had any luck with those so far. Yeah, so I guess I got some examples here. Like U-event variables, for example, is something that it's entirely undocumented in the kernel tree, and so those properties apparently can just change. And yeah, like there's a lot of lack in documentation on that front, I feel like.
Yeah, okay, so, well, that's too bad. Yeah, sorry. I mean, when we put, just from my experience, when we put a new file in sysfs and all device drivers, we do take care that, like, if it's supposed to be stable, it's supposed to be documented. But yeah, okay. I mean, fair enough.
Any other questions? Thank you.
Sorry. Yeah, I just need to reload the file because there's a big group of technical issues. Won't take long. So LPC results. 52 slides? Do you have 52 slides? Yeah. Okay.
That's
All
it.
right.
Thank you. Okay, so shall we start? Okay, so I think we're good to go. Yeah. Hello, everyone, and thanks for coming. We are Helen and Ricardo and myself from Calabria, and we are going to talk a bit about interacting with kernel test results. So this is a continuation from some of the topics we already presented in Plumbers last year about kernel results and kernel CI in particular. So yesterday there was a presentation by Dan Sikus and Gustavo Padovan about the kernel CI project, where they gave an overview of the project and its current status. And today we're going to go into a bit more detail over a number of talks. So the project has changed quite a bit since last year. One of the main differences is that KCIDB now has a more prominent role as the final destination for all test results and kernel builds results. And that means that we are we are using it as our source of data now instead of using the intermediate data that we had in kernel CI before. So this is we're going to show some examples of how that applies to to test results. So Helen is going to talk a bit about the overall data flow and about identifying and managing test errors. And then I'm going to propose and show some ideas on data analysis and automatic error detection. So, all yours.
So kernel CI data flow. So let's first review how it works. So let's start with the Maestro. So Maestro is a test orchestrator responsible for watching the trees, doing the builds, executing the tests, and submitting test results to KCIDB. So just so you can have an idea, in a given day, Maestro was able to do 7 checkouts, more than 100 builds, and more than 30,000 tests. And our resources are currently underutilized. So if you want to register your tree, let us know. If you want to add your test suite inside Maestro, let us know. We can add it there. So Maestro sends all the information about checkouts and build tests to KCIDB, as Ricardo mentioned. And you can actually view these results through, before that. So in Maestro, we have some sort of noise detection, which means that Maestro will try to check if the error was an infrastructure error or if it's an error in the kernel itself. So if the network goes down, for instance, it's probably an infrastructure error. So it sends this information as well to KCIDB. And then we can view all these results through our official dashboard that was very recently released. You can go there right now, dashboard.kernelci.org, to check. But this dashboard is meant to, so you can check the data as a general view, but if you need specific views, we have a Grafana instance of it. I will show you more about Grafana in a few slides later. And you can also query the results with a few command line tools as well. Also, inside KCIDB, we have a post-processing part that depends on the rules. We can submit email notifications to people. Right, so since we have a lot of data there, we need some sort of triaging mechanism. So we decided to start very simple. We decided to start with a manual triaging. So let's say you is watching a given tree and you have 100 of failures that you need to analyze. So the first idea was, okay, let's try to tag the errors there. Let's check the first logs of the first failure, and okay, this is issue 1, the next one is also issue 1, it's the same error, the next one is, okay, it's a new thing, issue 2, and then issue 1 again, oh, and the next one is a new thing, issue 3, and so on. So we have tools for that. So we have a user UI where you can create these tags, which in kernel CI, KCIDB vocabulary, we call issues. So you create this class of issue, you describe the problem, and then the act of attaching a given error, a given test result with the issue, we call as reporting an incident to that issue. So you manually do that and through our web interface, and you attach. But the problem with that is the next day you get another 100 of tests and you need to do all over again to classify your data. So what we thought is, okay, when you create an issue, you can add a pattern there. Let's say a regex, all the tests with this given string or error in the logs, I want it to be automatically attached to this issue. So KCIDB can do it for you. It will automatically attach new errors coming from Maestro or coming from other CI system to it. Just a note, here in my presentation, I'm focusing on Maestro because Maestro is the CI that is currently maintained by the kernel CI community, but we could have also other kinds of origins, other people also submitting their results to kernel CIDB. So once we have this automated process of classifying the errors to known issues, we can go even further. We could automatically create the issues. And this is a bit, this is related to what Ricardo will present after. So this is how the web dashboard currently look like. If you go to the website, it was presented yesterday by Gustavo in his talk. You can check per branch and per tree. You can check the number of failures, the passes, and click on those to check more details until you get to the test and check the logs. And here is one example of one of the Grafana dashboards. So Grafana is a platform where you can build different dashboards and query directly from the database, and you can create a specific panel. So it's very easy to build something there. So let's say that you don't, this dashboard doesn't show the information that you want. So we can go quickly in the Grafana, sketch something for you. So you can hack there and create your own dashboard or come to talk to us and we can put something up very quickly for you. This is one example of email report. I know it's small, but the email reports are also very specific and custom. So we have a rule, for instance, for the Codex people. They are following test results on a given tree and also for given test suites. So we submit them information about those test suites that they are interested in. So the number of passes, the number of errors, and a link if they want to check more details, for instance. And this is how our great web interface looks like. It's very modern, I know. So you can create the issues on the top, which is the tag that I mentioned about. And in the bottom, you can say, okay, now associate this error with this issue. You put the issue ID and you paste the list of test ID there and you submit, and it will be in KCI-DB, and you'll be able to check with in the web interface and with Grafana. I'll show you how. Issues, so this is one screenshot how issues look like in the Grafana dashboard. We can see the issue title, like would be like the tag name, the title there. We can see the number of incidents we have to that issue. We can see who reported that. And when we look at the list of tests, so each line here is a given test result that was submitted to KCI-DB. We can check the status there. We can also check the ID. So if you click on that, you can see more details, check which compiler, which architecture it was, and the log of that specific error. And the interesting part is the last column there, that you can see if that specific error is already attached to a known issue or not. So if you check those that are empty, it means that those are not classified yet. So it means that they are new things that you probably need to go and analyze. Some problems there. The noise detection from the Maestro side or in any CI system that is submitting the data can be misleading. It's a bit hard to detect which of the errors is an infrastructure failure or not. And the post-processing noise detection can also be a bit hard. And we also need to understand when to send notifications, understand which kind of data to show. So our goal here is to provide you data you can do something about it, you can act on. So we want to clean this up and show you something with value. So I had several questions, but actually the biggest question here is, are there smarter ways to filter noise, to filter the data that really interests you? So if you have other ideas, I'm open to discuss. I was discussing with another person yesterday regarding doing some machine learning, maybe. So this is the current proposed model. So if you have any ideas, I'm happy to hear about.
So about filtering like the noise. So I think one problem that we've seen like in the past on the kernel CI reports was that sometimes you would have a lot of false positives, and it is sometimes then a bit hard to understand like which of the reports are actually relevant for you or not. And so when you create those issues, is there maybe a way to say certain issues are like basically on my like whitelist? I don't care about them, and like, yeah, so have you thought about something like that?
Yes. Well, the idea that I had was like to be able to subscribe or unsubscribe to the issues, but yet you would need to check each issue individually. So I'm not entirely sure how to do it more automatically. Yeah, so this is a problem that we need to understand better.
I mean, if we talk about false positives, you probably can't do it automatically because someone has to identify that that is a false positive first. But yeah, maybe just a...
So, well, what happens, I think, is that you get a test case that gets a lot of false positives. So if you could, like, opt out on an individual test case name, right, and you see a bunch of people opting out on that, maybe that tells you need to go look at the test and fix the test.
Yeah.
So I guess my assertion would be let people opt out at individual test case granularity.
That's exactly the case like of the device testing stuff. Like we were seeing a lot of flakiness, and then okay, let's write a test for it. Let's write a better test.
Okay, so we'll move to the next part.
Thank you.
So data analysis and automation. This is a topic that we touched upon Plumbers last year as well. And it has to do with the fact that we have this massive amount of test results information and kernel build information in KCIDB. And that's good on its own because we can do a lot of stuff with it. We can browse it and generate reports from it. But there must be a lot of information hidden down there that's not readily available for us to use unless we do some kind of processing or analysis on it to digest it and kind of extract that hidden information. So in other words, what we want to do is to use the data we have already to extract information from it and then use that information to automate the processing of additional data. So there are, of course, must be like a million ways to do this. This is an open problem. It's by no means a well-defined problem at all. But like the first use case we thought about was, and probably one of the most interesting ones, is to be able to characterize known error information and to use that information to be able to perform automatic matching in the new results that we get. So in theory, if we are able to do this, there are new features that we get that we didn't have before, such as the possibility of classifying errors by type, provide new enhancements and possibilities for queries in the database, and probably find patterns as well. So how are we doing this for now? Well, I think the main idea is that if we can find a way to automatically profile an error, and by profiling I mean to be able to uniquely identify an error type, then we have a way to compare errors together and match them against each other. So we wrote a very simple proof of concept, a very simple tool, which is basically a context-sensitive parser for logs, and we'll see how it works in a while. The question is, where are we getting this information from? Right now, build logs and test logs, including kernel boot logs and etc. So this is far from ideal, and we are aware of that. In an ideal world, we would get that information straight away from the kernel or from the tools in a well-specified way and a structured way, so we can just put it in the database and use it directly. And I know that GCC, for example, can provide the error information as a JSON object instead of just as regular standard error output. But that's a particular case for a tool. We don't have anything like that for the kernel. Each test may provide the output in a different way, even though there are standards and there's KTAP and all that. But we are not there yet. So this is just an experiment to see how far we can get with just logs. So the way we are doing it is, well, this tool and the associated scripts basically take a log output, which is basically what we have right now in KCIDB, a large number of results and a large number of pointers to logs, and do some specific parsing depending on the case, depending on the type of log. If we find an error, something that looks like an error in a kind of a structured way, we turn that into structured data, and then we get a signature for that. The signature in this case might be just a hash. And then submit that automatically as an issue in KCIDB so we can have it as a reference. What we gain this way is once we reach that point, we can now use that structured data to do specific queries that we couldn't do before without it. And we can use the signatures, these kind of unique identifiers, to match new test results with the issues that we have already in the database automatically. So here's a simple example. This is a fragment of UBSAN. I don't know if people at the bottom can see it, but this is an example output from a UBSAN as you would find it in a kernel log. And this is what the tool we get from that, which is it has something like an extractor. It's not standard at all. It's just an experiment. But it will tell you this is this kind of error, and this is a summary, and it happens in this file, in this hardware, etc. So you can extract a kind of signature for this particular instance of that error. And then you can link all the test results where that error happens all across the database automatically. This is an example using the Grafana dashboard that Helen shown before. Different example, this is with the kernel build, compiler error. It's actually a warning that's considered an error because of the -w error flag. And this is what the tool would get from it. Again, a summary of it. Type of error in this file, this was the target file, and in that makefile script. So as much as you can get just by parsing using silly regular expression from the log. This is just another example of another kind of, this is a kernel warning, and this shows how we find logs normally, which are not always clean, sometimes with a lot of lines, unrelated lines in between. If you're careful enough, you can kind of write a parser that is robust enough to be able to parse that into something useful. Again, this is all best effort. It's very fragile. If the format of the reports change, this will break, so you have to maintain the parser. So again, just a way to showcase an idea rather than a final solution. But the good thing is that once we have that into the database, now you have something for free, which is the ability to do queries that you couldn't do before. So we can still perform this kind of queries like, give me all the tests that fail in this kernel version for this tree and branch, for this kind of hardware, etc. But now we can say things like, give me all the errors that were kernel warnings in this source file, for instance. And from that, you can tell, now give me all the tests that failed and contained that error, which is pretty neat. I'm sure there are many other ways to apply the same principle to other type of functionalities, but it's just like the first example that we came about. And that's pretty much it. Any feedback that you have is more than welcome. There are open questions about how to integrate this into the workflow, and how would you like to use this kind of stuff? What other tools would you like to have integrated? And I think I have a question over there.
Okay, so I might sound like a broken record a bit, but like what I talked about at like Ray's talk with like the thing of doing the parsing of like the errors and the warnings of the build log in the kernel, like especially as you said, for example, when the format changes, then you have to like maintain the parser that you have there so that it works again, because it breaks easily. So I feel like the natural location, like for now, seems to be the kernel, so that you have that parser in the kernel, because then if the format changes, you know, yeah, the parser is in the same tree. And then obviously, as you said, like not obviously, but what David basically told me is that the best location is that we get the errors directly from GCC or from CLang then, basically. And so, but I suppose that will probably take a while until we have the proper GCC version then for the kernel. So in the meantime, I feel like the right location should be the kernel instead of doing that in user space. Yeah, and so any thoughts on that?
I totally agree. I mean, the issue, in my opinion, should be addressed right at the source. I mean, the kernel has the information about the errors. It's only a matter of choice how you provide that information. So I don't know if there is any initiative to provide a standard interface to publish that information for other tools to consume. But in my opinion, that should be the way to go. Until we get to that point, we have to rely on logs.
Yeah. And so basically, the reason why you choose to do that first in user space now for this experiment was basically convenience for now.
I choose to do it that way just because it was the easiest way to hack something to have a proof of concept. Not necessarily because it's the best solution that we can find so far. So
okay.
Just a test.
Yeah, and I think the following question would then probably be like, Okay, so you could get the build warnings and errors a bit easier if you do that directly in the kernel, and then the question following that would be then how you handle like the warnings and like the panics. I assume it might be possible to store that also as a kind of JSON when it happens. Not sure, maybe someone has like an idea on that.
I think someone else can give an answer to that. I don't have it.
I want to see JSON and oopses. So, I mean, I'd rather human readable. And if you want to regularize the error output in the kernel, I think that's great. But I still think just getting it from the logs is the best way forward. Because as a kernel developer, I want human readable is more important to me for the moment. Right.
But I don't think they are mutually exclusive. I mean, you can still have the logs and then provide.
I mean, if you have enough oomph left in the kernel to also emit the JSON after the oops, that's fine. but oops first.
Thanks. I'm sorry if I'm plugging a little bit here. So when you said the other CI systems can send their data too, they're actually sending. There's about 8, except Maestro. Well, 7, 8, I don't remember. It keeps changing sometimes. So there are systems sending data into KCIDB right now, and in total we get like quite a bit of test results. I'm not going to lie, like maybe 1 million per day test results. And also when Helen said that we have Grafana, we actually have 3. 3 Grafanas, and we keep working and trying to converge in something that satisfies all of us. And yeah, if you're interested in any piece of data that we can have in KCIDB, come to us. We'll make you a little dashboard for your specifications or give you our little folder where you can play around with it and get your data. Regarding issues, Red Hat also sends issues, and they have different workflow. They have an army of QE people who look after test results and then submit issues in our internal systems. And they describe how to find them in which log files, etc., etc. And these issues are submitted to KCIDB in a reduced shape right now, but also the incidents. So you can go to a test result and see which issues appeared in this test result. You can go to revision to see which issues appeared in a revision specifically, or in the build, etc. And from the issue you can see which test results were affected. And we also have issues for builds as well. So if there is some particular build issue that you don't want, for example, kernel developers to be bothered about, you can say, this is an issue, and ignore this failure. Something like that. Yeah, that's all. Yes?
Just a quick question. How long do you expect to keep the test logs and test reports in KCIDB?
I think this might be a question for Nikolai.
So we are preparing to have some sort of service level agreement. With that, we have like some beginnings of the system for caching those test results and the artifacts. And we'll have to come up with some rules that more or less easy to explain, but the plan is to maintain a certain length of time, particular files, etc. Not only to provide you with the possibility of downloading them, but because we need to use them for triaging, the same thing, and retriaging. For example, an issue has changed, we have to retriage it. So yes, there's going to be an archive. At the moment, we have a test system running which archives every 256th file. And if it's under 5 megabytes, otherwise, if it's not cached, it will send you to original URL for now. So it's on the CI, particular CI system at the moment to keep the files. But yes, we plan to store them.
That's actually another good reason to do the processing, so we can extract what we need from the logs and then forget about it and keep the important parts.
Yeah, this is also possible. We can keep those pieces of logs in the database. And we have a field called log excerpt where you can put the most relevant piece of log when reporting the issue, and that's kept in the database. Yes.
Yeah, on Helen's question about filtering noise, I think there will be different categories for the noise itself. But I thought one thing that we see on our side is cases where the test didn't even run because there was system failure or some type of instability in a test. And so if you require that the test follow some structure and indicate clearly the start and the end, then you could filter the ones that don't contain those starts and the ends, and therefore those would become part of that noise. I'm sure there are other sources for the noise, but some of that will be clear.
Yeah, thank you for the talk. In terms of that signature, looks like it's kind of a hash. From those, different data. You were showing earlier. Shouldn't it be, more coming from some minimum logs? It seems to me that there are too much information in the, how you're getting the hash. So I think it's very likely that it will end up with a lot of different signature, which is actually pointing to the same issues and so on.
Right, that's a good point. It depends on, in the end you have to decide which fields you need for each kind of error, because there's this balance about being overly specific and having a large number of different issues, or being not enough specific and losing information. That's something to analyze on a case-per-case basis. Basically, that's what I did. I'm taking like 3 different cases, like KBL failures, kernel failures during boot, and that's about it. And trying to be as specific as possible. But thank you. But yeah, you're right. And this is something to be addressed. Yeah. Over there.
So isn't Sysbot doing some of the, in terms of their collection of tracing? Like I thought they had a thing already that could take crash dumps and kind of get a sense of which types of crashes are kind of similar and categorize them into buckets. And surely like people that are shipping Linux commercially, I know Android, Chromebooks and all those, they're collecting crash dumps from the field all the time and doing some sort of analysis. So it seems like there's got to be plenty of overlap in commercial offerings that are already doing this that we should be sharing. But I know Sysbot at least is doing some of this. I just don't know exactly how. So.
I think they just look at the first line and kind of sanitize it lightly. This one looks much nicer than what they have.
So I'll try to be quick. Yes, Sysbot does that. They do a very good job identifying it. They have their own magic. And Dmitry was here. I don't know. He's not here in the room, but he's at the conference. You can go and ask him. But there are many ways to do this. I suppose at Red Hat there is a person who is doing it with machine learning tools, identifying the clusters and everything, grouping them, and we're going to be using that. Perhaps we'll try to deploy that. But if you have your own ideas of how to extract issues, how to identify them, etc., you're welcome to join and deploy your own, extractor. So the database is open to like different ways of extracting this information as long as you can express it in the schema. Like Ricardo worked on one way, we can have another way, and there is namespacing in the database, so you can have your own IDs, your own playground. You can do your own hashing. Yes, hashing is difficult, but like only the person who makes the parser and extractor can decide like what goes into the hash because they know how it behaves and that's where it comes from. So it depends, right? So if anybody has any wild ideas or not so wild ideas, if you want to parse logs or whatever, come over, we'll plug you in and we'll just have to clearly mark where it's coming from so people can use that. Okay. Okay.
Just a quick, I'll second the plug. So at least KCIDB, you've got a whole bunch of logs that you can test your parsers on. So.
Okay, I think we are over time now. Thanks a lot.
So I think
Sorry?
You're coming to the evening event?
Yeah.
so next, just more examples. I think. And this is the second last example and the final example. And now we're getting back to the newly inserted page about the questions and instructions. I think it's good. What's the next one? Oh, hold on, I see. Yeah. That back to the previous slide. Just discussion. You can have a discussion. It's further.
But it's, you have to be fixed right now. What about next year?
Yeah.
Maybe next year, like, you don't need to fix it.
Depending on which conference to go.
No, I mean, like, LPC, I guess, like, you're going to keep talking here.
Okay.
Honestly.
That's why I thought I'd just go through the slides to see if something.
Oh yeah, the green's.
Okay. I just go to the next slides and you can complain if there's something more. That's okay.
Hello, Philippe and Kate, can you hear me?
Yeah, I was looking for a plug. Do you need a plug-in?
No, I've got my I plugged in at the desk.
So you charged.
And so I've got my laptop's thing down. So you can get it.
You deleted all the other slides, or I can simply create a PDF after I've changed and upload.
I basically I gave you access to it, and I basically went out of. I went your slide because of all the other things. Yeah, I deleted everything else. I just kept it very simple. And then I basically it's in a different file right now.
You reshared it, right?
Yeah, I reshared it. And I just because that was having weird formatting issues because it was coming from PBDX. So it was good.
But I had already when I downloaded the other one.
Yeah, it was problematic mildly, and so I hacked it. Something wrong. Read is short. No, it's got PBTX on it. It is not a PBTX one. Let me go get the file.
But it's not. Let me just. Yeah, where do you look? I see that.
Who left the rock stuff there?
Uh-oh.
Yes, yes, fine, yes, I know you. Sorry.
It's no longer. Ah. I see.
Hello, guys, can you hear me?
Yes. Olivier, we can hear you.
Thank you. Okay, thank you.
I don't know how you can hear me, but.
I can hear you as well, Philippe.
Wonderful. Not even being at the microphone.
Is the mic working here?
I guess this microphone definitely works, I guess. Yes.
Yeah. It's working pretty well.
Really narrow guys, where you stand in, speaking from the back. Someone said, I bring you a microphone, and he said, I don't need a microphone. I have an inbuilt amplifier. Very cool. What's Zach Pfeffer? In case you know him.
and I'm here with my laptop, you know.
And her
I'm
cake.
kidding, I'm kidding.
Oh, thank you.
You've got one, you've got one, right?
Oh, wow.
So you give one to people and I give one too.
There's a T-Dex too. Nice. Thank you.
I do a lot of favors for the staff. Sometimes they'll do favors for me if there's extras, so they give them to me. Without you.
That's wonderful.
I'm going right now. Sorry. Works, yeah, I get you, sorry. Okay, so that one. Shut that one out, Kate. Yeah, let's see what. This is here. Yeah, I know. Well, I gave it to the cat, not my dad, that's my bad, sorry. There it is right now. Anyway, just need to go to it. Yep, that's what we use as well. Just do transparent in the center here, it's working out just fine. Yes, I don't program anymore, I program. Google that one, Google presentations. I don't program anymore. Oh, yeah. I think PowerPoint. Look at this.
Ah, beat me to it.
What?
I'm just cleaning up some of the
things I missed.
One. Here.
It's nicely organized too. This document, we can all collaborate and just add stuff to it.
Philip is awesome at organizing things. He's a delight to work with, that's all I'm going to say.
There you go.
I'm a fan.
Just clear out your LinkedIn profile, just put that right there. Delight to work with Kate Stewart.
Yesterday,
You're hired.
I had this nice moment. I went to the Colonel CI. When I came in, there was one guy, and the first word he said was like, I know you. You're showing up far too often on LinkedIn.
That's really cool.
Far too often.
That's really cool.
I find like, yeah, that's like...
It's a sign from the universe.
Yeah, that's showing up far too often.
Far too often, yes.
So I got me a tea, and then we're
They have, by the way, at the reception desk right now, they put out all the extra t-shirts if you want to grab extras.
I grabbed one for our
Okay, they also fit it if you want to take one for your wife. Oh, then never mind that.
She's already complaining that when I wear open source t-shirt on the weekends.
Oh, she does? Okay.
Hey Kate, my son is graduating today from paramedic. I hope you never have to meet him under the wrong circumstances, but he will be there if you need him.
If you want an extra t-shirts, they're right by your reception desk right now. They just put the extras.
The list of t-shirts. Oh, those. Okay. I grabbed one already.
Oh, you've already grabbed the second?
Oh, yeah.
You grabbed your second?
I didn't grab a second.
No, you get one when you come in, but when you have extras at the end of the conference, they always put them up there.
I'm proud of. I usually don't pick up the OSSNA, but I do. I'm proud of the plumbers shirts. I wear them. I'll go grab one when I go out.
If they're there.
Yeah.
Yeah, that'd be, that's just whatever is your ass. I mean, essentially,
branching diagrams to function it out. Take this.
And I should go for the other side slides.
Okay, well, we need to go back to the other one though.
Yeah, we
So
do
we
the
have
default
thank
one.
sponsors.
Yep.
Okay, you take presenter. Fine, you got it. You can see it.
Okay. So I guess we can start. We're exactly as per the second. First of all, that's the Safe Systems for Linux microconference. I would like to thank our sponsors of Plumbers. So without these sponsors, this would not be possible. So thank you very much for this. And then also important that we take a short look and on the anti-harassment policy. I would summarize it up with being excellent to each other, keep the discussions technical, don't become personal. If you get emotional, take a deep breath and calm down a little bit. We're talking about safety. I know discussions can become sometimes quite emotional. And we don't need the break thing. This comes for later. So I just jump over to the first slides. It's a new one, +1, latest +1, right? Latest +1, this sounds good, last minute changes. Couldn't be better. It's really just like the very quick starting point, settle the scene for the next 3.5 hours, including our nice little break in between. Slide set is by Kate and me. And just to get you an understanding, we have already safety in safety critical system around there which use Linux. Well, Tesla is one example. We don't see too much from them in the open on their work, but actually that's running in there, and that's just an example car. So there are many other cars which also make use of Linux, like in Asia. And of course also in space, right? So that's super cool. It's another kind of safety criticality also, but I mean, it's human life, rockets, and you know that you have a risk when you go there into space, but well, maybe you're expecting another kind of risk when you take a car. That's just two examples. Other industries are medical, industrial applications, and so on. So it's just like heading this up. And a little bit on the definition of it, so we know, okay, that's the scene in which we are. As per the definition, I guess it was the one from, Nicole, you took it from Wikipedia or somewhere around or somewhere. Yeah, but it's like definition of safety is the freedom from unacceptable risk of physical injury or of damage of the health of people, either directly or indirectly, because of damage of the property of the environment. A little bit lengthy, but basically it's like you want to prevent hurt from people, potentially animals. You could also treat this as a safety element in there. And the functional safety is like the part of the safety that depends on the system or equipment operating correctly in the response to its inputs. So it means like how does the system behave in the environment. And you would like to see that you detect any dangerous conditions, you want to make sure that it operates as it is expected, that you prevent potential hazards by the mechanisms which you implement. So it's like looking on a more rigorous part. And as this confusion sometimes pops up, I hope, as you decided to come here, you're aware that there is the difference between the safety and the security part, while there's strong overlaps and a bunch of former security people became safety people. That's on that. And what you typically expect, and I guess that goes to the focus on what we have here, that a system or software behaves as specified, and it also must not impair or interfere with other system components. This may be also a strong difference to what you know from the security side, because in security you would say, oh, I have my container, I'm good in my container, I know my environment. And for safety part you would say, well, could the one container impact another container? And if you take it more on the hardware side, you could imagine like if there's a heavy GPU load thing, while your safety application runs on the CPU, the GPU heats up, you go into dynamic voltage frequency scaling and so on, and suddenly you impact your scheduling mechanisms because there's not so much load which you can handle. So it's like interference which you can keep in mind. And then you also need to show later on to authorities, and you also want it for yourself, that you have evidence on whatever you've done and that you really covered the erroneous cases. somehow or somewhere. So it doesn't need to be directly in Linux. It could also be in the system environment around it with hardware measures or whatever. Right. And this is just a list of sample standards. It says integrity standards, which you can see. The interesting difference between a safety standard and an integrity standard, which makes it more complicated. A safety standard would tell you, oh, you have like for the safety standards for toys, which tell you how long you need to put them under fire until they are allowed to start burning, something like this. They give you clear instructions what you do. The integrity standards basically just define procedures and say then, yeah, these are best practices from process side, from other parts, and here's requirements, here's evidence on this. So it's basically looking into this, and you need to test a lot, but it just describes methodology and not like what is your threshold or part of it at the end. Right, and all these different standards which you have seen from all the different kind of industry, it often boils down that you need to have kind of a requirement, like what do you expect from this? It's being explicit about the assertion, and then you have testing a lot, you have evidence on what you have done, on your verification, you have to document a whole lot of things. So someone said it's like 20% is like your normal work, and when it comes to safety, you add like 80% of testing and documentation of the same things, and you try to get this traceable. Right, and there are ways for traceability, which is a perfect handover to Kate.
Yeah, so one of the biggest realizations for me when I started working in this area was you only look at safety in terms of a system. And something like the Linux kernel is a component in a system, but it'll be used in a context of that system. And the interesting thing is that if you're having a system that has some safe usage requirements, it's going to have various needs. And those needs are going to be matched up by effectively assertions about that component or requirements or things that the expectations of what you expect that requirement to do, that component to do. And all those traditional standards that Philip was just showing you, they are lined up with this mental model in mind, okay? That they had access to what the assertions are or the requirements on the component are, and you have specific needs that are being satisfied. And when you can do that full traceability across that system, that's when you know you're done. And you have the evidence to show it. That's when you basically can say, okay, I know it's going to stay safe. So our challenge right now with these components is the fact that open source, sorry, I guess I have to stay by the mic. Open source doesn't have this concept of surfacing out what the assertions are about the code, what the functions are. And in particular, with the Linux kernel, every time we put a patch request in, there's information about why we're putting it in and when it should be working as part of the pull request. If you have effectively your 00 patch to explain why you're doing this, that is effectively the assertions as to why. So the elements of this exist, but we have not made them available in a systemic fashion throughout the industry. So part of the challenge is going to be now is how can we start to make this information visible and where? So what we've got is, each patch does have a reason to be added. And, it is, oh, this is so small I can't barely see it here. Yes, old eyes, what can I say? But, there's a context that you expect a patch to work in. Okay, do you have a hand? You have, okay.
Wait, no, I'm just saying I could you just have to do
okay. And
now you could read it.
Oh, thank you. Blessings on you, Stephen. So we also know that when we actually put changes in, we have to test them and prove that it's working, it's doing what we wanted it to do functionally. But we also have the concept of when does it not work? And you have ways of making it better too? Oh, thank you. Okay, I'm being taken care of, I love it. But proving when something is not working as you expected, it's going to go into a safe state is something we generally don't traditionally think about sometimes. everyone's focused on getting the functionality working, show it what's working, but if something goes disastrously wrong, will it become in a reasonably safe state? And so what we're trying to expect and being able to capture that in a machine-readable form so that we can start to put tooling around it is, I think, a path towards automating this stuff. The same way we're starting to see us improve the transparency of what software we're running with SBOMs and things like that, we need to improve the transparency of what we expect the code to be doing so that we can link it to the tests in things like kernel CI and actually know if you make an update, it's going to be sane. So giving us a way of making assertions about what the code should do and in which context is a big missing piece for us to actually start to hook up and put automation in place. And I'm pretty much convinced, you know, we're not going to expect the maintainers to do it, flat out. If they want to, they can. I'm not going to say that. I'm not going to say that they can't. But realistically, there are people who have vested interests in making sure that we have build some common understanding. The same way that the source code is effectively a standard way for us to share together and work, we need to basically start to have the documentation of the assertions of what the source code is doing shared and reviewed at the system at a wider level. So my hope is maybe that the maintainers will at least review these assertions that people are coming up with and saying, yes, my code is actually doing that. Or no, you've got it completely wrong, which is useful. Go ahead. You want to throw the catch box? Where'd it go? Ah, there, it's sitting at the end. Yeah, Tracy's stringing it on.
Okay.
Thanks.
So we maintainers are already overloaded.
I know,
And we
that's
already
right.
have a challenge. So
I know.
what motivates us to review a documentation problem?
It's better if I, who don't maintain your code, have looked at your code and came up with a wildly incorrect idea about what it does. You can help me correct that. Then I'm going to create requirements or assertions from that, and you're going to go, no, you're still wrong. You don't know what you're talking about. And I'm going to keep narrowing down until I get it, until I really understand it. And then I'm going to say, is this it? And you're going to go, actually, that is it, but that's wrong now that we've reasoned through and really understand better. We've actually required ourselves to write this down and start thinking it through. Now you're going to realize, oh man, you're making me think this through a lot more too. Interesting. I came up with some bad ideas. That's the idea. We don't expect you to do it, but we expect you to at least help us and tell me I'm being stupid and how do I become less stupid, and then maybe something might reflect back on you and we go, oh, actually, no, I didn't even think of it at that level either.
And the other thing I'll add into this, and what will be hopefully beneficial to you down the road, is once we have these assertions in place, we should be able to link the tests that prove these assertions there, such that you have a better regression suite and you'll have higher quality of coverage after you do security fixes. The goal here is we need to be able to, if you talk to Greg, he'll give you the stats on how often we're putting CVEs in right now, right? And if you're putting a CVE and you want to make sure that you're minimizing your regression chances, thank you very much. And if we have a set of test cases we have affiliated with a piece of functionality, and we know which files are touching these different requirements, we have a way of now starting to improve the quality of the regressions and making sure we have minimized regressions, especially in the place of security fixes, which is missing today. And so hopefully that will improve the quality of a maintainer's life.
Maybe you can think of it like a shadow stack for design.
Okay, but let's keep going so that we can. Okay.
Kate said what I was going to say. So.
What? Oh, you said.
You said what I was going to say.
Okay, so. Thanks. And so, once we can clarify this missing piece of the assertions, you know, linking the code and linking the test to them is possible. We are prototyping it right now in Zephyr, so we should be able to do the same thing in the kernel. And so, if we can do that, we suddenly become a way to automating a lot of mess out of the things, and quite frankly, improving the sustainability of the kernel and possibly getting rid of some things that are no longer needed, cleaned up. But, oops, there we go. Nope. There. So this afternoon's talks, and keep me on time here, because I think I'm looking.
Yeah, the last minute.
I'm the last minute, okay. So in the schedule, you'll see where we're going to be touching on a lot of these aspects that need to be pulled together to make this happen. And the key here, though, is, we need to understand all the system elements. We have to select the components in the context for things, and then we have to identify gaps to make things safe. And if we can start to get this more engineering-wise, more automated, I think we'll be in a better place for dealing with when people are using Linux in contexts that have safety requirements. Because they're doing it now, and I know people who have left certain organizations because they didn't like what they were seeing and they didn't want to be associated with working with Linux on that, because of the quality issues and because they were worried about people. And I don't think any of us want that in this room. And so with that, I will queue up the next one. Thank you.
So the next one is Matthias. There you go.
And come up, Matthias, and let me help Bert.io. Okay. Do you want to be in full screen mode too?
Is this possible?
It is. Now that I know it's possible. Thank you.
To switch, I can just.
I think this should actually. Well, oh, the keys work anyhow. Thank you.
The keywords.
What?
Okay.
The dongle needs to be in. Okay.
Right. Okay. Cool. Thank you.
I can't see it from that angle, so you can let you guys do it.
Go ahead.
Okay.
No, I doesn't have here. It doesn't have either here.
Okay, sorry.
It is. Yeah, it's fit. Okay, hello everyone. I'm Matthias. I work at Red Hat, and in this presentation, I'm going to talk about a work in progress I'm doing to try to see if we can find violation of the Virtual specifications in a more systematic way. And yeah, this is a work in progress, so I'm not going to propose any concrete solution, but the idea was just to have the discussion. And so for those that you are not familiar for Virtual, Virtual contains the definitions of drivers and devices and how they interact. Also, feel free to interrupt me if you have any questions, because I'm going to run out of slides soon. And so yeah, the Virtual specification contains the definitions of drivers and devices and how they interact. The drivers are meant to be deployed in an operating system that they are going to be a virtual machine, and the devices are meant to be implemented in virtual machine monitors, and the idea is they are going to emulate some physical device, right? We have different implementations of the drivers, like depending on the operating system. So you have Windows and Linux, and then you have different implementation of the devices, depending on the virtual machine monitors with different technologies. So for example, you have QMC, RASMEMN in RAS, libkrun in RAS, and so on. So even if we have different implementations of the driver and the devices, all conform to the Virtual specifications. What I have been reviewing patches to the specification, but also implementing different devices, and I can say that it's sometimes tricky. One of the problems that I found was sometimes we have patches to the specification that they are, for sure, the specification is written in natural English. Authors sometimes means one thing and we interpret another thing, so there's some ambiguity there. And also when we have, for example, a new Virtual device, we don't really know how to test it. So what I do, for example, is I pick up one driver and I pick up a device, I do some stuff, let's say, for example, Virtual console, so I send something from the virtual machine to the host and to the host back, something like this, but I don't have any systematic way to, for example, figure out if the implementation conforms to the specification. So, and also any violation of the spec, I will consider that as a bug. So to open the discussion, I want to talk about one issue we have with the Virtual sound driver last year, and you have the discussion there, and I try to make an illustration about how Virtual sound works, more or less. So we have the guest, and we have the host. In the middle, we have the Virtue, And if we want to reproduce something, I'm talking about sound in the host, what the driver is going to do is to fill the available rim buffer, which is, as I said before, is a rim buffer, and then the device is going to consume these buffers, and then put it again in the user rim. Here I brought some of the functions that the driver uses. So for example, in this case, this is what is executed in the context of the interruption. So the device consumes the buffer, triggers the interruption, the function is triggered during the interruption, and then what the driver was doing at that time is just taking the buffer and put it again in the available rim. If we see how the buffers were made, the driver was creating the buffers from a region of memory that was shared with the user application. So when the user applications wanted to play back something, it's going just to query the position with that function, with the virtual PCM pointer, and get an address in which it's going to write something, right? So in this diagram, what I highlight is the buffer that the device is consuming at that moment. So if we move to the next slide, the device starts to consume the next buffer, but then the driver put again the buffer in the available rim. At that moment, the user application at some time is going to query the position and start to fill the new buffer. But what we can see here is that the buffer is already in the available rim and is already exposed to the device. And this is a violation of the spec because, as we know from the spec, the device can pick up this buffer at any time. And this is exactly what happened in our case. We were picking the buffer in the moment that the buffer was available in the available ring. And the thing is, we should not do it at that time. We have to wait a bit, otherwise we get old content. But in that case, the driver was not behaving as the spec meant to. So if we see the traces, this is not a good trace because I created with print K. We have to use something else like trace point or something else. What I can see here is first the adding of the buffer in the available ring. At some point, we can see that the user queried the position, and at another moment after, we see that the device consumed it. But what we say is this pattern is a violation of the specification because you cannot write when the buffer is already in the available ring. So this is something that we like to detect early and say there is something wrong, let's say. I use this as a use case, but you can find other examples in which there are some resulting implementation in which we violate the partial order that the specification defines. So what is the proposal that I tried to do in this presentation? And something that is not concrete at all, it's just an idea. So first, define the virtual specification with less ambiguity, let's say using a formal language, for example. I'm not saying to define everything in a formal language, just some part that we can leverage something to the fact that doing it. Second, from the specification, try to build runtime observers that will detect violations. And what I'm thinking is that we could extend the virtual specification itself by adding this formal specification, not only English, but something formal. Again, I'm not saying to do it for all the spec, just depending on your formalist, you are going to be able to do it for some part. And for the first part, for the first item, I wanted to propose, for example, finite automata, which is another formalist. And this is the description of what I would like to detect based on the use case that I presented before. So, usually speaking, let's see, that work? Yeah. When the buffer is in the VRIN, it's not in the VRIN, we are going to be able to write it. If it is in the VRIN, this is going to trigger an error, basically. the model could be different depending on how precise you want to do. The idea of this is to propose a formalism more than the model itself, let's say. The other formalism that I was also playing with is a language called clock constraint specification language, in which the invocation of a function is modeled with a clock. And we can imagine that each tick of a clock is the invocation of a function. I will going to create 3 clocks, for example, 1 for each function. And then I will go to specify a relationship, a temporal relationship between the instance of these clocks. In this case, I used alternate with, which has a precise semantics, and this is the result of the simulation of this specification. This is what you can see as how I would like that things happen. And the second item that I presented before is, well, okay, we have a formal specification, how we consume it. And for the moment, I have been thinking 2 things. First is use the current runtime monitors that are in the kernel, so that they already accept finite state machine as a formalist. And then you build a kernel module that is going to observe certain trace point. In this case, since I'm talking about Virt.io, will be some trace points in the Virt.io drivers. And then, since I am interested in the vhost user devices, which are in Rust, in the Rust BMM project, I was thinking to implement a tracer that not only you instrument in the code to say, well, the code passes here and so on, you will accept also as an input the formal specification. So the traces, we're going to do 2 things. So first, going to tell you that the code executes something, but at the same time, you will feed the tracer with the formal specification, and if something is wrong in the event that, in the sequence of the event that execute, something is going to happen, I don't know, warning or whatever. So I'm starting to work on this because I'm recently playing with Rust, and I wanted to know how to implement a tracer in general, but the code would look like something like this, let's say. So for example, here you can say you have some annotations in the Rust defining some event, which correspond with some definitions. Sorry. So you have some annotation in the code, in the definition of the function. And here I add some properties like an event, the event name. Then this is a very simple case for sure. Then at some point in my program, I'm going to instantiate the constraints. So I say, well, this is an alternate between these 2 events. And then I will go into instantiate the tracer. So for example, in this case, just for playing, I execute in this order. So this invocation is going to trigger a violation of the specification. There are several things that you can see here. This is a toy example. I'm trying to play with Rust BMN and see how can I instrument this, but in something more serious, like Virt.io Sound, Virt.io VSOC, or some other vhost user device. And you should know, in this case, I use this relationship between the event, but it could be something else. You can, for example, if you have a state machine, you can instantiate a state machine and write this in another way. So yeah, that is what I have to show. I don't know if someone has any questions. I don't know, you have the thing.
Hi. Yeah, thanks for the talk. Very nice. I'm actually also a Rust VMM maintainer. I think we've talked on Rust VMM before. So I've also had the idea of applying formal verification to Rust VMM before, also because on Firecracker we've actually done something quite similar to what you're proposing here, not with the device drivers, but with our Virt.io devices, where for part of our Virt.io queue implementation, we do actually have a handful of formal proofs that try to make sure that what we do in Firecracker conforms to the VirtIO spec. What I was just wondering about is, so if you do this sort of like tracing style approach where you execute your program, I'm assuming once, and you collect the trace from it, that's not, because for formal verification, what you kind of want to do is you want to make sure that for all possible inputs that your program could possibly receive, you will always conform to the spec, or you will always uphold some sort of invariant that you want upheld. Whereas with this tracing approach, don't you only verify that one specific execution flow, say some unit test, conforms to the spec? So how do you plan to cover all possible inputs?
No, but you're right. Yeah, I had the same question. Yeah, I was talking with someone, and maybe we can use a fuser to try to increment the coverage, for example. But yeah, what you say is exactly right. Yeah, I don't know. Yeah, I mean, what I missed to say at the beginning was I could not be exhaustive.
All right, so in that case, I do have a suggestion. Because what we use in Firecracker, and I have a disclaimer, I'm from AWS, the tool I'm about to suggest is also from AWS. But we do have what we call the Carney verifier, and it's a formal verification tool based on bounded model checking for Rust code, which it has a similar approach to what you're proposing, where you describe your specification in Rust code, and it does do the exhaustive thing. So you define non-deterministic variables, and then you have unit tests looking like proof harnesses, where you just take non-deterministic inputs, you just pass them to whatever function that you want to verify. You don't need to modify the function. Then at the end, you just write an assertion, and you run it under Carney, which is a compiler plugin, in a way, and it will do the formal verification for you. So maybe you could have a look at that.
Yeah, I will. Thank you very much.
Yeah. I don't trust myself to throw that far.
One thing to remember also, when you're declaring design, that is just a form of invariant, right? So when you just say, this is my expectations of a thing, that means I'm holding that invariant, and then the rest can vary, which means your testing and all that is much more simplified as compared to a formal verification, which, except for loops, has almost no invariance in there. So there is a difference. So then I'll pose the question to you. Were you shooting for an invariant-based analysis or a provability analysis? They are different.
Yeah, I don't know.
Okay,
I don't know
great.
the answer. Yeah.
Great.
Sorry.
Thank you. Well, first of all, I'm very glad that I see somebody making use of the work that I think was started by Daniel.
Yeah.
Right?
Well, yeah, yeah.
And,
well, we have. Sorry, I interrupt you, but we had a discussion with Daniel about this. I think it was 4 years ago. So yeah. Mm-hmm.
Yeah. But my question is, I didn't understand. So are you trying to design a runtime verification monitor for an instance of a driver, or for the VirtIO framework to monitor, any driver to behave according to the specification?
Yeah, that is a good question, because I had also the same question. For this case, VirtIO Sound was easy to do it, but the idea is to do it for any VirtIO device, which I'm not really sure how easy it is to do that actually.
Mm-hmm.
Yeah. But the idea, since all VirtIO devices do more or less the same, so you put something in a variable and consume and so on, this have it true for all the devices. And the idea would be to generalize it, but I don't know how easy it would be that.
I think, I don't know, but I think that maybe most important thing is to do it incrementally. As in, I don't think you need to start with the greatest, with the perfect.
No, I agree. Yeah.
See what I mean? Mm-hmm. So the important thing is basically, if you start capturing, the main states of the.
Yeah.
That would represent, the specification, then maybe you can build on top and refine it.
Yeah, I think so. Yeah. Maybe someone else has a question.
Oh.
Just to let you know, my background is not 100% in formal language, so maybe that is the reason why I couldn't answer you. Sorry, but I did my PhD on that. But I are for sure topics I don't know.
Yeah, so first of all, a great idea, and I have several things to say. One, recently I saw a lot of people trying to implement hardware and then coming to Windows drivers and saying, oh, something is not working, something is crashing, and mostly it was because the spec was not correctly implemented in the hardware itself. So it would be nice to have some kind of a framework verifying the hardware implementation.
Yeah, sorry I interrupt you, but yeah, I mean, in this presentation I did just one problem, but I already identify a few. So we have a sort of families, let's say.
Second thing, if you look at the kind of more complicated devices like network, then we have things like feature dependency, and depending on the feature, you have, for example, virtual net header size changes. So how do you think about handling those?
I don't know, because I know that there is a limitation of the formal list that I'm using. So in the formal list, for example, in CCSA, I don't have ways to model something like this.
I think let's discuss it, because I think it's kind of important if you want to add this formal definition to the spec. I would want to see it as well.
Right, okay.
And the third thing is, if you define something in a formal way, please don't put Linux API, because then on Windows we have trouble with that, right?
Okay. Thank you.
So maybe I missed it actually in the talk, but I was wondering, what is, from your point of view, the difference between the automata and the CCL?
They are somehow equivalent, because you can go from one word to another. Mm-hmm. What I see interesting in the CCSL approach is that you can be more shorter, so you don't have to design a state machine, for example. So in one CCSL sentence, you can encapsulate a more complex automata, and I was seeing like that, like a nice in that way, but only for the syntax, I will say. But then the problem with that language is quickly become a bit complicated, and people has a lot of trouble to use it. So it's simpler. It's simpler. Almost everyone can design a state machine, let's say, in that sense.
Okay, so I mean, I was just wondering, because you had those clock ticks in the CCL, but that doesn't. Does that imply anything about latency of things or anything like that?
No, okay. Because they are just what you observed that they are was just, I mean, a solution of the specification. So what they simulate, once you specify this, when you simulate, what you actually see is a possible solution. So it doesn't care about the things that happen in the, it means nothing what happened in each tick, because it's not associated with physical time. It's just logical time. So
okay, that's yeah thank you.
Right. So just thinking about it, from the specification point of view, I think first, if you work through it, you'll find that a lot of behavior is not covered by the conformance statements. Like we try to ask contributors when they do description to add conformance statements, but we also don't want to duplicate everything in there, and see things slip through, and also everything that predated VirtIO 1.0. We did go through it and try to write conformance statements, but again, we probably missed a lot. So if you start basing your work on conformance statements, that would be there will be work to write a lot of conformance statements.
Right.
Another thing is that they haven't really been designed with this kind of use in mind. So, for example, the example that you gave, right? So that's a conformance statement. That's a device conformance statement, right? But it says device may use buffers in a specific order, but you want to convert that into into some program that verifies the driver actually, that the driver is ready to handle this kind of device behavior.
I see. Okay.
So I guess that's. Have you given some thought to just like how you convert conformance statements?
I mean, no. I mean, the idea, as I showed in the presentation, is from that statement, converted somehow in something that then you can check, like an observer or whatever. But if you are asking in something that is automatic to do that, I don't know.
Hi, maybe it's a far shot, but there is some academic work on using neural networks to translate natural language to, for example, signal temporal logic. And sometimes it works quite nice, especially if the spec is not too bad. And related work where basically monitors are synthesized out of the translated spec, essentially. Right. So maybe temporal logic in general might be a formalism that could be useful for you. Not sure, but might be worth checking.
Okay, thank you.
Maybe one idea for. Sorry, I can't see. Was it Michael? Is that your name? I can't see your badge. Sorry. One thing for what you said earlier, that potentially those cases where it's about the interaction between the device and the driver could be covered by because in this case, for example, the driver will always see the Virtuo structures and everything at like a specific snapshot in time, because concurrent things, modeling that with formal language is incredibly difficult, and I would say somewhat out of scope anyway. And so if you just take all possible Virtuo state and you just put it into a completely non-deterministic state, so you run your formal proof for all possible queue configurations, all possible descriptor configurations, then you kind of cover every possible point in time in an interaction between the driver and the device. It's computationally very, very expensive, and these sort of proofs take a long time, but theoretically that should cover most of it, I think.
I saw your observer is in the corner, right?
Yeah.
Well, I saw it is more natural to have this observer in VMM or kind of device implementation side, because the device implementation is observing the behavior of the driver. So yeah.
Okay.
So I think it makes more sense to have observer in device.
Okay. Yeah. Could be. Yeah.
Yeah, I think that's exactly, just to answer your question, that's exactly where it becomes murky, because sometimes you say something about the device, but actually what you're saying is that, okay, so the driver has to be able to handle all kinds of things that the device has. So it's not always so clear-cut.
Yeah, it's okay. Okay. No, the monitors in the kernel, I mentioned this because we have already some infrastructure to check that, and this is why I wanted to see that the runtime verification is already in the kernel, and they are already up to observers at least, so we can reuse that, and that's the reason why I put it here. Yeah, but it could be in the device too. That's all.
Okay, this was the last question.
Yeah. Okay. Thank you.
Just at the last minute.
know how to get to this beautiful... It's always good to press escape, first of all. Okay, yes, no. There's case no. Yeah, exactly. And there was somewhere a way how to make it full screen. Okay, where do I need to press for full screen?
No, it's okay.
It's okay?
No problem.
Then that's it. Good.
Shall I go?
You can start now.
Okay. Hello, everybody, and welcome. I'm Alessandro Carminati. I'm working in Red Hat in the automotive section, and today I'm here to show you a tool that I was contributing with in the ELISA project that stemmed its origin in a Red Hat safety project, which is KSNAV. What is KSNAV? KSNAV is basically a tool that is meant to provide and ease somehow the kernel investigation. It is able to produce some type of diagrams to allow a person and someone who wants to investigate into the kernel implementation how things are done. And the KSNAV has also this concept built in of subsystems that seem in the kernel maintainers file. So it provides this view, which are the call tree diagram. It basically allows you to specify a function as a target and see the call tree in a static view fashion, which means that you don't see an actual flow, but you see all the possible path that this call may take. This is particularly interesting for safety-related investigation because we want to analyze all the possible behavior in order to conclude a particular flow is safe or not. Another view that the KSNAV can provide is the possibility to see the subsystem view, which is more or less the same of the call tree view, but instead of showing the single function, it is able to show the relation between the subsystems. Another view that is important here is the interface mapping, which is a view that allows you to specify a function and see the relation, the interface that the subsystem home of this function have with other subsystem. This is useful, for example, when you want to speak with a maintainer and assess within if a particular flow is safe or not. In order of development, there is this global data sharing. There is another view that allows to specify a function and see which global data is using and which other function is using the same data. So, in order to do this, the KSNAV uses a binary investigation. Instead of tackling directly the source code, I prefer to investigate over the binary image of the kernel, because something that I may not have mentioned before, KSNAV is particularly focused on the kernel. The idea itself is extendable to any other binary program, but for example, for the subsystem thing, it is heavily depends on the kernel source tree. So why did I choose binary over the source code? Sometimes someone may be tricked to think that analyze the source code is more easier. In fact, it isn't, because despite being more or less readable from human, the source code has a lot of quirk and difficulties that are not fitting well with binary, with an automated investigation. For example, a macro is something that is not easily it's not easy to analyze in an automated way, because even if we have a specialized parser for the C, the macros doesn't fall into this because they expand. So in turn, in order to analyze the source code, we should have preprocessed all the code before tackling it. Another thing that may be worth noting is that a lot of macros depends of configuration parameters, which is something that are not considered. And also, you may have that the kernel code itself is not written in a single language, because there are some specific place in the kernel where the source code is written directly in assembly. This is the case, for example, of interrupt management and the early boot things. So the advantages of using binary is that in the end you have all the code already resolved. What you see is what you get, more or less the same as an editor. You see exactly what you want to analyze. You don't have to pre-process the thing before working on it, and that's it. So, which benefits brings this KSNAV to user? It simplifies the understanding of the complex kernel interaction by providing these diagrams. It is more easy for humans, typically, to understand some situation with respect, for example, at the source code. And can also enhance the debugging by clarifying the dependencies. Other things that may be useful is that, for example, a maintainer could use KSNAV to see not obvious dependencies. For example, if it happened that a particular global variable is changed by the code, it is not evident by, for example, get maintainer to understand that that variable may involve another maintainer in the analysis. This is something that may be worth considering. So, how KSNAV works? KSNAV, at first, KSNAV is not a single tool, but a tool set. It is composed, in fact, by 3 parts, which are the kernel BinDB, which is basically the parser of the kernel image. Its duty is to analyze the image using reverse engineering tool like Radare, which is a reverse engineering tool that allows to dig into binary, and it fetches cross-references, symbol name, and fill up a database. This database then gets used by the nav utility that provides the actual diagram. The third, in turn, is still experimental. It is a web interface that wraps the nav tool and present this diagram on a web interface. For the moment, it's very limited, but the final objective is to have a tool that allows you to browse the kernel source code together with the diagrams. So when they need, you can trigger a diagram drawing and see the part of the code that may be of interest. Yes, thank you. One of the dependencies that KSNav has is the graph width, which is used for the diagram drawing. And at this point, I will have, I don't prepare the video. Okay, I had a video here, but I have not the video. So, yes, but I didn't prepare the video yet, so. Yeah, I fixed the path. I fixed the path. I fixed the path. I fixed the path. I fixed it. This one here.
In this session, we'll use KSNav.
Yes, you could have, if you had logged in, you could have cut and pasted into the shared notes and then cut and pasted into the laptop.
Yes. Oh, I've written.
It's in the, you want to edit in there, yeah.
Yeah.
Yep, no, is it, no, that's where you want to edit?
Yeah.
Oh, but.
Yeah, actually, why don't we just finish with the
Yep, just finish the presentation.
Okay. Was the last slide?
Is the last slide? Well, you know what, can you do talking? I'll type it in. If you,
Okay.
you want to talk, I'll type it in. I'll type, you go and just talk. Here, talk. Just talk and I'll type it in.
Thank you. So, since this was the last slide, I will gladly accept a question, if any. Yes, please.
Function pointers?
Yes?
Function pointers.
Function pointers, yes. This is a great question. So KSNav in this moment for the function pointer stops to a virtual subsystem that is called dynamic call. Still, I have some plans for the KSNav to solve this by using types. So, whereas for the most of the investigation, I need the binary. For function pointer, I may want to use the source code because using this because the kernel is a self-contained code. I'm sure that there can be not any function, but it needs to stay into the code. So knowing the type of the call, of the indirect call that needs to be made, I can fetch all the possible candidate for that call. I cannot say in a particular situation which one would be because I am in a static analysis, but I'm pretty sure that I can provide a list of possible candidates for that.
Actually, I was going to link this up. Have you considered taking ftrace data and linking up with the static analysis?
Repeat, I couldn't hear you.
Have you considered using ftrace data and linking it with the static analysis data that you're collecting?
ftrace.
The function trace data.
Yeah. ftrace.
It shows you which flow because pointers are allocated on the fly.
In that case, I would make an dynamic analysis. The ftrace is something dynamic. And by the way, the ftrace, if I cannot be sure to have considered all the to have tested all the possibility, I cannot be sure to have I am watching all the possible things for that.
Yeah, so basically by using ftrace, it will be like reverse engineering based on a specific context of use. So.
Yeah, maybe it's a next level tool that could probably marry this together. Yeah. Yep. Because most of the safety use cases do not tend to be dynamic. What we are trying to do is to get a visualization of how the system looks like, right? And then for each of those flow, what our coverage looks like at the next level. So any one single technique doesn't give you a full picture.
Yes, I agree.
That's why you have to do this beforehand.
No video. Oh no, now we have the video.
Nope, that's not it.
This is for another. Okay, but anyway.
Yes.
Time's up.
Okay, so the next one's Wental, who's online.
Yes.
Okay, Wental's online. So Wental, you want to ask him to...
I copied the number from the bottom.
Yeah.
Yeah. Why don't we just give him permission to let him share directly? I'll give it to him right now, okay? I got it. Okay, Wental, you're now presenter. Do you want to share your screen?
Share screen or share presentation?
I just use the uploaded version of slides.
Yep, there we go. That works.
Okay. Shall we just begin?
Yep, go for it.
Okay. So, hello everyone. My name is Wen Tao. I am a PhD student at the University of Illinois. Today, I'd mostly like to discuss a new development tool, LVM-COV, for measuring precise and source-based Sorry, there's some echoing on my side. For measuring precise and source-based code coverage of Linux kernel. So the agenda is as follows. Basically, I will quickly set up the background in terms of the existing coverage tools in kernel, and I will demonstrate how this new LVM-COV tool can possibly benefit us by its source-based feature. Here, I'd actually like to apologize in that we have originally mistaken the format of this mini conference. So we prepared a full NANS presentation. I have also put up the link here, so hopefully we can have some offline extended discussions. My team has 10 in this room who can maybe raise his hand. And yeah, and a special thanks to Kate for helping us do the final moment revision. Okay, so right now in Linux kernel, there are at least two coverage tools, namely KCOV and GCOV. KCOV is commonly used together with syscaller, and GCOV, on the other hand, is designed for coverage in general. But the problem here is both these two tools are performing their instrumentation at some late stages of the entire compilation pipeline, so they can only approximately correlate the execution traces back to source code. So their results are especially susceptible to optimization. And before we dive into concrete numbers and concrete examples, let's first set up some expectation. What should an intuitive coverage report look like? It must be straightforward. In terms of line coverage, let's suppose this first line of assignment here is executed N1 times. We would naturally expect this very next line is executed for the same number of times, right? And since we have an if statement here, it's allowed to have part of the execution traces going into this then clause and all the rest going into this else clause. But the point here is these three numbers under this curly brace must add up. Thus this N2 and N1 minus N2. And in a similar sense for this second if statement, these three numbers should also add up. And in terms of branch coverage, we would expect two outcomes for either if statement, and this execution counters should once again be straightforward. So this conceptual coverage report is exactly our goal, which exhibits precise source correlation. And since we have been talking about source code all the time, the results should not be affected by optimization in any way. But let's look at how GCOV would report for this exact same code snippet using the setup on the screen. Notably, we are using the default optimization level of kernel build system. And for this specific file, I think it's -02. And briefly explaining some GCOV notation, this minus sign means this line contains no code. For example, it's just an empty line or some declaration. And this hashtag basically means zero counters. And from GCOV's reports, we can actually notice many counterintuitive parts, like in this first red box, in terms of line coverage, we can see some executed lines are showing up after unexecuted lines. And even if we consider this return statement in the middle, it still does not make sense, right? And second, as for branch coverage, for this if statement that only has a simple predicate, a simple equals predicate, it is reported to have 10 branch outcomes instead of just 2. So there are actually many such examples in kernel's GCOV reports, which is not ideal because it does not really helps us in terms of improving the tests or improving the kernel code itself. That's why we would like to present this new coverage tool, LLVM and its source-based code coverage feature. What's special about this tool is that it maintains dedicated mapping from the counters back to source code locations. And since these mappings are constructed at the front end and remains immutable henceafter, the results are not affected by optimization. And let's see what this LLVM would report for the same code snippet. So basically, all the counterintuitive parts are now disappearing in this report, and this report is consistent with our conceptual expectation. So basically, all these lines are executed for the same number of times, and for these branches, we have 2 outcomes with no surprise. And here's another example. Remember that in the previous one, GCOV is reporting some actual branch outcomes, but here it's somehow missing some of them. And once again, LLVM is sticking to our conceptual expectation and correctly reported 4 branches. Sorry, 4 branches and 8 outcomes. And the third example, the final example, is in terms of MCDC that is enforced by many safety critical industries. And like again, in this example, GCOV is reporting for simple expression like this that only has 2 conditions. GCOV is reporting it has 6 outcomes and 3 conditions, which is not straightforward. And like I've presented yesterday, this LLVM patch comes with another benefit that allows us to measure MCDC of Linux kernel. So
So that's actually the brief introduction. Our original plan is to dig into the gory details of how we implement this source-based code coverage patch, including some of the known limitations and design choices. But I guess for better discussion results, let us also explore some open questions. For example, what do you expect? What do you developers in the room would expect? What kind of information do you want from our coverage report? And what other development tools you wish to have regarding kernel test coverage? For example, I know that Chuck Wilbur has been proposing some ALVM intrinsics modification so that we can precisely control the measurement of span and get some even more fine-grained coverage report. So yeah, that's basically the kind of feedbacks we'd like to hear from you. Thank you.
This is more just, I guess, kind of a implementation question if you're aware, but you mentioned that the LLVM Cov has benefits in the face of optimizations and that it is able to maintain that source mapping, but does it also prevent optimizations from changing branches, removing branches, collapsing branches, and doing those sort of transformations, in that you would get a different report with the coverage turned on versus it not being turned on, like in actuality versus with the sanitizer enabled, I guess?
Yeah, definitely. I think, sorry, okay, so I'm accurate. Yeah, I think the instrumented code would prevent some of the optimization passes. So I guess the instrumented version would exhibit some different branching as the original one. But that's kind of a trade-off between being able to precisely mapping back to source code or retaining unaffected by the optimization. Does this answer your question?
So then that would not alleviate you of then later having to do functional tests. So LLVM Cov says, yes, we are in fact traversing the code. Gcov gives, in that respect, a more realistic view of what the optimized traversal will look like, but we don't really care because said, as long as the compiler is doing its job correctly, then we show that it's following the code, then we do the functional tests, and everybody's happy. So, yeah.
Yeah, I have actually scrolled to some of my backup slides, and this is a quote from the documentation of LLVM. So I guess those, like one of the point is that the instrumented code would prevent the optimizers to really optimize the instrumented part out. So yeah, I guess there is some kind of impact to the to the differences between the instrumented version and the original version. Sorry, I'm not hearing you. I see someone speaking, but I get no audio here.
Can you hear me now?
The question was if it's already in the kernel CI or it's planned to bring it to kernel CI as coverage tool.
Yes. Did you can you hear us, Wentao?
Now it's good. Now it's good. Can you please repeat the question?
Okay, so I'm going to repeat it. So my question was, is LLVM Cov already integrated, or is there any plan to integrate it with the kernel CI framework?
No, it's currently it's not in the mainline kernel, and that's exactly what our patch does. So right now in CI, I know that For example, in Red Hat CKI, they are running GCOV coverage report for certain of their branches, like the automotive branches. But right now, LVM COV is, because it's not in the mainline kernel in the first place, so it's not integrated yet. But that's definitely something desirable. Yeah.
Right. Thank you.
Yeah, the patch is there, it's been submitted, so review.
What I want to say is, like, the patch is out there. Like, if you want it to be like in kernel CI, please review it, like, and give us some feedback, and hopefully, like, we can merge it soon, so like everyone can enjoy it.
Exactly.
Well, I think we're pretty much at time, so thank you very much, Wental, for coming. Let's take that.
I can find
You can do it?
Yeah.
Good man.
Hi everyone, my name is Luigi. I'm a software quality engineer at Red Hat, and today this short talk will be about the roadmap of an open source tool that we developed as part of the ELISA project. This tool is named Basil, is a software quality management tool, and it is aimed to provide and to create a traceability between work items. So we yesterday had an exhaustive overview of this tool. So who is interested, is curious, you can take the deck from the yesterday talk. This is just an overview of the roadmap, so a way to share with users and anyone interested in the development to which can be some the roadmap and the list of features and ways to improve and create some community around the tool. So essentially we have two goals. One is to try to create and increase the audience of this tool, and there are some backlog activity that we can imagine of, so like creating educational videos, blog posts, and also something that really is useful from my point of view is to create some demo with a project that want to have to create traceability to manage work items. In the last months we had some demo with Zephyr, with Xen, with LTP. So if you are interested on set up a demo, I'll be happy to set up a meeting to help you on your safety critical application to put in place an instance of this tool and help you to create the traceability that you need to show to your assessor not the evidence that you need. So after that, we will see how we plan for the next 6 months to work on those things. The other point is feature development. So today we arrived to Plumbers with some new features to extend the traceability capability of this tool, adding a new kind of work item that generalizes the way this tool can approach traceability. So that was really a great goal because it increased really its capability. And the goal is also to interact with SPDX. So we are trying to stay connected with SPDX, supporting all the relationships that SPDX provides. So for the next month, we today are here. So the yesterday talk was about a demo of mapping LTP test cases against syscalls. So I provided an automated analysis of that mapping against man pages. So the main things for the next month is to go through the automated analysis, review some feedback that we collected during Plumbers, and yeah, I also plan to start educational video, because we have already discussed a lot of things. We have a lot of demos, and probably it's the best way to interact with the community. So after that, we will plan to have other demos with open source projects, and I also plan to increase to improve the documentation, because this tool provides several capabilities that probably not everyone is using. So like the HTTP API is something that we can clarify and provide more details around it. In December, we will have another workshop with Elisa, with high probability in the US, right? Yeah. So we'll try to arrive at important event with something new, and yeah, it's time now to collect your feedback, and now we can demo everything in that relevant form. Okay. So another thing, I'm planning to support other browsers, because this tool at the moment is mostly used on Chrome. And yeah, another idea is to extend the possibility to use as a reference document, multiple reference document. And yeah, January now, usually it's time to reflect. So it's possible to, yeah, I think to spend time writing blog posts and demo to community. And last thing is that probably in February we will have FOSDEM. It's another forum that we can think of. And as a tool development, I plan to work on the SPDX import feature that at the moment is missing. So, and that will provide us some integration with other tools. So essentially, we are trying to define some standardization around tools, and on doing that at ELISA we have a working group that is the tool investigation working group that is trying to define those rules. And so if you want to see some features or to talk about Basil in general, you can reach out on the mailing list of this working group, or you can show up in our weekly meeting, bi-weekly meeting, sorry. So, and that's it, the plan for the next 6 months. So if you have any question, or do you want to discuss about any feature of the tool, I'll be here.
Well, I'm going to start off. Given you'll be doing some of the work in February for that, are you willing to start prototyping with SPDX 3.1 group on safety and see if we can do some experimentation with the tool, with some of the stuff that isn't quite landed yet?
This tool already provides some feature around SPDX, so you can export your traceability in SPDX, but what is not able to do is to import things from other tools. Yeah. So that is the missing piece, and to really interact, we need to define some rules, because we have some, let's say, additional fields around work items that at the moment we really don't know what is the right place.
Yeah, no, that's it exactly, in the sense that there's work going on right now to create new fields in the SPDX 3.1 safety profile. Yeah. And so if you see gaps right now, letting that group know of things that you can't represent easily, and then quite frankly, prototyping in your tool some of the stuff before we formalize it finally would be really helpful.
Sure.
Okay. Anyone else have questions? Oops, where? Oh, there.
Yeah. So, well, this is something that probably it's not in the roadmap, because maybe it's something that we just discussed yesterday. But an important thing will be an important step would be, to integrate Basil, within the kernel CI framework.
Yeah, that's the part of the feedback we collected from the community those days. So there is an idea to let this tool able to refer to external test result, because this tool also provides a way to execute tests. But in general, so that is the work of other tools. So let's do that now to the kernel CI team. And yeah, we need to continue the discussion with the kernel CI, because we need to find a way to, let's say, standardize this interface on our side, because there are also requests to interact with GitLab CI. Other companies asked those days to interact with other pipelines. So now, as the requests start to be more than one, we need to create, let's say, an interface for that.
Yeah.
Anyone else? Okay, well then we will say thank you very much, Luigi, and everyone will be going on the break.
Thank you also for the remote attendees.
All that evidence, we're busy talking about on Friday, right? And all those decisions. Now, what I'm trying to figure out is how we deal with the rules. What?
Yes, okay. This is where to take the pointer. Sorry.
I think we need to really take a what?
Is this able to take the pointer back?
Yes, you can take the pointer back now. Thank you.
No problem. I was hoping I would have seen one of that.
I wanted to leave like 30 minutes ago, but you just were waiting for the pointer. Just kidding.
Anyway.
At the end, the last half hour, we were trying to put the maintainer question back up for discussion in the wider room.
Okay.
We're very sensitive to that point.
Yeah,
Really
I know,
hard
I can
and
imagine.
locked.
My challenge, though, is
Okay, so
how many times does the maintainers have to ask the same question over and over and over again? This will minimize that.
Some project managers don't get that, but you know what I mean? And then it's very similar to Strictdoc, but yeah, it's 10 years or so.
Tell us to write more documentation.
Like, are you saying we
Yes, that they get, because then we have,
I
you
know the
know, we have
time
all
that
our
the
free safety open source projects, SAN, Zephyr, and LPC are using some open source requirements management tooling that can import or at least export SPX safety profile files. And then we can start playing around with that.
Doesn't have to be perfect.
No, it's just something to play around with.
Yes. I do agree, because we're spiraling out generic. And we don't want the engineers to write laws.
Yeah.
Show them all, and then let's.
Okay.
So I can show you the slides.
Well, good.
So we have a lot of
Just
discussion.
need
What do you
Yes,
do?
me too. You can grab some stuff.
If you see that, okay, sure. You have a few minutes?
I've got the break right now.
Okay.
I've got the break.
I need cheese.
Some good tea. If you get me tea, that would be lovely, but green tea. Yeah. If you can, that's fine. I'm going to go with the Colonel CI.
I'll check for green tea.
What?
I check for green tea.
Check for it. If not, don't worry about it. I've got water still. Yes, it is a social problem, completely. Socialist, I'm looking on the outside. Okay, that's fine. Hey, good to see you again. Thank you for coming. Thank you for coming.
I watched the last session.
You watched the last session as we finished talking this stuff too? Thank you. Yeah. Right. Mhm. So we don't. There it is. Where do you see the return? technical debt builds up because these are all designs in people's heads, and people get tired of being asked about their designs over and over and over again. Yeah. So the social engineering problem. I agree. I'm trying to figure out what is the angle. I know. Solution now. So the question here is, how do we, I'm the conflict, because John needs to get the documentation better. And the assertion from the clients are flying into that space. So the question though is, how do you track it upstream so you can get credit and you report it in stats? Is that what you're saying? Is that right? I know you seem to, sorry, because you get my.
So we have to find the right incentive.
Correct. I completely agree.
Make it a requirement. And definition of that requirement has to be tied to something that the maintainer is doing on a daily basis. People will know that this is
Yes. That's what I want to see.
So you can show him that it is red, green, yellow,
Yeah.
color,
Stats.
something like that. Right now, that I'm sorry, the pieces are open. Okay, nobody's able to discuss that.
So the SPDX is a way for us to start to stitch it up if we're going to look to start looking at these, and that's what we're proving that it does. I know it's data structures, I know, but like I said, McDocs is kind of where we're prototyping it before, we're actually changing things around, etc. There's the question here is how do you get across the eye stuff up
If you
and
can
test
get
it?
limits,
I'm glad I started
if you can
making
get him
noises.
say that he's just lacking in terms of requirements, the rest of us are ships in water.
I know, like, I basically called him last night, he said, well, you've got through the email, I write this email now, and so I know exactly what that means, but anyhow, on the other hand, Thomas is, I basically trying to lie through to you.
I missed to have put the background.
Oh,
I am when I was here.
yes.
Curious
What?
about that conversation.
Oh.
Was it about?
What that's just like me in town for putting
No,
this
not that
in
one.
and the one here?
Yeah.
Oh. Basically, it's a social engineering of finding out what is going to motivate the maintainers to care. And it's, aspects of the requirements, probably. We're going to start to think about in terms of what's going to motivate the clouds. And maybe we get some key developers to start here.
Okay.
And, Steve Tyler gets it. Thank you. I'll let you guys keep all of this one. I think that there's really trying stuff, so basically really trying stuff we're seeing in there. I think Thomas told me last week. So I think Thomas is going after sustainability as an issue.
So we're design for sustainability.
Right now, because we're making a point. Basically saying, this is, I designed in my head, they don't write it down. And they don't think they need to write it down. But the reality is, this is why we get that.
You forget. You forget.
We forget. Exactly. So, these are the social engineering coming up here, and that's why the MVP is started the social engineering. UPG 6.0. I actually tried last night, I started, I believe it's a little bit like these getting to the stage. And go ask, the track plans. And at some point in time I will.
It wasn't a no, though.
No. No, he's basically, so Thomas is a natural ally here for me, in the sense that he's trying to make a case that we need to have a fund, simply for senior people who want to part-time retirement or whatever, to go in and start using the technical debt that we've created. And obviously created, and I'm saying, well, Tom's definition, requirements, and proper specification needs to be part of this, and it's not in the talking about it very much.
Okay.
So, and the social engineering, John Carter's view is, including stuff, subsystem, and friendly subsystem.
Kannst du doch mal anfangen?
We get to the stage where we're working on subsystem.
Yeah, step one is come up with a spec, right? Agree on a spec.
Like, yeah, well, like I said, we've done a lot of work already.
Hast du das schon gemacht?
Wenn wir mal das Fliegen nur in der Pause aufgeben. Die würde kann man gar nichts mehr machen. Original auf Breakboard.
Do we have enough agreement on meta information framework and all that? I didn't think we did.
He was saying basically, he's trying to lead off with some language to this stuff.
I will laugh at you myself.
Yeah. Like, I think the concept of doing the assertions that this is what I expect to see happening. Style, and having a statement first, just even heading towards years. And something that says shall and should, etc.
Yeah. You can create a shall count from 1 to infinity, and you don't, that doesn't mean you have.
Achso. Kannst du drücken für.
Ja.
We effectively take into account the shell
Also
system.
alle Beacons ausschalten.
Okay. All right. Well, we'll keep plugging away. This is what I want to be doing.
Oh, good. Take some of the students? Okay, great.
Thank you so much.
Sure.
And you should say, because you're working in that space now. For safety reasons, do not remove the sticker.
Thank you so much. You'll be super happy.
I need you. Okay, and I will follow. Okay. Just don't be afraid. I understand what you're saying. I understand what you're saying. I haven't That's what I'm asking for that, if you don't
Sure.
mind. I
I
need
don't mind at
bumpers. I need you to measure me.
Guardrails, huh?
Yes, I need bumpers.
That's fine. I've got no problem with you Wednesday.
Thank you.
Like I say, like I say, you and Ryan, the Friday after your discussions are just as alike right now.
Yeah.
We're really making, we're really having a good time. I'm having a good time.
I'm
Regardless
having a good
Yes,
and
it
a
is.
hard time because it's 6
Good.
p.m.
And you're
I'm tired and you're talking so fast.
Sorry.
No worries. It's the flow that's don't do anything different.
Do you want me to turn on recording on the call so that you
No,
listen
no.
later?
I never used to. I never listen to recording, and
I don't either.
it keeps people off speaking freely.
That's the other part.
That's the issue too, yeah.
I'll watch my words more if it's recorded.
Yeah.
Yeah,
I
same.
want to do that.
So I think what we, yeah.
Because I sound like an idiot. I
Well,
never
just,
even.
just look at the minutes and make sure.
I think we
get it right.
all do when we hear ourselves. So
I never watch my talk recordings. It's embarrassing
Neither
to
do
me
I.
to look at them.
When I have if I have to
That's
check
what
this,
it's made for.
Yeah.
yeah, if I have to.
I just
check-
need you to tell me.
But I'll tell you if you're saying something, just come down.
That's exactly what I need.
Yeah, okay.
Sorry, Nicole. I didn't mean to
Yeah,
interrupt.
just
And I tell her to.
you need to check your recordings or force them. I never do this on my own. I always tell Sven, you're the audio guy in the family. You need to check if the recording is correct.
Yes. I don't want to look at my own video. I don't
Yeah.
like it. I don't like it. I mean, I guess if I wanted to become a better public speaker, I would study my own video, but I don't really want to.
I
You know,
think
the one benefit of COVID for me is it forced me to watch my own videos because
Oh,
that's the way
wow.
we were doing it. And I basically, every time anyone asked me to talk to you, I could count on it maybe 4 times before I was comfortable with the talk. And that practice has stood me in good stead since we
That
started
is
going
true.
back in person.
That is true.
And I am definitely a better presenter now
That
than
is
I
true.
was.
Yep.
5 years
That's
ago.
definitely true. I'm just think I'm happy enough at the moment with the kind of presenter I am. I think
Well, I thought you just said
for a German and for an engineer, I think my presentations are okay. Yeah, but next time, before I give my next talk in Limerick, I will just contact you, Philip, for getting stuff.
Do you mean a German engineer presenter would be like rigid and?
No, it's with respect to language, accent, funny use of words, funny way of creating a sentence, and then boring way of thinking, no humor. Yeah.
That's not what I'm thinking when you're talking, but okay.
I think it's okayish enough.
You're doing great.
Yeah, so that's.
Yeah. You want to get me for what?
Next time, well, I don't know when I will give my first talk about what I'm doing in Limerick, but then I will contact you for getting some stuff to just bribe people.
Oh, she wants slides to hand out.
Yeah. But I don't know, so usually I should have a talk before Christmas, but it seems that the talks are not scheduled before Christmas.
At a chair,
Oh,
so that people can see when they come in.
okay.
So it's a good spot, because I don't want to carry them in my carry-on if I already have so much to carry. That's all.
See, I'm trying to think if I'm going to be seeing a lecture fit next week, so you want to keep some for that. So I'll take one color set and the rest of it to that set. I'll put some of these tabs like these. Okay, I'll see it on it.
Yeah, put it on my laptop too.
We have a student also with her account, but he wants to write safe code.
Oh, that's very good.
So he has an account.
So yeah, we can get a sticker on the
So Nicole, what do we do? Just sort of aggregate what we have now and just say kind of like, blah, this is what we have. What do you
I
guys
think we should do this, so that we have something,
Okay.
and then we iterate over that we have to get what we want.
Do we have enough to do that now? I think we do.
I think we have.
I think we do. Okay.
Because, yeah. And for the stuff where we say we don't have anything, we make a TBD.
Yeah.
It's just, you know, that's
Point out
how
the
drafts work out.
Okay. So there's no meeting next Friday.
I don't think so.
And the Friday after, are we meeting?
I think so, not we're meeting.
Since Friday after the 3rd of the
4th, yeah.
October.
Yeah. I am just happy enough if I can get my 3rd of October free of stuff. And if the trains are running to Salzburg, because I'm really considering going to Salzburg for shopping on the 3rd of October.
We were just there. It's a great place.
I know. It's 2 hours from Munich. And on 3rd of October, everything is closed in Munich because of the holiday, the bank holiday, the day of German unity. But everything is open in Salzburg. Everybody from Munich will be in Salzburg. The whole plan, so it's more or less just transferring people from one town to the other. And it's just much fun to be there on the 3rd of October because everybody is expecting us. And
have you done the salt mine tour?
Yes.
In Salzburg? We just did it.
Well,
It's so
not
cool.
in Salzburg. I did it in Berchtesgaden.
No, we didn't do that one.
They have big slides.
Yeah, we did the slide in Salzburg. It's really cool.
So
I was like, is this for real? I said, yeah, go.
Yeah,
It's so much fun. Yeah.
I did it the first time when I was a kid, and I was like going down, running the stairs back up. There's the stairs for those who are not comfortable to go taking slides, but you can also run up the stairs again and do it again.
That was a lot of fun.
Yeah.
The one in Salzburg actually has 2 sets of slides. One shorter than the other. The second one's really long. That was a lot of fun.
I wanted to ask Seth for this Yocktö project, or Yocktö project.
That one?
Yes, I wanted to ask him, but I did not get one.
Yeah.
But I will ask him again, maybe I can meet him next week and get one if he still has some.
You should. These are my favorite stickers so far.
Yeah.
It's like an AC/DC.
Yeah, or like Motorhead.
Oh yeah, Motorhead. Thank you.
Yeah.
Yes, I don't listen to Motorhead, but yes,
Yeah.
I agree. Yeah. Yeah, you're right.
And maybe he's coming to our Safa meetup next week. He has been at the last one, so I just have to text him. I did not catch him just on the first day, first morning. I met him and that's Seth. He said we can call him Seth, but only if we're native Bavarian speakers, because every other speaker's Seth sounds terrible. But it's like, it's like if you come from English, it's like Z-E-P, Z. Yes, that's perfect. That's like the Bavarian Z.
Well, imagine having a last name like Wolver and trying to pronounce that to native English speakers. They don't hear Vulver. So I feel that.
Ich habe irgendwie nur ein T-Shirt gefunden.
Turn it off, we turn it on. Focus the first.
Upsi aus.
Wait, yeah, yes. Fourth.
Alright, I think Kate said we're not meeting. I'll have to ask Kate when we're meeting next. I thought it was the next 2 weeks. We were not.
I think we were not meeting last week.
Yep.
And
Definitely not this week, and I thought the week after too, right?
Oh yeah, Kate is traveling the week after.
Yeah, the 27th.
This week, yeah.
Yeah, okay. But after that, we are meeting.
I hope so. It's October the 4th.
Yes,
But
you were right.
I won't take a day off on October 4th.
Oh, wait, you're shopping on the 3rd, right?
Exactly.
You're all set. You're all set. All right, I'll delete it out of my calendar for the 27th.
You turn it on. It's on.
I think I take my water bottle to the stage.
medium.
How long does it take you to get home from here?
My flight goes at 8.
Oh, you're flying? I thought you lived in Berlin.
What's the right decision I guess to take? Flight.
Oh, because of this floods.
I said much earlier because normally it's a Berlin or like Hanover area.
Train from Hildesheim would take forever anyway.
Oh, would it?
8 or 9 hours.
Oh, that's too long. That's just
It was 2 or 3 changes, so it will take longer because you will definitely miss a connection somewhere. And then I thought, well, it's more Sunday, sort of quality time. So probably check the possibilities to bring it with it. Sweet, yeah. And I guess it's more the most perfect time.
Oh, yeah.
Yeah.
Oh, yeah.
1 hour for kids,
Yeah.
and they have an early lunch.
Yep.
So you can know successfully if you're Zoom video pre-time. And then once you have 6:30 now, it's like is it 8. So you probably just had this too. Should see some ways it is
And the closer they get to it, it freaks out. So I think my flight leaves Paris at 4:30 and gets into Seattle at like 6:30. So with the time change, it's like 2 hours difference.
Yeah, but how long will you be in the air? 12 hours?
10 hours. Long time.
Yeah.
Watch the movies.
So you can turn it on. Everything hurts just thinking
Oh yeah.
about this.
I get a business class seat though.
Okay, that's why. Yeah, so that frees you. Now that I have my own stuff, I don't want to pay for business flights. But I don't want to go economy, so I will fly.
That's why we didn't
on
see
long distance.
Premium economy is
But for me, it's not a
Probably has to be so
difference.
talk.
Oh.
I have a meeting, like, and I have to go.
Well, take care of business, I understand.
So, yeah,
It's
yeah.
great to bump into you.
Yeah. Thank you so much.
We also have a student with a smaller size of person. I have this small size t-shirt.
Yeah, small t-shirt, okay.
It's up to you.
Yeah, I will take it.
Okay.
Yeah, thank you so much.
So we'll see where the patches go.
Yeah.
As we're waiting for feedback. I know they saw it. Keys Cook was sitting, the Chancellor was sitting right there listening.
I see.
They were all there.
I see.
Yep, they were all there.
Good.
Let's just wait.
Good.
If we don't hear from them in a couple of weeks, maybe we'll send a ping, but right now let's just let it sit.
Sure.
And then after that, we'll worry about maintainers and follow-on features. But for now, Wentel keeps doing his own work.
Sounds good.
We'll keep an eye on it. He does not, you can tell Wentel, he does not need to rebase the patches unless they don't apply cleanly to Linus's head.
Sounds good.
Head commit. Okay. If they apply cleanly, he does not need to modify the patches. Okay.
Thanks again, like, for all the support, seriously.
Oh, I'm enjoying it.
Yeah.
I'm really enjoying it.
Yeah.
I'm having a good time.
See you. Yeah.
Thank you. Let me know. You know where to find me.
Sounds good. Yeah.
Yes. Yeah.
Thank you for all the slides.
And tell everybody I said hi too.
Yeah.
Darko and everybody else.
Yeah, Steve now.
What's that?
Yeah, I'll Steve now.
Still on Chicago time?
Yeah, Chicago
time.
nice,
Yeah. That's one way to do it. Stay on Chicago time. Yeah. Yeah. I heard rumors that next year is going to be in Tokyo.
The European one, or the plumbers.
In December. Plumbers. They're moving it. Interesting.
Eight and nine, so some in Japan. I saw a sheet of paper which was meant for those which are having booths. So they were giving it to the ones who were to the sponsors, who sponsors thing, but they know already the event schedule for the whole next year, the tentative schedule.
Where's North America going to be?
I don't know, just saw that. It will be in September. That's what I heard.
What will be?
The Open Source Summit North America will be
No.
in September.
I read on the events page that it will be in June. Open Source Summit US.
Yeah, they try to keep them separate enough that you can technically learn about it.
I just heard rumors, as I did not attend any keynote, that the next Open Source Summit Europe should be in Amsterdam in August, which means that I'm not very motivated to attend.
August is a good time for Amsterdam, or no, just for vacation season? Or
Amsterdam is fucking expensive through the whole year. End of August is not, it's vacation season, so it will be more expensive. If I would need to go to Amsterdam, I would most probably get a hotel half an hour by train away, near to the sea, which makes it not cheaper but more expensive in August. So,
I thought LPC moved from US to Europe every other year.
yeah,
but I said the OSS, not the LPC.
the LPC also.
Last year was in the US, in Virginia. So that's why I was surprised when the hint was dropped that it might be in Tokyo, LPC Tokyo next year. I don't know, maybe I misheard. We shall find it.
We haven't misheard. What I saw was.
So they're not going to go back to the US? Interesting. Well, let me use the facility before we start back up.
You have 4 minutes.
No, I'll make it fast. Yeah, I have to go down that. Oh, wait. Oh, wait. Coffee breath. I guess we should also target one of these conferences to roll out the safety profile model itself, too.
Yeah.
Yeah.
Which conference?
Well, since we want to get into the kernel, maybe plumbers we should be targeting.
I don't want to go to Tokyo.
Oh.
I love Tokyo, but we're talking logos and flags again. And as you cannot go via Russia, it's about 14 hours from my place, or 15.
Man.
And if you want to go business, it's now at least 7,000 or 8,000 euros. So Tokyo is limits for me. I don't want to go via Dubai because you always have at least 4 hours of labor in Dubai, which also sucks.
Yep. I wonder what it'll be for me in Seattle. My leadership seems to be okay with me paying for me to go to plumbers. So.
Yeah, I need to decide for myself if it's worth spending the money and the days to go somewhere. And that's really a hard decision.
This is really valuable being here. It's super valuable. We make a lot of
It
progress.
is content-wise, yeah. But I also need to think about how many leads do I generate and for next project.
So you are self-employed as a project engineer then?
Yeah. So, yeah, we have a small. I'm employed in my own company. That's the structure. So we have the company. Just let's say full time. It's just me. Then it's Andreas as part time. Then I have Moody, the hardware guy, in part time. Then I have Flo, the training guy, in part time. So when I'm somewhere for a week, nobody's working full time.
Yeah, you're right. Yeah, you're right.
And also produce nice travel costs. So I have to think about this.
I agree. Think about it.
It's fine. It's fine. So we get this.
Kann hier so auswählen. Wo ist deine? Weißt du, wie der hieß?
Ja, LPC 24 und Pablo oder so. Safety. MC.
Du siehst auch nicht.
Nee, ich sehe es auch nicht.
Ich gucke mal.
Ja. Also ich habe sie heute um 8:59 Uhr hochgeladen. I uploaded it at 8:59.
Okay.
Must be there somewhere.
Has to be there. Do you have a video?
No, we're just not finding my presentation.
I mean, there's a PDF on the site.
Yeah, that must be.
Yeah.
What's the problem?
We can't find my presentation.
It's not on the upload. It hasn't been uploaded.
It has been uploaded this morning.
But it's not listed here?
It should be named something also like LPC 24 and then my name Pablo P. double P.
So if that's the case, you know what? Here, I'll do it this way. The easiest way is go here, not here. This is, let's go to back to the title. Where's schedule overview? It's a little slow. Go to Friday. Go down here. Safety and here. Click here. Have the break. It's this one
yeah.
right there. That's what it's called.
Yeah, that's what it's called.
Well, that's the one, but whoops, I gotta download it. Where's the download? Here it is. And it's called, what's it saved as? Safety MCMP, right?
Yeah.
And then we'll go to here. We'll do, this one?
Yeah. Yeah. We just
I just went through. I downloaded it and I'm it's converting the file, and once it's done, it should show up.
Okay.
Well, oh, you have a lot of slides.
Yeah.
Okay. We
I
found
have
out that this has a max limit of 200, but you're okay.
I was 40 something.
Yeah. There you go.
I have fake. It's okay. Thank you. Okay. We'd like to start.
Thank you.
So, yeah. So, okay, so thank you everybody for being here. So let's continue after the break. Try to make it fast and painless. So how does this work? Ah, okay. So yeah, so I'd like to talk today about traceability requirements and why we also should consider this, or we're talking requirements, shall consider this for software. I'm a safety person, so please excuse me if I'm sometimes a little bit strange. So I'd really like to show you what's the issue with having no traceability in software or no requirements, and why we need this. The intentions of why to have documentation and evidences documented, and give you a glimpse into the upcoming SPD safety model that hopefully helps you with that to set up and maintain. So let's talk a little bit of history. Back then, when we started to think about safety, it was based on pure mechanics. We had, for example, these big steam trains. The safety was in the nuts and in the bolts and in the construction, how these worked together, how these were sturdy and big and reliable enough in the steel that was there to be safe. And actually, one of the basics to that was also that everything you had in there was standardized and identifiable. So I have this still from when I started to work. So in here you find every kind of combination of measures to identify a screw. Dimensions, what tool to use, what torque to apply when you fix a screw. So you have serial numbers, you have everything standardized how to identify things. And when you need a screw, you know, the screw itself is not the specification of the screw. The dimensions are described in a specific way. You can verify it easily enough. The dimensions are on the box. The serial number is on the box. When you buy this in the shop, you have these little measuring things where you can make it really sure that you have the screw that you wanted to have. When you're in your box at home, it's also pretty easy to identify. You have these little things. Just, you know, like this, I know exactly which size this is. So it's pretty standardized. It's not something in between. And all this information that we have, it gives us the manufacturing information. Where does it come from? If something breaks, maybe the whole lot or the whole build is affected, you know? So you can trace things back in mechanics pretty easily by standardization, by having serial numbers, by having BOMs, bill of materials. This is nothing new to engineering, of which things you put into your final systems, what were the dimensions you have in your construction documentation, why you decided to have this, and you have a list of everything and where it came from. And I don't want to do finger pointing, but I think this is an accident, at least the Europeans still have in their mind, the big crash in Eschede, where there were around 100 dead, a lot of people injured. It was a real shock to us German engineers that something like our big ice trains can break, and break that fatally. And actually the only way to get over this and to decide what could we have done better was really to analyze what was the material, what were the dimensions, look at the disastrous debris and check what really happened, what were the response reactions, how could we get better. And based on this information, we were able to come up with, improved construction of the wheels, improved maintenance routines, improved response and emergency ways. So this is something that we also should consider for software. So once something happens, really going to the source code might not help us in the end. So this is a question I really like to ask you. When it comes to your life, what would you trust more? A screw where you exactly knew where it came from, exactly know its tensile strength, its material, its dimensions, the tools you need to use to assemble it, or would you trust something that you found on GitHub, and just because it's openly available, you would use? So back to today, we don't have pure mechanics anymore. So everything I said about mechanics, it's still true, but we have electrical systems and we have software. We have loads and loads of software, and we need to trust the software the same way we trust the mechanics these days. So functional safety can really add some value to that. So I won't get into that. Philip already opened that track explaining what is functional safety. And yeah, safety is a system property. Safety is the complete train with its braking systems, but it's also the trust that you have in each screw, in each bolt. And for software, this translates into you need to have trust in each piece of software. You can have the most beautiful software. If one piece is crap, it will give you the incident. So, and from a functional safety point of view, that means you need to have a concept that builds a software that is sturdy enough, but you also need to have the process and the documentation and the evidences to show people that this is really what you have intended to have. So you need to have the intentions, and you need to have the evidence that you have implemented it as intended. Yeah, usually there is a specific way to capture all this. This is documented in several safety standards. In the end, whatever standard you're looking into it always asks you for the same stuff. Unique IDs, traceability, evidences, evidence of completeness, archiving of things. So it's whatever the flavor, that is the stuff that comes out there. And the big challenge on that is not creating this once and then forgetting about it somewhere in your archive. The big challenge is creating this consistently and then keeping it up to date throughout the life cycle. So, as just for overview, you will, for functional safety, you usually create loads and loads of documentation. You have on the one hand side your plans. Based on that, you create a safe system. You do analysis based on your system. You have the planning documents, safety plan, configuration management plan, whatever plan. You have your code. You have your test evidences. You have your assessment evidences. So you have a lot of stuff. Thankfully, this stuff is not an amorphous blob. It's in relation to each other. So everything depends on a lot of other things. And as many people see the V model as a sequence of doom, please don't look at it as a sequence model. Look at it as a knowledge model that you describe what you want to have, the assumptions that you made of what you need, and the way you want to reach this. And these days, all these pieces of knowledge, all this information is captured in different types of documents. You have more or less always some kind of plans, process guidelines, you have requirements, and you have all your test results, tests, analysis results, assessment results, all that. And all that stuff is documented in its own system. You have your life cycle systems, you have your repositories for your code, you have some system that creates you the dashboards for your management. You might have might be very modern and you might have a wiki, but it's all living in its own space. So really keeping this stuff up to date and in relation to each other so that your documentation of what you want to do is really up to date what's in the code, and that your tests are up to date not only with the code, that's usually in development not the big issue, but that they are up to date with what's expected of the code. That's really, at the moment, the hardest thing to keep up to date. And any guesses what's the #1 tool at the moment is to document this, to keep the traceability up between all the words? It's Excel. And usually this documentation comes with a very interesting name, a draft that is final, that has a version number that for sure is not the same version number you find in the document. And when you look into the document and start looking for the evidences, for the work products, for the code that's referenced in there, you will find that it's not up to date because it's a pain keeping this up to date manually. And each company, each project has its own way of doing things, so you can't exchange it and know by just having it where to find something. You can't import, export, you can't use this for really to establish traceability between projects. it's impossible. So why should we look into SPDX for that? And just by reading through, let's say, the first thing that comes up when you look for SPDX, and what SPDX is supposed to do, it already ticks a lot of boxes. You don't even need to think deeper into what to add to SPDX for safety. It already ticks a lot of boxes. It tells you we have a way to describe what's in a release. We have a way to describe where it comes from, about the author, about the licenses, about the copyright, about relationships between or dependencies between projects. It gives you really already a lot of information. So that's where we started to look into having a safety profile for it. And when you just look at the simplified version of the V model and say it's not a sequence, it's a knowledge model, you see you can already use existing SPDX relationships to describe the dependencies within your project. And now with, if you look into the models for SPDX 3.0, you will find there's a lot of stuff there that we already need. You can find the models on GitHub under the little QR codes, so don't worry that you can't read it. And if you look, for example, what we are now planning to do in the Zephyr project, we have a structure. This is just looking at the requirements management and the relation of planning to requirements to code. We can set up a model based on these relationships, so we can, the traceability that we have in the tooling translates into these SPDX relationships. And if you look a little bit deeper into that, you can really see you have a safety plan that describes what should be done for requirements management, what should be done for verification. It translates also to what should be in the coding guidelines. So safety plan will say, hey, we need some coding guideline. We need to agree on how to code. And the coding guideline influences how the code is written. The requirements influence what is written in the code. So everything has an ancestor or a child relationship. And this really works through the complete life cycle of a system or of a project. So including at the end also the evidences that really show this is the evidence that it complies with requirements, that it complies with coding guidelines for this release of the code. And the beauty of that really is once you find an issue, you don't need to start guesswork. You don't need to start calling people, having a shout out on 3 different mailing lists to get the right people into the room that might know where to look into the real source of this issue. You really have a way to follow these relationships back to its possible source. So from the build, back to the source code, back to coding guidelines and requirements, and really identify what was the issue. Do I have a wrong requirement? Do I have coding guidelines that destroy my functionality? Do I have a simple coding error? Usually it's not the code, it's usually the requirement that's wrong. So, yeah. And it's really, when you think about, I want these pieces of information that come into my project just to decide, is this really what I want? Is this project, this piece of code performing as I want to have it? You can really look into the SBOMs that can be then created by the project. It's not something that somebody in the inbound process department needs to do and then just assume by reading code that they might not understand what something does. You get information about what's in there, how is it structured, what was the intention of it. Thank you. And you can really reuse all these pieces of information to document what finally gets deployed in your system. So that's the big goal, coming from Excel to a standardized lifecycle model with SPDX. This is just the summary I've already told you about. You can standardize your impact analysis. You have a standardized exchange format between the projects for the safety cases. You have reproducible results. It's not depending on who you just get on the phone. And it's a formal way to demonstrate completeness, so you don't need to start gathering all your evidences manually across different tools. So just for remembering, it can really cover the whole V model. And if you would like to know more about it or contribute, we meet each Friday evening, so Friday evening in European time. And yeah, that's it. Thank you. And are there any questions? Yeah. Where's the box?
Thank you. I'm wondering, from a practical perspective, you had code at the center of those slides. What are you tracking exactly? What's the granularity? Are you tracking releases, individual patches, or how do you use it?
Really source code. So source code with relation to say this is a function. How what this function should do is described in this requirement or in this interface specification.
But if it changes over time or from release to next,
yeah, if it changes over time, you will adapt your documentation anyway. So even now, without thinking about high-level requirements, you will update your interface specification. You will update the docs so that everybody that uses it knows that maybe I have a new parameter in this interface, or that I have a new type in this interface, or that this interface has now a new functionality somewhere in the back. You will document this anyway. And I don't expect, at least not for the near future, that a developer or maintainer will care about high-level requirements. This, on the short term, will be a task for a different group, really going over changes in a regular basis and say, hey, what does this mean on a high level for us? But the intention of the model is really to track everything down from, let's say, a function level to an interface specification or design, to the docs, and then to a higher level document that is then more or less the interface of this.
Okay, thanks.
Okay, yeah, all of this sounds really amazing, and I think it's definitely something that as new systems are developed, like you can really take this approach from the ground up. I guess I want to get your thoughts on what existing systems can do, if there's ways to iteratively take portions of this and replace like that Excel spreadsheet, that type of thing, and if you have any recommendations or guidance on that for people that have existing systems they want to adopt this with.
Yeah, so my recommendation is always don't eat the full burger in one bite. Look into what is the section that's most important to you for applying this. It could be the most stable, so you don't need to iterate too often using a new system, or it might be the most changing one because you really want to keep track in this way. So I would really say, okay, identify a part of your system, your project, where you want to roll this out. Play around with it. At the moment, give us feedback, please. And yeah, just go with it. But yeah, piece by piece. Also, we don't roll this out over each project. From the Zephyr point of view, we roll this now slowly out using our requirements management tool. Luigi is implementing it in Bazel so that also what's documented in Bazel can generate this. So it's really piece by piece, and it's not a big bunch at all.
Yeah. Okay, thank you.
I'm just, I think we're, one more question, I guess, and I'm just, in terms of the safety profile and the evidence, what do you see as the benefits by having this stuff automated from the point of view of working with the ecosystem?
So the benefit is it's much less pain, because having it automated means you don't need to think about it. It's something that just, it does not just happen, but it's not like you need to manually edit something. You just type it down, your tooling will take care of it, and it's making things much more reproducible, much more sustainable, much more maintainable.
Do you think the assessors will assess?
Yeah.
Go.
So I don't have any official information, but I have many friends still working as assessors, and if I pitch this to them, they like it. They just want to see how it works out and who will adapt it. And then say, oh, but the SPTX tooling then also needs to go through a quality evaluation. But yeah, we need to trust our tooling, right? That's just what it is.
Okay. Any last questions? Okay. Well, thanks, Nicole.
Thank you. Just taking my props. Oh, that's your time.
Good?
Yeah.
We can go.
Okay, excellent. All right, my name is Chuck Wilbur. I'm an Associate Technical Fellow at the Boeing Company. Obviously, my words are my own right now. I don't speak for Boeing in this presentation. I introduced the concept of the cinder block problem at the last Open Source Summit in North America. It's really just kind of a way of describing security problems in safety design systems. So we just call them cinder block problems because it does start an arms race. So what I wanted to do is just elaborate and go deeper into it and talk about how we're going to deal with that, especially with the upcoming SPTX safety profile, how we're going to work for that. But first, let's see. I want to give a shout out to my son, who did not follow me into software, but today he is in Austin, Texas. This is his graduating group. He is going into safety. He'll be a first responder in Austin, Travis County area. And I'm really proud of him, so I just wanted to use some of my precious time to say, good job, buddy. I hope none of you have to meet him the wrong way, but he's a great guy if you ever get to ever do meet him. So there you go. Okay, so first of all, thank you very much to Kate and Steve. By the way, I'm here actually because you asked me to a while back. So I give you a lot of credit here. So thanks to sponsors and everybody. It really is a privilege to be here. So one of the things, so raise your hand if you've ever been responsible for a product that someone can buy, big or small, that is safety critical in some way. Medical, automotive, aerospace, nuclear, railroad, right? Okay, so.
Does that count like infrastructure? I mean, not a product. You said a product.
Yeah, but I know you work for Lockheed, so I have a feeling I probably know some of the stuff you probably worked on. So yes, that does count for that as well. Yeah, you have a responsibility to the public in that case. And so what I kind of in a Harvey Milk, I want to recruit you style thing, I want you guys to think about, maybe take 2 seconds here if we can describe this. Safety is really just evidence of design and evidence of testability. You can think of design as just one big giant invariant. We can't, Alan Turing proved a long time ago that you can't prove, there's no general provability. So a design really is a form of invariant that you can test. And so that has to be able to benefit the rest of the open source community. We all agree, just like we say at Boeing and every other company, no new feature gets to go on because it's good looking and it speaks well. It has to sell itself onto the airplane. So we have to sell ourselves into the open source community. You have to earn your way in. I think selling design is a really good idea. It causes everybody to think carefully about what they're doing. We can never test all of our software fully. That's impossible. Okay, but does anybody have any thoughts they want to spout off on about briefly about why everybody else other than safety should care? Are we just the weirdos over here in our own little mini conference hardly anybody knows about, right? Does anyone want to make any comments on that? Why should they care? Why should the rest of the open source community care?
I thought the question was, why don't they care?
Okay, fine. Answer that one better. Yeah.
No, it's like the whole thing, safety, security, and stuff like that. Everyone's got their own focus on what they want to do, and of course they don't really care. Like it's like, well, it's not my problem. Yep. That's the whole thing until it becomes their problem.
Yep. And it did. And we look at, going back to the 60s and 70s, all the way into the 80s and 90s, we see how code became better, and we did a much better job because of security. It caused us to get our act together and do a better job. And so we have good interfaces, good encapsulation, we have rules of the road. I mean, it's really helped everybody. So kind of my answer to that is it's a diverse form of scrutiny, right? Many eyes argument. And really that should carry the day. Safety drives thoughtful design. If we sit here and reason through our design, sometimes we call it rubber duck debugging, where you tell the duck, right? You get thoughtful design. Someone is convinced they know what's going on, but you present the design to them, they're like, I didn't think of that. And you do that. That's why we have these conferences. I've seen people who, to me, I look up to, they're gods to me, and they're in the room arguing back and forth. I'm like, they don't even know. Because they're scrutinizing these things down to the nano level, and that's what happens when you drive design. Of course, testing. Once you have design, that is an invariant that now you can test it. It's a shall statement, right? So old versus new. When I first got into the game, early 2000s, I was given the privilege to come up with a Linux OS on we call them line replaceable units, LRUs, in a Caribbean ECU. LRU, I was given the privilege to come up with a Linux platform for an LRU that would fly away. I think I have the credit for the very first Boeing Linux-based LRU, and it was not IFE, it was deeper into the system than that. And I said to the chief engineer, what about security? This stuff has the security shelf life of market produce. In fact, sometimes not even that, right? Barely lands before it's got holes. He said, well, we've got gates, guards, guns, security, all that thing. We have background checks, heavily trained people. We've got an entire supply chain. We don't have to worry about security. That was back in the early 2000s. Okay, that is not the case now. So we only had to worry about back then just creating a design, having your shall statements, making sure they're all testable, you're good to go. Now we actually have to worry about things like supply chain attacks and insider attacks and all those things. So it's almost like a trust no one kind of thing. Now we have to worry about these things from the safety standpoint I'm calling cinder block problems. Smash through your carefully considered design. So when we think about bugs, a bug is always a violation of expectations. My mother's a very intelligent person, but she knows nothing about computers. And when she calls me baffled about a problem, that is actually not Apple's that is actually Apple's problem, or my job to educate her, but it has now violated her expectations. And she's not the only one. You sit in a room of kernel developers and they're arguing about what? False positives, right? You get all these bug reports and they're wasting their time, they're grinding their lives away on false positives because no one knows. It's all violations of expectations. So it really just depends on where you're coming from. Context is everything. In fact, it turns out a well-considered idea can now be a bug because it violates way too many expectations. Everybody hates it. It sucks. It's like that goofy little keyboard thing they used to have on the top of Macs that no one likes because the escape key is flat and it's driving me freaking insane, right? That is a bug as far as I'm concerned. So a security bug is just a violation of expected privilege, and a safety bug is really just a violation of the expected margin of safety. It's all just violations of expectations. So context is everything. Design must be clearly specified and testable. When I say I have a very clear design, the design is testable, I have now set up a set of expectations, and now I can test that set of expectations. It passes or it fails. You only have two choices. So that takes us to Our cinder block problems, a safe system is not necessarily secure. A secure system is not necessarily safe. They are mutually exclusive, okay? If you say I'm going to just take into account security and try to retrofit that in, you get into an arms race problem. A red team actor can take a hammer to your window, so you can make that window bulletproof. And now it becomes a lot heavier. And eventually I'm just going to bring in a tractor and keep on going until you've got a plane that can never take off, okay? So you can't ever win that arms race. The only thing you can do is not play the game. But what does that set us up for? Safety engineering concerns itself with what shall happen, provable statements. Security engineering concerns itself with what shall not happen. Why? Because humans are creative. You can't predict what humans are going to do. You can barely predict what the weather can do. We can bound weather. We can bound outside conditions. We know that we're not going to get 0 degrees Kelvin or 2,000 degrees Kelvin in the Earth's atmosphere, but we can say negative 200 to plus 200, depending on the circumstances, right? We know where those bounds are. Humans can go all over the map. So in that case, you're really talking about you shall not allow a human to get creative with my system? No, right? So we're calling those cinder blocks, smashing it through. So what are we saying here? Let's look back at our concept of design. This is what, when we're talking about requirements and assertions, this is really what we're talking about. At the highest level, we're talking about the big idea. I want to get someone from point A to point B. I want to throw 4 people in there, and I want to do it for 500 kilometers on a tank of gas. Okay? Those are your highest level requirements. Each of those are going to trace down to some level of greater detail till the very end. If you're in a really highly critical system, this level of detail, tier 5 in this case, is almost to the degree that someone can practically re-implement the code there. And that's why the punchline is, yeah, at the highest level of detail, requirements really is at the functional level, or even lower than that, at the sub-function level, depending on how you're doing it. Push that back up in an open source project, and you say, if I had a kernel with all the low-level requirements in it, now I've got a design that doesn't care about the Linux kernel. I can now trace to existing requirements in the kernel that carried along. Suddenly now that kernel comes baked, ready to go, usable within a safety critical system. And oh, by the way, that design has been scrutinized and tested by a lot of people who, you know, are grudgingly coming along with the idea that design is important. Okay, now I can take advantage of all that testing and all those artifacts that come with it, including test artifacts. Because now all the test rigs go, well, you have requirements. Can't I just test against those requirements? Voila, I have what I need. Now I can plug in all these things. Now we try to get all the other open source projects to follow along, starting with the kernel. When we talk about safety, we talk about hazard assessment. That means once I come up with my big idea, I go have hazard assessors say, okay, what could possibly happen here? And they're going to come up with a bunch of hazards. The road may be wet. You may not always have good visibility, all these kinds of things. So they'll throw in some requirements in tier 2. We call those derived requirements, to say, you need to take this into account at the tier 2 level. We're also going to do that nowadays with cinder block problems. We're going to go tell the cybersecurity people, let's do a threat assessment. Let's go figure out what our threats are. And they're going to do a similar thing. They're going to come at the tier 2 level. They're going to come up with some requirements to do some stuff, but the problem is, what do we say? Humans are creative, right? There's only so much you can do once they get past the guards and the guns and all that kind of stuff, okay? And that means you now have the effect of a cinder block comes smashing through your requirements and says, a whole section of these, now that I've realized this reality exists, I can't do this anymore. I cannot do certain things now that I realize this reality exists. In aerospace, we have something called FOD, foreign object damage. Okay, that's like someone finds a hammer in a turbine or something like that. It causes a lot of damage. This is sort of a FOD expression in your design. It smashes through, and you realize now your designs are necessarily much more limited because of this problem. So, in deference to you, Steve, I'm bringing this problem to this learned group. What do we do here? We don't have good ways of solving this problem now that we realize that cybersecurity group is going to say, I just can't find a way to turn don't let a human do this into a shall statement. I can't put shall not in this architecture. It won't work. I can't test that. When I test my implementation, when I test the tier 5 requirements, because of the traceability, I can just take credit for 4, 3, 2, and 1 automatically. I cannot test a shall not. You cannot prove to me that I don't have a Lincoln penny floating somewhere out in the universe, because you'd have to go check every spot in the universe. And then I'll just move the goalpost and say, well, I transported it somewhere else while you're not looking. You'll never win that game. Shall not is not provable. What do we do? Well, right now, I don't know. We're looking for ideas. So this is sort of a fake graph. Feature types, not feature quantity. This is sort of the greater number of feature types, cool things that you want to do as we get into autonomous driving and all these things that, what crazy person ever thought that humans were able to control 2-ton devices in closed formation on a highway? I don't know where we came up with that idea. We need to come up with things like that, or aids to driving and all that, but those are features we throw in computers on our deadly devices as a system becomes more critical. Because of these cinder block problems, because we can't turn security into a shell statement, we don't have ways of putting these features into these systems. What do? I don't know. I don't come here with these answers. That's what the mini conference is for. Okay? So is hardware separation, it's a lot of people would want to say, well, that's the gold standard. Let's do hardware separation. Is it really? Is it the gold standard? Because what happens? You have to connect systems together. The minute you get a system connected together, it's game over. Oh, I could just throw some IP tables firewall rules in there. I don't know about you, but when I throw a bunch of packets at something where I'm blocking 0/0, I'm pretty sure the interrupt counter still keeps going, right? So there's something hitting the CPU. So I can DOS a machine no matter how you lock it down. That's the system running your life support system, right? Think about that. Once you start connecting, I don't know that hardware separation really is the gold standard. In aerospace, we do have a thing called time and space separation, but it's a connected world, and when you want to do things, you're starting to combine things. Also, the other problem is aerospace is very low volume. It's a very difficult thing to sell when we say, let's just put it in a separate LRU and we'll do its own separate thing, even if you can get past the connectivity. And in a lifetime of an aircraft, it'll do as much as automotive did with just the time I'm talking in the number of units that go out with automotive. But the same thing applies to automotive and every other safety environment as well. It's got to be very reliable and easy to fix too. So with a car, no one wants to be able to have their car in the shop for a long time. So if you make this really complex and hard to maintain, hard to get at, it's going to be problematic. And of course, power and cooling is very limited no matter where you go, especially in movable devices. So is hardware separation the right solution? I don't know. I don't think so. So ideas, like I said, we have to have time and space partitioning. You guys all understand the implications of connectivity. We got to have interconnectivity because systems have to talk to systems and become bigger systems. At that point, I just have to prostrate myself on the learned body and say, what can we do? How do we deal with all these shall not problems in what has to be an invariant? We can't. Alan Turing ruined it for all of us in the 1930s by saying we can't have a general way of proving anything. So we're stuck with that reality. We can't add features that we need, and I'm not willing to be artificially limited, right? We got to have ways of solving this problem. So I hand it over to you guys. What can we do?
Thank you.
Thank you.
So the key issue here is, in my opinion, is that at the end of the day, the implementation is only one. So the design is only one.
Yeah, design is only one. You don't get two designs.
Exactly. And must accommodate both security and safety requirements.
Yeah, party's over.
Right. So usually, the way, I don't know, from my past experience, let's say, my experience is Linux, right? Also in the safety domain. So what we did is that, we kept them separate in terms of requirement. Mm-hmm. We had the security guys working on the security solution. Then if the implementation of the security solution was also intersecting the safety scope, then the implementation had to meet the systematic capability requirement to also meet the safety requirement. And
just like that, when the safety team gives us requirements, we got lucky, they didn't smash through. They go at tier 2. The rest of the engineers don't even know that those are safety and hazard requirements. So they derive down to tier 3, tier 4, tier 5. By the time you get to tier 5, I have no idea where that requirement came from. It all derives down, and that's the way you want it. You want it to be gracefully in there rather than someone bolt on something at the end. So that's why you do it in a tiered fashion that way.
So let me go turn it around on you.
Please.
What is your request?
My request is this graph right here, okay? There's a lot of feature types that as you increase the system criticality, there's stuff we just can't do. And I understand the reality. We got to lower our attack surfaces. We got to keep the aperture small.
So is this, okay, so which one are you want to focus on right now, safety or security? So let's go from a security point of view.
I want to focus on the impact of security on safety.
So basically you're saying like we could define requirements that like for, let's just look at the safety point of view. This is where you would case or something like that. But let's just like look at one of the things that safety would be, or not safety, security point of view would be copy from user.
Sure.
Copy from user, copy to user. There we have a very strict requirements in the kernel that we actually easily define. Everyone, it's almost like tribal knowledge. Now, is this something that you want to have like a formal way of defining something like that? So starting with that simple thing, do you want to have, say, something, the copy from user is, this is the requirements of the use cases of it. So like right now we're working, I'll throw in a new thing that we're developing right now, S-frames, which is a way to do a stack walk through user space.
Yes.
And we're doing this by taking user space memory that defines us how to walk that stack. The first thing I did when I looked at Josh's patches was I found 2 cases that I said, oh, you really expect the user space to have this sorted.
I don't know if that's a valid assumption.
Right, no, it was, that's, no, the code expected it sorted.
Right.
That was incorrect. So like I said, okay, so basically from, here's like I said, asking for you. Like I know I have requirements that I need. Now the question is, how is this to be articulated? How is this to be documented? How is this, I mean, I don't know.
Well, no, that's a great question. I mean, some of it is, if we get a very clear design and we prove it up, then we may actually get more leeway from the regulators. Like the open source community has figured out how to define their design really, really well and make it testable, and copy from and copy to is very clearly shown, and we can show evidence of that. That will expand the envelope of possible types. So that is one example of, yes, that would help if we could show evidence of design and evidence of testability.
But the thing is, the Linux kernel is so effing big. I mean, yeah, that's one little thing, but every single aspect, every single system call, there's, that's just.
Think of it this way. No, I agree. And think of it this way.
I think
there's a vested interest. There's a vested interest to use open source software to do very complex and safety critical things. If we achieve that, you're going to attract goodwill and value from the organizations who are currently finding other ways to solve those problems, right? Why not focus our attention and goodwill on the open source community instead of going to other places who solve those problems? So you're, in other words, creating a greater market for open source software in that sense.
I'd also say that there are certain parts that have more sensitivity of the kernel than others, and there are certain configs that have more sensitivity than others. And so starting with the pieces that people care about the most and starting to show a pattern may be a way. And quite frankly, because of the rate of change of the kernel, we need to take and use the same methodologies that we do for contributing code to contributing the analysis upstream. So we need to get the people who need to spend the time for their own business reasons to contribute their analysis in a way that others can benefit, and we can basically keep up with the pace of code.
And it doesn't become a one-off. You know that the investment in that analysis time is contributory rather than thrown away.
One thing from my experience, case by case, at the end, the safety scope of each application will be reflected in just a small piece of the Linux kernel. So we don't need to take care of everything.
So actually, yes, exactly. Actually, Linus Torvalds once said, when someone was talking about the provability of the kernel for, actually, I don't know if it was safety critical systems or whatnot. He said, actuality goes, yes, the Linux kernel has several millions of lines of code, but what actually executes on your machine is actually a small subset of it. Now, the thing is, now you find the traceability, maybe even the function tracer or something like that could probably help out to say, you run your system, you find this, and then find a way to make the rest of the code like not executable. So if you hit it, you crash, boom. And then you could actually go through, and that's at least, so the question is, you need people to do that work, then maybe come back and say, get help to say, this is what we need to focus on. Did you want to?
And like a moth to flame, you're drawing in other resources of interested parties who need that.
Yeah, so basically building up from some common places and then extending beyond is probably the only sane path here. And certainly the thing is that once we have the traceability linked to the testing, those parts that have had that testability linked, when there's a security fix, they will have confidence that they have basically addressed and not caused regression. And quite frankly, those parts will probably have a better understanding of their design, so there'll be less side effects emerging, which will hopefully make things better in the long run.
And in reality, we want a degree of independence between the developer of the code and those who are responsible for interpreting the code down to requirements. It shows disconnect. It shows someone has done the thinking and communicated that. You can get buy-off from the developer. We'd love to find out that there's buy-off from the developer. Stop you in the hallway at the conference and say, is this really what you meant? Because this is what I put in requirements. That's going to be a huge thing. Then you can show that. And then that attracts a lot of interest from those who need those requirements. Suddenly there's a lot more people showing up in the open source community because of that.
And I would actually hope that, unless there's someone else who wants to say something.
And I'll just end at the trend, at least here in Europe, is for longer maintenance cycles on products, like 10 years.
10 years, Chromebooks are supported for 10 years today.
Yeah, and so dealing with vulnerabilities 9 years in on those Chromebooks, you really need to be able to have fully reproducible builds, and you need to know exactly what's done effectively, which is required. Yeah, I'd say the
hardware may not last for 10 years that we're supporting something that we don't own anymore.
You're not the only company like that.
And that's why we're looking at these things as systems too, quite frankly. But yeah, but I think, like I say, these longer support cycles we're getting pushed towards by the market are going to need these types of automation. Okay, so I'll shut up now.
Thank you very much for your time and attention.
Kernel design documentation.
Yep.
You go.
Okay. So, right. Thank you so much. In this session, we'll talk about, possibly improving kernel design documentation and involving the experts. So as Nicole said earlier, in functional safety, there is a lot of documentation. Now, in this session, actually, I want to take a step back. I will talk about quality, not about functional safety, okay? So I will lower the bar a bit, okay? A bit, okay, to make life easier. About myself, I'm Gabriele Paoloni. I work at Red Hat. And, I'm also, the chairman of the governing board in ELISA. And I have a sort of mixed background between functional safety and Linux kernel development, okay? And so the agenda, so we'll see how we ended up here, why documentation is important, the aspects to be documented, what we have in Linux today, and how it maps to the different aspects, and finally, we'll have an open discussion where, to be honest, I would like to spend most of this time to discuss with you, the maintainers. So there are quite a few many here that I can see. What we can do, right? Okay, so how we ended up here. There is a work in progress in the ELISA Safety Architecture Working Group that I lead, where we are basically putting together a document explaining, what we need to document and what we have in the Linux kernel today. This is still a work in progress, and I hope that soon we'll come up with a pull request for the ELISA GitHub. Okay, now let's talk about quality. So the principles behind quality are pretty simple. So the first one is that we need to define what is the expected behavior of our code. And the second principle is that we need to provide enough evidences to demonstrate that the code behave as documented, as expected. So it's pretty easy. Sorry, I skipped the slides. Okay, now the other question is, how does the documentation support the quality key principles? So now, here there are three different aspects. So the first one is the integrator. Okay, so if I am an integrator, I need to rely on the documentation to understand what to expect from the code and to assess if the code is able to satisfy my requirements. Okay. Then there is the developer's point of view. From a developer perspective, indeed, if they need to write patches, if there is documentation, they can assess their code against the documented expected behavior. Otherwise, they need to read the code and figure out if their patch effectively comply with the purpose of that code. And from the tester point of view, the tester, they need to design and run verification measure on the basis of the documented expected behavior, because otherwise the tester will write tests according to what the code does, and that could lead to biased results, right? So, and these are where documentation plays an important role with respect to the quality key principles. Okay, now from a software architectural design point of view, what are the main aspects that must be documented? So there are different aspects, different categories. So the first one is the static design aspects, where we should describe the main components and the requirements or specification allocated to them, software hardware interfaces, software hardware resources. Then we have the dynamic design aspects, where theoretically we should describe the chain of events and behavior, the logical sequence of data processing, control flow, data flow, and temporal constraints. And finally, there is any compile time or runtime parameter that impact the above mentioned behavior and aspects. Good. So what do we have in Linux today? Okay, so now with respect to the main components, indeed, from the integrator point of view, we do have different documentation available. We do have, the Linux man page project, the Linux kernel user space API guide, the Linux kernel users and administration guide, and also finally the GNU C library reference manual. And also, with respect, if an integrator needs to write, an out-of-tree driver, there should be, the documentation for the exported kernel symbols. Okay. And from a developer's point of view, we see that, the kernel is naturally divided into drivers and subsystems in the maintainers file, where, we can also see who is the guy maintaining, each of them. And also there are guidelines where Jonathan played a big role, I believe, that describe, how to document the most relevant, APIs of such drivers and subsystems. And finally, we do have Cregit, that is, a web-based tool that can be used to retrieve the mailing list discussion and also the cover letter, in case, we really want to drill down into a single function and we want to rebuild the history and understand, what the code, what is the rationale behind that specific code. Now, in terms of software-hardware interfaces, from the integrator point of view, I think these are already covered by the previous slide. From the developer point of view, today, as far as I know, we don't have much of description between dependencies, between the different subsystems and drivers. In some previous talk, I think Alessandro Carminati, right? He presented KSNAV, that is a tool that can be used, to fill that gap. If you want to analyze the Linux kernel in the context of a specific API to retrieve the dependencies between subsystems, KSNAV is able to do that. Also, we do have the firmware interfaces that are documented in the device tree bindings documentation, as well as in the ACPI specification, depending on which one you are working on. And then we go to software and hardware resources. Here we have, from the integrator point of view, this is already covered in the user space documentation. From a developer perspective, there is, a documentation to document the critical data structure, the member documentation template. However, today, such a template does not enforce, specifying which subsystem or driver use a certain data structure. So, if you want to visualize, which subsystems drivers are using a specific data structure, also for that case, KSNAV could be used. Now, with respect to dynamic design aspects, today I don't think there is nothing enforcing to document such aspects in the Linux kernel documentation. From what I found, the overview section of the driver subsystem, can be a possible place where such aspect could be, documented. With respect to compile time and runtime configuration parameters, this is still a to-do on our side, so we still need to go through that aspect. So, so to summarize, basically, today we do have tools that can be used to document or reverse engineer the code to cover the requirement specification, the static design aspects, and dynamic design aspects. Now, but the question is, what is the current status of the documentation in that regard, right? So, I mean, we did some analysis, and right now our analysis was restricted to to the exported kernel symbol, and even limiting the analysis to this, there were many gaps. So now I think it's a known issue, right? So now the question is, what can we do? So first of all, I want to make a disclaimer, okay? So I'm not asking the maintainer to write the documentation, right? That would be crazy, okay? So my question is, what can we do to improve the documentation that could also be acceptable from a community development point of view, right? Something that could not, basically something that maybe will not put a burden that that is unacceptable, right? So today, here I've listed down a few ideas that that came to my mind before plumbers. Maybe some modification to check patch to warn a contributor to also push documentation update. Also, another point to think about, improving the sync process between the kernel internal changes and the man page or the glibc manual.
Yeah, we have a process.
Okay, thanks.
Just a second.
So on the user space interface side, any modification or extension of a syscall or introduction of a new syscall requires a man page change or a new main page. Unfortunately, the problem is right now that we do not have a man page maintainer anymore.
Yeah, I saw that.
Yeah, I mean, this is a larger problem because we do not have people paid for caring about documentation either. So this is mostly a resource problem because the individual developers and maintainers are not the people who should write documentation in the first place. Right. So we really need a documentation team for that, and somebody has to whip up the funding for it, or provide the people who actually can do that. I mean, there's several gaps in that area which need to be addressed, and this is the usual janitorial work nobody is interested in to do, but also nobody is interested in to fund, up to the point where everything breaks apart and then panic occurs.
You're like kind of getting on. Weren't we just asking or talking about this, I mean, just a few months ago at the tab, about having funding from like working with the Linux Foundation to come up with something? Because this is something that, like, basically a lot of times no single company wants to like spend the whole thing. So you kind of need a collaboration. So kind of have another documentation project. Well,
so, I mean, we have gotten a bit of support from the Linux Foundation in an effort to try to improve the documentation in a specific area. It was trying to help those benighted developers who just can't figure out kernfs and and need some help. It's had a bit of a rough road. It's really hard to bring someone from the outside and expect them to document something internal like that. So we haven't yet begun to solve that problem, even though some effort has been made to do it. With regard to man pages and all that, we may have a policy that says things require man page changes. We don't actually do them, not very often. And I often see man pages being fixed up by people in the glibc community or something like that. Somebody's trying to fill that in and do it. So we're not as good about that as I think we should be.
Subsystem problem.
Well, most things are.
especially when it comes to system calls. One thing, okay, so for trace command, I make sure all my libraries are man page or have a man page to it, just for my own personal thing, and you can easily forget. So actually, I modified my make files to fail the build if I don't have a man page for something that's exported. So I have to have a man page for everything. Now, if we made the kernel compilers that if you added a system call that doesn't have a man page, it doesn't build, we could actually have the compiler
fix problems pretty fast.
Yeah.
But for that, man pages would have to be in the kernel sources as well, which they are not right now. And I think the even more important thing is make the man pages part of the submission of the syscall or syscall extension. I think that's a lot of people asking for. And yes, Jonathan also looks a bit crazy. But I know there are reasons against it, but I think that works well for quite a lot of other free and open source projects.
One aspect that we can't overlook here is that the kernel interface as exported, I mean, the syscall interface as exported by the kernel is not necessarily what user applications will be calling, right? There is a layer in the middle there. And so the writing of these man pages requires cooperation with the glibc people because often what the interface they make available is not what the kernel makes available. It's got a whole layer of stuff around it. That part has actually worked better in recent times than in past. There's a couple of people in the GLibC community who are very interested in actually, first of all, actually making wrappers for our new system calls, which wasn't always the case, but also having the documentation to go with it, because the GLibC people are pretty insistent on that.
Instead of actually having just actual man pages into, maybe we could just have our own form, like some sort of like RST or something format that basically just describes that. So you have to get it in, you just have to have a description of it that some tool could just create a man page for, but it won't be the default man pages like glibc wants to do its man pages, it has its own man pages, but just to have something that's documented that can be used for man pages.
New format.
And I know you are loving that. Wait, did you?
Regardless of format, it seems like it would make sense for the kernel to document what its own system calls are, and glibc can deal with documenting whatever changes it makes in its own documentation.
That has actually been handled in the man pages project when we have people who are able to put time into it. If there's section 2, which is what the kernel does, and section 3, which is what the library does. So that has been handled to an extent so far, but again, the kernel could be better documenting its own interfaces, what it's providing, and we haven't been doing that.
Actually done an audit to see where the gaps are these days between what is documented and what is not, what's missing? Has anyone actually done a run through? So we don't know how badly we're broken right now, if at all.
Going back, okay, so if we actually created our own format, this actually goes back to the previous talk. Now you have a way to automate something that could read a format that's this is not only does it man page, but basically describing what this does. You could maybe perhaps have some sort of automated thing to look at it to create a test to make sure that that system call actually does what it's saying here.
Yeah, that's the ultimate goal when we are working on the SPDX safety model to come up with exportable format that we can create requirements, et cetera, which would fit into what you're describing here. It's not up to the maintainer to maintain that, but a patch rolls into the kernel, that's going to trigger an expiration notice to say, hey, you probably need to go look at that code because the requirement may or may not apply, and that will then engage a design process to say, do I really understand what this is, and can I make sure the requirement still matches what I think it does? It requires that. And as industry uses, as more safety critical industry uses this stuff, you're going to get more interest from those consumers of those requirements. You're drawing in a lot of interest when you do that.
A lot of notifications then.
Yeah, but like I said, if we have it automated so we can actually do a test, so you make tests to that. So you actually like the self-test or something. Once, if a patch comes in, suddenly you're going to get reports saying that this system call is broken.
Yep. On the other side, we also need, the maintainers' active involvement, because if you have a new features, that is not, that will not be caught by the regressions, right? So.
About new features, I think we at least with my experience with time, we are doing better or requiring documentation pages together with the actual feature that gets introduced to the kernel, and I think we should be more strict about it. And the other thing is that I feel lots of the information that is actually there in the process of getting the new feature in gets lost. Most of the time, I guess, thanks to John and the team, we are having that documented somewhere because he's documenting actually the process, which is also what we refer to in like in the future. If we can capture that like more automatically, or we can find a way to make that part of the documentation, I think we'll help in the end.
But actually, just come to think of it, is this on?
Yeah.
Okay, just come to think of this, with the S framework, we need to create a new system call, and we're about to do this, and I'm just thinking, I don't even know where to put the documentation. So we're going to create a system call now, and now we're just going to add to the problem because I have no idea, like, okay, who do I talk to? I'm going to create a system call.
So actually, that documentation needs to be at the source code next to the system call. The problem with that is that we do not have something which actually makes that a format. So we have to come up with something. Here is how you have to format your documentation. Because if you look at the kernel doc right now, the only thing which is enforced is the parameters, the arguments documentation, but then anything else is random, whatever the developer thinks is nice. So we have to come up with better templates, and enforce the templates, because then you can put it next to the code, and that's where it belongs. I fundamentally hate the documentation, high-level documentation, which gives you an overview on the 3,000-meter high flight level. This is where we should go in documentation, yes. But documentation of a particular interface, whether it's kernel, internal, or syscall, needs to be at the code and not at some random other place. And when we have that enforced for syscalls, it's a specific format, then we can, the man page people can extract that and validate against that.
That's why we recognize when everybody says, don't make the maintainers do this. Correct. What you just described there is a skill. Okay? Peter Zylstra is really good with schedulers. That is a skill. Coming up with this documentation in the right format with all the right information and reasoning through how it would look as a requirement, that kind of thing. That is a specific skill. That is a specific maintainer's job. That is why independence is necessary for this, for it to actually work.
Right.
Yeah.
And I think I completely agree it should be near the code. I don't think it should be in the code.
It should not be.
No. Actually, no.
But it should not be embedded in the code.
No. I actually disagree with this.
You think it should be in the code? Okay.
I think it should be. I agree with because I know what Thomas is saying. Because what happens is it's like the kernel. You have it there right with that, and any modification is. Closer the documentation is to the code, the more likely it gets updated with the code.
We agree. But is that a recipe for failure?
No.
Okay.
No?
Okay. First of all. Okay. First of all, my experience says that the assumption that having the documentation next to the code will get the documentation updated is charmingly optimistic. It does happen, but not all the time. But I really question this with regard to something like a system call interface. If you're changing a system call interface, you're going to have to change all kinds of things in various other places, including tests and so on. You're changing something that's externally visible, right? If you can't go outside of the code for that, I think you're not looking far enough afield anyway. So I would question that in particular. For API documentation, yeah, fine. I think that's the fine place for it. For something like system calls, I think you need to be a bit more formal and with a bit more of a defined process.
But I would love to see the kernel doc format, or having more checks and rules for the kernel doc that we have, in particular to the exported symbols. Because we have quite a few bugs that sneak in where people are checking the wrong return values, where it's null, but or we get 0, but it should be checked against a negative value and so on. And oftentimes you do a C-scope jump or something, and the information you're looking for is missing in the kernel doc. So if we had some enforcement on the kernel doc style, maybe in check patch or something like that, then it would be more convenient for people to add that after a couple of issues like that. So I'd be happy to contribute as we go, and would love to have some support for enforcing that.
A lot of these things should be covered by tooling. That's the only way to actually bring people to do it. Because if the tool yells at them, then, and it gives maintainers the leverage, hey, the continuous integration of your patch showed this failure, go and make your homework. And I don't even have to do anything about it because all the people submitting patches to me know if the continuous integration fails, I'm not looking at it. No, I mean, why would I look at it if it doesn't even compile? So, and we can't do the same thing in forms of documentation formats or missing documentation or whatever. The one thing I learned very, very early on when I started working on preempt RT, tools are a key. And everything else is just wishful thinking. You can build so much rules. If you can't enforce them by tooling, they are completely useless.
If we do have like okay, so I'll take your point. Yes, system calls for being more formal, but we need to have a formal process that's easy to find. That's one of the things that, like I said, I don't know where to start. Is there a process right now? So basically the problem is we don't have a process.
We want to roll one out. So
Right.
we want to roll one out. We're just sitting around the table. We're like, well, no one's going to let us put requirements in code, that documentation in code. And now, are you? I mean, who should we involve in this conversation when we do this?
I mean, we could.
Yeah.
You could put documentation in the code. Maybe, like I said, documentation man pages. I don't know if you, or system call interface. I don't know. Maybe a place like a single location where it's easy to find. Right now, I went to look like for like adding real-time stuff. I have no idea where to put it. Like, you know, I'm looking. It's the document directory. I don't envy you. It's so much data. How do you organize having, a fire hose of data, and like there's so much document, and people say, well, there's no documentation. I mean, I actually just skimmed through a few times. I found like a few golden nuggets, like, wow, I never knew this existed. But
let's be clear here. We're talking more about formal definition than we are narrative documentation. I love your documentation. I sit there and read it. It's interesting to read, but it's not formal definition. I can't hand that over to my regulator and say, here's my requirements. Oh, sorry. Sorry.
Yeah, actually, I can override with this. Yeah. But anyway, so okay. So no, I think. So thank you for the discussion. So basically, correct me if I'm wrong, but what we agreed on is that first we need to conceptualize a documentation template, a format, basically, right? The first thing that can be used to to better document kernel APIs, and maybe another one for the syscalls for the user API. And the second thing is, from a process point of view, we need to figure out what we can do. Maybe with one option is with check patch, for example, right? So if
No.
Huh?
No, not
okay,
check patch itself.
A separate. Sorry.
Yeah.
Create a separate tool which can be run by CIs. A separate tool which can be run by CIs. Checkpatch tries to be a Swiss Army knife, and it does nothing wrong. Right. It gets most of the stuff wrong, and it's a pain to work with. Follow the Unix philosophy, have one tool which does the one job right, and don't try to create the Swiss Army knife thing.
Okay.
It's a design fail from day one, and it gets you nowhere, because you can gradually introduce new checkers which you expose to the CIs, and they will catch the thing and notify the people. And we need to go step by step in a gradual approach. So don't try to over-engineer this. Start easy from a manageable, handleable point of view, add the tooling, and we move from there. And then we can catch up to the next step. That's the only way it works. I mean, I think I have some experience on that. Sorry.
I just wanted to add, while you're thinking about this, system calls are not the only ABI from the kernel. Okay, there is a huge range of stuff in /proc, /sys, all that. That is a crucial part of the kernel interface. For things like /sys, there is actually, for the sysfs part of it, There is a formal mechanism for documenting it. It's not in the code and should be. But you have Greg trying to force people to keep up to it. That I think you could try to automate fairly well. You have a reasonably well-defined interface, and you could try to automate it. Yeah. And that would be a very useful thing to do, and I think would be fairly universally appreciated.
I didn't realize that. Yeah.
Oh, by the way, it's great that we have this discussion with this group here, but too bad. This sounds like a maintainer's topic.
Only if the maintainers understand we're not putting more work on them. No. I really want to jump in and make sure that's clear.
I'm saying, what?
That's why I suggested start with some easy to tackle thing. Provide the tool which provides the checking and says, hey, this sucks. Then you can point people to it, and it's not getting a maintenance problem. Yeah. I think the discussion is, won't be a big discussion if stuff gets proper templates and proper, hey, here is the document, how to deal with the template, and a tool which enforces it. Nobody will yell at you. Okay. I mean, you might get some answers. You figured this out, can you fix it, please? But, I mean, that's obvious. But
what about concerns? Somebody says, well, you're just going to add a bunch of comments into the code. You're going to bloat it up. I mean, what's the obvious response? I don't know what the response to that is.
No one complains about too much comments. Okay, you're right.
So if somebody complains about too much comment in the code, send him my way.
Oh, great.
Can you fix Peter for me?
My code is almost 50% comment.
Could there be some agreed upon format for just like putting a reference to some other file or something like that? I mean, I can imagine that, like for man pages, you want the man page to have 100 lines of information, right? So it doesn't really seem suitable to put in line with the code. But if there was like a forced link to some other place, then one could easily check that the right information is in that other place.
And in our rendered documentation, the web version of the documentation is very easy to link. I mean, you just name a file and it makes a link to it. You name a function, it makes a link to the documentation for the function. That all works fairly well. Again, the man pages aren't a part of that. One could think about trying to integrate such things. But in general, we have the machinery to do that now. And that's why we have Sphinx, is to be able to do things like that.
What about stale links?
What about stale links, you said? We have some, I mean, Sphinx will warn about that. We have some other tools that will do it. Some of that stuff comes out of Linux Next now, because they do docs builds in Linux Next, which was a wonderful, speaking of getting the tooling to help us, that has done a lot to reduce warnings in the documentation, because if somebody introduces one, they get a nifty little note from Steve Rothwell and are encouraged to fix it.
Since I keep about you repeat what you say. What about for Julia's links in the code, like comments? If we have links and comments, then you have still links.
I mean, links in the comments, if those comments are built into the documentation, right? You can do design documentation, all that in the comments, and have it pulled into the rendered stuff quite nicely. That works. If you just have a random comment somewhere, nothing's checking that, no. Although we do have a tool for stale file links actually that will grep the tree for that. There's something in scripts that will do that.
As the ELISA team is busy working on doing their analysis and putting things up and figuring things out, I think what I'm hearing is we need to come up with some templates for the documentation for these areas, and then basically start to put in, have the tooling in place.
And the tooling.
The tooling in place. Step by step. Templates? Yeah, well, let's and quite frankly, having an example in front of you makes you do it right, okay? So that's why I'm saying we've got examples, we've done work here. can we figure out how to figure out what template we need? So the question in my mind now is, okay, who are the reviewers of the potential template that would want to weigh in on it? And then we put the tooling. Obviously, John, yes, but is there any, you also, or not? Yeah, okay. You're volunteering too, Thomas? Thank you.
Thank you.
Okay, so if we can get you guys basically saying, yeah, you're getting close, or no, you're off, then we can start to look at putting the templates in place and then the tooling around it, and then we start upstreaming the pieces that we've been doing the analysis of into these areas, and then that way we're starting to move the ball forward a little bit.
This, but yes, see me too.
Oh, Steve. Thanks, Steve. Yeah.
I was just going to suggest you might actually consider starting with the SysFS side of it, just because it's relatively simple in a sense, and because it's already halfway done. So it might not be that big of a stretch to get to something that you can verify and make the tooling enforce and all that. It might be a really relatively easy first step.
Yeah, I agree. No, with a new template, you can convert the existing documentation into the new
into the template once we get something there. And if we wanted to, with that template, start to refer to things in kernel CI, can we look at that, or should we just focus on this part first and then start to figure out that when you know how you test what we've documented effectively, getting that linkage and working with the kernel CI folks are heading in this direction anyhow, and so how do we basically connect those two? But I think let's, to your point, focus on getting the template first, then focus on the second part.
If you have the script with it, so once, if you have the script or the tool, the checker tool with it, make sure it's something which is simple and usable and doesn't require to install thousands strange libraries. Then the script goes into kernel, into tools, and then you add into the testing or whatever section a run script which invokes the tool. And then you can ask the kernel CI people, please run this once a week, and they are happy to do that. So there's enough tests and checking things which are only run periodically and not every day, but that's good enough for a start, and they are easy to deal with.
And I guess with that, we'll end this down because the discussion I was hoping to have.
Yeah, I think now I understand why this was the last session, by the way. And no, I mean, thank you so much, guys. I mean, this is really great. I mean, great discussion, and thank you for your guidance on the next steps, really. So, thank you.
Did you give out your chocolates?
Oh, yes.
I actually have one extra one if you want to give it. I'm shutting this off because I downloaded this. I shared. Get a chocolate. Yes. I'm turning this off, right? I download the shared notes into, if there was any shared notes for the room. What? Yeah, but I saved it. I saved it in here, so hopefully I saved it. I'm killing this.
There's some more concrete examples of what instead of like just a bunch of like graphs.
Yeah. Bye-bye. Hopefully everyone remembers to take the
How complicated is that?
Yeah, I think that is something we could use that one. Someone's phone?
That was very good. Well, it was the best possible result I could have hoped for. I mean, we were really racking our brains to figure out. We need to not, it's not documentation, we need formal definition. We need to know what